Hello and good morning to day 2 of performance.now. Woohoo! Welcome back. Did everybody have a great day yesterday? Yeah. I don't know about you, but like my brain was like absolutely fizzing overnight thinking about all the things that I want to do when I get back to work next week. So I'm Katie Sylor-Miller. I am not Tim, but don't worry, Tim's coming back out again shortly. So just a couple of reminders and housekeeping things before we kick things off. We have a code of conduct. The shortest summary of that is just be nice to each other. There's a way to report if you see people breaking the code of conduct. If you go to the Perf.now website, there's a form. You can grab Karlijn or you can grab PPK and report things. The Pac-Man rule, although I'm going to call it the Ms. Pac-Man rule today because Ms. Pac-Man is objectively a better video game than the original Pac-Man. So today we're following the Ms. Pac-Man rule, which is when you're standing in a group and chatting, make sure that you always leave an opening for someone new to walk up and say hello and join the conversation. All right. Next, we want to say thank you to all of our sponsors. All of us probably would not be here today if it weren't for the generous financial support of all of these companies. Do us all a favor, make sure that you go by their booths, make sure that you're talking to them, say thank you for the stroopwafels, say thank you for the barista, because without them, we truly couldn't have this wonderful event that we have every year for our entire community, so thank you. Yeah. Another reminder, just please don't bring the glass cups downstairs when you bring your beverages down. Grab a paper cup, they're at the top of all of the stairs. We just don't want the cups getting knocked over and making a lot of noise or shattering and hurting people. Turn off your phones, turn off the sound, please. Disable your Dropbox and your Google Drive. Bless you, Mandy. The Wi-Fi is for everyone, so let's not take it over with syncing files and things like that. There's toilets in the back. There aren't a lot of them, so please be kind to others and keep your time interactive in there low. There's a cloakroom in the back. It is unguarded, so don't leave any of your valuables there. The Wi-Fi is performance.now 2024. Password is Akamai 2024 because our Wi-Fi is very generously being sponsored by Akamai. If you want to take a picture, take a picture. We're doing a live stream, so hi everybody watching the live stream. Hi Bert back there running the live stream. It's going to be on YouTube, and you know my kids, when they found out that I was going to be a live stream on YouTube today, were like, "Oh my God, Mom, you're famous!" Because like, you know, when you're like a preteen, YouTube is like the height of like fame to them. The hashtag, if you have any questions, is perf.now. We'll be monitoring Mastodon and Blue Sky, so if you have questions that you would like me to ask during the Q&A, you know, skeet them, toot them, tweet them, and we'll be monitoring those, and I'll be putting them together and kind of organizing the Q&A questions. Oh, also for Blue Sky, because that seems to be where all of tech Twitter is going these days, we have a starter pack that you can follow that has all of the speakers on it. So if you want to continue the conversation after the conference, that's probably going to be your best way to do that. All right, so I think that's everything that I needed to cover. So now I'm going to welcome Tim Kadlec back out on stage. So Tim, I met for the first time 7 or 8 years ago at Velocity Conference. And I just have to say, he may not be the tallest man in perf anymore, but he's definitely the kindest man in perf, unless he's talking about Andy Davies, in which case he's not so kind. But Tim is going to kick everything off for us today. I hope you enjoy it. Thank you.
Thanks, Katie. In my defense, Andy totally started that. No, and I can relate to anecdotally on the YouTube comment that struck me as funny. Has nothing to do with this talk. But we went into school with my kids in 5th grade, and they have like a board where all the kids are able to put like what they want to be when they grow up. I'm not even lying, like 60% of the kids put YouTuber as their career aspirations. So that's, it is a thing. All right, you know what I've never been like, don't you just hate it when it's like, it's in the morning, you just got in, you're kind of tired, and then the speaker has the gall to be like, hey, we're all going to do something together now? Like, isn't that the worst? I've never done that. We're going to do it today, all right? So I know it's early. I know it's day 2. I know there was a really nice party, thank you Speed Curve, last night. I'm also very aware that it is Amsterdam, and it is quite possible that some of you didn't even go to bed last night and just came straight here. But we're going to do it. I want to, something kind of simple, something just to get us all in sync, energized, fired up, and ready to go. Are we ready for this? Yeah, that's about how I thought it would sound. Okay. All right, on the count of 3, here's what we're going to do. Everybody's going to blink. Are we ready? Can we handle that? Okay. 1, 2, 3, blink. Everybody do it? A couple of you might have held out. All right, so everybody feeling good now? The energy's up and running? Like, that's good, right? Yeah, that's today's workout for us. Now, for most of you in the room, that probably took about 100 to 150 milliseconds. There is some data that suggests that maybe it can go as long as 400 milliseconds. I suspect that's for the people who were out until 4 a.m. in the morning. I think as long as you're bright, it's probably in that 100 to 150 millisecond range. That's not a very big number, but I think it's actually a very interesting one because there's a lot of connections to performance when we talk about that 100 millisecond threshold. For one, I've always been kind of fascinated by the number of studies that show the impact 100 milliseconds can have on a business. Walmart finding 100 milliseconds equaled a 1% increase in revenue. Zalando, who was mentioned yesterday, 100 milliseconds meant a 0.7% increase. Amazon actually found the same thing, but like in reverse, if you 100 milliseconds slower meant they lost 100%, so very similar to Walmart. And we also had Mobify back in the day talking about 100 milliseconds on a checkout page load time meant a 1.1% improvement in session conversion, leading to about $500,000 across all their properties annually. So it is a small number, but it is a meaningful number. Now, the other place we hear this brought up is when we talk about perception thresholds. And I know Alex had shown a little bit of that from Microsoft's guidelines yesterday. That 100 millisecond threshold is what we view as instantaneous, and this comes from a paper back in 1968 exploring the human response to digital interfaces. And so the author made the statement that no more than 0.1 seconds to have this instantaneous thing. Now, there's all sorts of reasons why there's some question marks as to the actual, is this really 100 milliseconds? How precise is that? But I'm going to gloss over those. What I thought was interesting, though, is you really don't have to read much further to see your first sign that, maybe this isn't in hard science. It's actually about a paragraph later. There we go, it's about a paragraph later. In 1968, he was already observing that, look, just so you know, this actually might be a little slow. This might be too slow for people who have more experience. So the idea here being that the more experience we have with it, the more we interact with it, the more comfortable we come with that system, the more we expect out of that. Did you know it only takes us about 13 milliseconds to process a visual image? That's it. If we flash an image in front of you on a screen, it takes you about 13 milliseconds, and you can recall most of what's going on. There's a certain limit, of course, to the fidelity of that, but that's all it takes. And that's a number that has gone down with recent studies over the years. It started off higher, it's been going down and down, partly maybe because of our precision and how we're able to measure it, but the other theory here is that we're just getting better at it. As we spend more time with digital interfaces and visual imagery, we just get better at processing that stuff. See, expectations aren't constant. They change. And as technology improves, our expectations of what that technology is, what that technology is capable of, and how that technology should behave changes as well. We hear that argument all the time about, devices getting faster, networks getting faster, and I feel like several people yesterday, Anna, Alex, did a really good job of sort of dispelling that, right? Like it's not evenly being distributed. But even let's just pretend that it is. Let's accept this premise for a second that technology is getting faster and faster, and this is what the reality of the situation is. There's two problems that occur when capabilities improve at a rapid pace like this. The first is Jevons paradox. The idea being that the more we have of a resource, the more we consume of the resource. Now, this was something that was first brought up in the context of coal consumption, but it's something we've seen play out with the number of cars on a road. It's things we've seen play out with technology. As we get more powerful devices, as we get more powerful networks, what do? We throw more things at them. The problem with this is that someone is always left holding the bag. Like, not everybody gets to benefit from this situation, right? There was a thread earlier this year, I believe on LinkedIn, where somebody was talking about how it was a waste of time to focus on performance, particularly on those low-end things. Like they were talking specifically about why they would ever test on like a low-end Android device. Why would they test on a 3G network? Because their users on 3G don't buy anything. And I just want to just break that apart for 1 second. They do not focus on improving the terrible performance on 3G networks of their site. Users do not buy anything on the 3G experience on their site. I wonder why that is. Someone is always left holding the bag. We don't all get to benefit from this situation. And it creates a little bit of a problem, right? Because if we're testing on those devices and we're having those fast experiences, I mean, that's why we start to accept that certain solutions become acceptable and appropriate for the web. I mean, you go back, the beginning of responsive design around that time, I was working on a project for a large US company. We had like 50 phones we were testing on. It was great times. And it was all based on their analytics. And a couple of their very popular BlackBerry devices were massively popular for going to their site. And what we found in testing was that, like, hey, even including jQuery on the site was enough to crash the browser on BlackBerry. That was it. Like, it didn't have to do a thing. Just the presence of it was enough to crash the entire thing. We had these built-in inherent constraints, and we were like, all right, well, we're going to have to be more creative. We're going to have to lean into the browser a lot more to make things happen. The only reason we ever kind of came to the conclusion that maybe we could get away with shoving a bunch of stuff and relying more and more on JavaScript is because some devices it was acceptable for. So we always have this paradox. We're going to throw more and more at technology as it gets better. The second bit that comes into play here is the hedonistic treadmill. This is usually applied in the concept of wealth, but the idea here is that as resources become more powerful, as they become more available, our expectations increase and they diminish our initial satisfaction. Again, wealth is the usual comparison, but I'm going to use like wine, right? All right, so you start off, you have your first red wine that you've ever had, and you're like, oh, this is not bad. I could get into red wine. Then you have another one, and it's a little bit better, and you're like, oh, I like that red wine. That was really good. The other stuff was kind of cheap. Then someone treats you to a really nice bottle one time, and you're like, oh, that is red wine. I don't know what the heck the other stuff is, but I'm not going back to it. And then the more you have of this, the more it stops being like this outer body experience. It just becomes like, oh, that's wine. That's what it is. Our expectations shift, and our satisfaction shifts as a result. I thought an interesting application of this in the last week at home was I was sitting down with my 7-year-old. My boys and I were big basketball fans. We like the San Antonio Spurs. That's how you know they're good kids. None of that Laker nonsense or anything like that. And their favorite player is Victor Wembanyama, 20-year-old guy out of France, 7'4", ridiculous talent. And so my son had been saving up some money, and he wanted to buy a Victor Wembanyama rookie card. So what we did is we went off to eBay and searched for Wembanyama, sorted by cheapest so that he could kind of find which ones he wanted to do. And then I just slid the laptop over in front of him and let him go. And so we started doing this. He started scrolling down. He would find a card that looked kind of interesting that he could afford. He'd click on it, take a peek, and then go back. It's the choice paralysis thing. He couldn't make up his mind. And everything about this was very normal, nothing absolutely out of the ordinary at all until we got to the pagination part. And we get to page 2, and he taps, and then he taps, and then he taps. Now, we've heard of rage clicks. This wasn't a rage click. This was the most calm rage click I've ever witnessed. But all of these taps happened within a couple hundred milliseconds. It was a small time period. And I was just like, hold on, buddy, just give it a second. You know, I sounded like basically what my father-in-law sounds like when I try to work on his computer in the middle of nowhere. But I was like, yeah, just give it a second. Like, I am a performance nut. I've been doing this for a long time. If anybody should get grumpy about, like, a pagination taking a while, it's me. But I thought it was fine. In fact, I'm pretty sure it would have passed every single threshold we have for a good experience. It was not a slow experience. But to my son, it was like, oh, there's nothing happening. Like, I'm doing something wrong or something's broken here. What's going on? So I thought about this, and I was like, why wasn't he freaking out about the listings? Like, this wasn't a problem until we got down there. And then it occurred to me that whenever he would click on a listing, what happens is we open in a new tab. And so when they do this, that's kind of flashing a little fast there, isn't it? We're going to pause on that. Whenever he does this, the response is instantaneous. The browser's doing a lot of heavy lifting. It's opening that new tab right away. And there's still time that has to happen for the page itself to come into display. But his feedback, the affordance that something occurred, going again back to some of the stuff Anna talked about, was immediate. Like, he immediately saw the impact of his what he was doing with that technology, with that interaction. And it occurred to me that, like, I have grown up with a very different set of expectations for what it means to use the web. I'm not quite as old as Grigsby, but, like, that same thing that he mentioned with the mosaic and the website sucking in his first experience of the internet being like, hey, this sucks and it's slow, that's not far off from where I was either. Like, dial-up modems and stuff, they were terrible. Like, you'd set it up, you'd start the connection, and then you'd go walk away and come back a few minutes later. You know, every page load was the same thing. My first phone was a Nokia that could barely get online. I live in the middle of nowhere, a small town of 1,200 people. I grew up in a town that was half that size. When everybody else was talking about 4G and how fast that was, we were sitting on 2G if we were lucky. It's usually some sort of an edge thing that happened to not quite be 2G caliber. We only recently, like probably within the last 12 to 15 months, got 5G for most of the area where I live in. And there's still parts where we go around and it's like it's just a dead zone. You're going to get maybe like some 3G equivalent if you're lucky. Like, I have learned patience. I have learned that, like, okay, look, it's not going to be very quick, it's not going to be very instantaneous, and it's just something I'm going to have to deal with. But my son hasn't learned that. My son's experience with technology has been primarily games. Very quick, very responsive feedback, instantaneous. When he is on the web, he's using a MacBook Pro. We've got a good connection at home. To him, the web should be like this. That's his expectation. Expectations are not constant. Expectations are learned through experience. And so as technology improves, our expectation of what we expect that technology to do and what we expect it to be capable of shifts as well. And so we're at this sort of interesting spot where I feel like we've got these two buckets. And now the situational performance is absolutely a thing. We don't all live in one of these buckets all the time, but these buckets, I think, are still helpful for thinking about the situation. On the one hand, we have sessions that are coming from those less than ideal situations, scenarios where maybe the device is taxed, maybe it's a lower end device or a cheaper device, maybe the network has intermittent connectivity, maybe we're roaming and we've got some sort of data throttling still going on, which is still a thing. We've got these less than ideal scenarios, and the web's not quite fast enough for them. On the other hand, we've got this new wave, this new generation, people coming up with technology where they're experiencing it on high-end devices and high-end networks, and they're coming in with these really high expectations for what we should be able to do on the web. And I worry a little bit. I do think we're settling a little bit into the middle here. Like, at the moment, I think the web operates in this sort of middle space where we're not quite fast enough for those in the less than ideal situations, and we're not quite fast enough to keep up with the rising expectations that we have from folks either. So I think we have an opportunity, though, to change this. And there's actually a couple reasons why I'm very, very optimistic that this is going to happen. First off, and it was brought up several times yesterday, but Core Web Vitals has been a massive success in getting an increased focus on performance. It wasn't that long ago where most of the performance conversations happened in side rooms on our own isolated events. And now you can't go to, if you have conferences that you're still going to, I know that's been a little slow coming back, there's always at least one performance talk. We asked people who was the first time here yesterday, and there's so many hands that shot up. We have all sorts of folks that are new to the community and new to performance. We have an absolute explosion of tools and monitoring that are being built around this and built around, the other initiatives that we've seen from Lighthouse and things like that. Like, we have more options than ever in this community. Core Web Vitals has been a huge, huge part of that. It's been opening up with the SEO carrot, opening up wallets, opening up budgets, and improving the interest. And I do worry a little bit sometimes that maybe there's like a risk of treating them like a checklist. I have seen situations where, we're like, all right, we're going to tick the box on these 3 metrics, and then we're good, and we're going to call it a day. I would just like to challenge, especially those of us in the room, to kind of consider Core Web Vitals. I feel like they are a better starting point than they are a finish line. Tammy brought up some really good stuff in her presentation yesterday where she was talking about, maybe your thresholds are going to be different. Maybe the impact for those metrics are different. Maybe we need to be looking at probably other metrics as well, especially, e-com sites. A large percentage of your mobile traffic is probably Safari. It's dominantly Safari for most e-com shops that I've worked with. So there is a need to go beyond it. So we got to be careful not to settle it, but as a whole, that initiative has been really, really successful in drawing interest. And so when we get this explosion of new people, we get this explosion of monitoring tools, we get this explosion of testing tools, we get this explosion of ideas, and I think that's incredibly healthy and powerful advantage that we have, because while we like to romanticize it sometimes, innovation very, very rarely comes from individuals. It comes from a collision of ideas. It comes from everybody bouncing things off of each other, seeing what each other are doing, and try to iterate and improve on top of that. And so I think we're poised for an explosion of innovation as we move forward in the next few years because we have this rapidly growing ecosystem. The second reason I'm really optimistic is I feel like in the last few years we're starting to see a return to the browser. We're seeing a bunch of new technologies and improvements happening that are making it easier and easier to do really impressive stuff without having to resort to extra layers of complexity. Last year when I was up, I mentioned fetch priority, which I believe, Robin threatened us with a sword if we didn't actually implement this thing. But I remember saying in my talk that fetch priority was it was incredible. The fact that we can get a several hundred millisecond boost from a single HTML attribute, that just doesn't happen. I was wrong. I was absolutely wrong. We've had a flurry of exciting improvements to the web that are all an attribute or a couple bytes of code, and that's it. We've got fetch priority for being able to put some emphasis on those images and stuff that we're loading. Yesterday, there was a lot of talk about the lazy loading attribute, being able to lazy load images without having to have 100 kilobytes of JavaScript. We've been doing that for years that way, and it's just a single attribute. Speculation rules, which is out there, is super exciting. This is, it's not a single attribute, but this little blob of JSON, what is this, a couple bytes, maybe a kilobyte? This little bit here is enough to say that anytime you go over and you hover any of the links on a page that are internal links, and it looks like they're about to interact with it, go ahead and pre-render that page in another tab, get a head start. This is, again, something where we've seen so many JavaScript-based solutions over the time, and we don't need it anymore. It's literally just a little blob of JSON and shove it in the page, and you're good to go. View transitions. How exciting are view transitions? The idea that we have the ability now to do seamless page-to-page navigation and transitions. It doesn't have to be this quick cut that we always were trying to do. Well, we hoped it was a quick cut, sometimes a slow cut. But to have these beautiful transitions between pages. You can get more complex with it. You can tap into it with JavaScript if you want. There are things you can do with keyframes and CSS, but even just this little line puts a nice little transition, a nice soft transition as you're navigating between pages. And anecdotally, on projects that I've seen this rolled out on, the feedback from users just from this has been really good. It's just a little bit of a nice embellishment and touch. All of this stuff is available now with just a few lines of HTML or a few lines of CSS. That is pretty freaking incredible. Betting on the browser is our best chance for long-term success. It's always been our best shot at long-term success. We need some of these other solutions because that's where the innovation comes from. We need people who are willing to try to push the limits and go outside of that. But at the end of the day, you can't beat the browser. We're not going to solve performance issues by dropping in more code, by adding more layers of complexity. We solve performance issues by relying on the platform and the browser to help us get there. Good performance doesn't have a shortcut. There's no shortcut to doing this. There's no drop this in and it fixes everything. The way we get to a seamless, fast experience on the web that everybody can benefit, that improves the experience for the folks that are in those less than ideal situations, that lets us provide an experience where it's still, they can use the web, they can access the web, they can get the things they need to get done, while at the same time meeting the rising expectations that we have with this new generation coming in, where it's like, hey, we haven't learned yet that the web needs to be slow, so why the heck does it need to be slow? The best way to fit both of those, to help reach both of those audiences, that comes from hard work and a ruthless obsession for the user experience. I think we're better equipped than ever to make this happen. So let's get to work. Thanks.
Amazing. Funny story, so my son routinely gets blocked as a bot by PokemonCenter.com because he scrolls so quickly that he seems like he's not a real human. Isn't that wild? Like, so to back up Tim's. So coming up next on stage, we have Jack Franklin. Jack, I think, is the new tallest person in WebPerf. We measured the other night in the speaker dinner. Jack is a software engineer on the Chrome Performance DevTools team. He has a 10-month-old baby. Yeah. So the fact that he's up here even talking to us is frankly amazing. And I don't know about you, but he's going to do a deep dive into some of the new DevTools stuff. So yeah, very excited for this. So everyone give it up for Jack.
Cool, thanks. Good morning, everyone. Thank you, Katie, for the intro. Yeah, really, this conference is an excuse for me to get into a hotel room and have an uninterrupted night of sleep. So I'm very grateful for the opportunity. But yes, it's also very nice. This time last year, I was here with my wife, who was heavily pregnant. Now I'm here with them. They're not in the room. I couldn't convince her to get up for a talk on DevTools, but they are here in the Netherlands, so it's really nice to be back and talk to you today. So as Kate said, my name is Jack. I work on the Chrome DevTools team, and particularly for the last few years, I've been focusing on our performance tooling. And today I want to take you through some of the things we've been working on in the performance panel in particular that we hope will positively impact your performance workflows in your day-to-day lives, hopefully for the better. The context for this is a blog post we put live in March of this year, where we talked a little bit about our plans for performance tooling moving forwards. And in a lot of this, we talk about how there's a lot of tools that we ship. You've got Performance panel in DevTools. There's also the Performance Insights panel, which I'll touch on later. There's Lighthouse as well. There's a number of other tools. And there's sort of been a lot of inconsistency across those. And what we want to do is make it more consistent and more obvious for you where to go to get really useful information and dive into the data that helps you understand your website's performance. So for this talk, I've broken it down into a few different areas that we've been looking at, where I'll highlight a bunch of features we've shipped. I'll talk about this a bit more later on, but we're always very happy to give feedback. There's a bunch of Googlers here today. Most of us will be up towards where the help desk is. Please feel free to come and chat to us. We like hearing what you like about DevTools and what we've built, but really we also like hearing what you'd like us to do better or do more of or focus on. So please do come and tell us what is bothering you on a daily basis. So the first area we looked at was spotting issues sooner. The performance panel, historically, the landing page when you first open up DevTools, go to the performance tab, was completely blank. I think it had a record button in the middle of it. But other than that, there was nothing there. It didn't give you anything useful. And earlier this year, we wanted to rectify that, so we shipped the landing page. I know this was mentioned yesterday, I think, in a few of the talks, and I'm sure some of you have come across this. But now, as you're interacting with the site locally, when you pop open the performance tab, we'll get live data into the performance panel, so you can have a look at what your website is doing. What's really nice here is that this doesn't have to mean that you don't have to record a trace now. You can see some data, and you can also, you might pop this open and be surprised that one of your metrics is slower than expected. It gives you a little nudge to dig into that. But more so, what we're really excited about with this panel is the ability to start bridging the gap between lab and field data. So now what you can do is you can configure field data in the panel, and when you do that, we'll go and fetch data from Crux and show you how that compares to your local data. We all know probably in this room that we're all probably fairly fortunate to have pretty new modern hardware. Recording a trace on a new MacBook Pro with 29 million gigabytes of RAM is probably not representative of most of your users. We can never bridge that gap fully. We can't create something that is completely accurate and representative of field data, but we're hopeful by putting some stats into the page, we can help nudge people in that direction. And we'll also try and call this out when you go and record a trace as well. in terms of the throttling settings that you could provide to try and make what you're doing locally on your machine closer to what your users are seeing. So this is really nice, but what this requires is that you're browsing your production website, and a lot of the time that won't be happening. You might be running it locally on your local host. You might be running it on some staging or pre-production environment that you have set up. In that case, we aren't going to have field data to show you. So in this case, I've got my very complicated local host website, and there's no data that can be shown. So what we've also added is the ability to map your development origins through to production origins. So here I can tell DevTools that although I'm working locally on localhost 8787, I actually want you to give me the data from web.dev. So if you're working locally or you're debugging a pre-production site, you can still hook up and get the data from any given URL that you want. And for those of you who have used this panel a bunch since it was released, I'll just take this opportunity to call out a few small improvements we've shipped. The LCP breakdown by phase is now in there as well when you hover over the LCP value, so you can see those 4 phases. We also show you now the phases for the IMP and the interactions. And we also give you a bit more information about layout shifts as well. And you can hover over those elements to see them highlighted in the panel as well. If you want to learn more about this, there's a good video and accompanying blog post. It's by our amazing developer relations person, Jesslyn. And who's the other? Don't know who the other guy is, but someone else. I promise Tim and I didn't even plan that. So Barry, congratulations on being featured in 2 talks this morning already. 2 for 2 so far. Yeah, this is a really good resource. Please give it a go and let us know what you think. And next up, an area where we'd had a lot of feedback is around the network track in the performance panel. It always felt like it was a little bit clunky, a little bit hard to work with, and didn't always give you all the data you needed. So we've been working on a bunch of improvements for that as well. The first thing we've done is we've really heavily upgraded the tooltip. So when you hover over events in the network track now, you're going to see way more information. I think previously you saw the duration and the URL. We'll now give you the URL, we'll give you its priority, its type, and we'll give you a little timing breakdown as well. And we're also trying to call out things that might warrant your attention. So for example, render blocking requests will now get highlighted via this tooltip as well. And if a resource's priority changes during the loading lifecycle, we'll also call that out. So here, this image started as a low priority and was upgraded to high, and so we can call that out so you're aware of it. And the nice thing about this is this all happens now without you having to click on the event and look in the summary tab at the bottom. Just hover your mouse over it, and you'll see a bunch of more useful information. We've also upgraded the summary drawer down the bottom. I think it looks a bit nicer now. You'll also see that timing breakdown that's in the tooltip. But one feature we shipped that had been in DevTools for ages but was behind the experiment is initiators. So these always used to be just for the main thread and main tracks, never for network. But we've now enabled them for the network track and turned them on for all of you. So there's no need to do anything to get this. So it might be a little bit hard to see at the back, but there's now an arrow here drawn from this PNG that I'm loading back to the document request. And this shows you why this request happened, what initiated this request. This is super helpful if you're debugging chains, or maybe you want to understand the critical path through to your LCP image. You can now see that visually on the network track, and we'll also call it out down in the summary as well. And we've also made it easier for those of you who need to regularly go between the performance panel and the network panel, which we know is pretty common. So this link to the resource here, this CSS podcast link, always takes you into the sources panel. But there's now a little icon next to it. If you click that, we'll be taken straight into the network panel, so you can see all the information about the network request. We're very aware here that DevTools doesn't always make it as easy as it could be to go between different panels, and this is a use case we're really interested in learning more about. So any feedback is welcome, but if anyone has frustrations around going between panels, particularly from the performance panel into anywhere else or back, please come and talk to us, because we'd love to understand the use cases and what we can do to make this a more seamless experience. And finally, a minor gripe of mine that we fixed this year. I don't know how many people know that in the performance panel, you can use Control-F or Command-F to search, and it will search through the flame chart to find particular events. Well, this never used to work in the network track. It just didn't. It would never find anything in the network track. I'm pleased to say it now does. So I can search down here, in this case for app.css, and it will find me all the events that match that, including the network track. So now there's a particular request that you're looking for, a particular resource that you want to see when it was loaded. You can search for it, and it will get highlighted. So this has saved a bunch of time. And finally, I've been working on DevTools for 5 years. This feature isn't new. I think it's existed for all those 5 years, but I learned about it a few months ago, so I wanted to call it out, is that within DevTools, you have the ability to block network requests entirely from happening. To all of you, this may be sort of common knowledge, but yeah, this was something I learned from a user research session fairly recently, so I just wanted to call it out. If you go into more tools, you have network request blocking. In there, you can add URLs or patterns that will get blocked. So here I think I'm debugging a site that has some Google fonts, so I want to block those requests to check the impact that they're having on my site. And so if I do that, and then I run a trace and reload, it's blocked those requests, and they're now not shown in the network track. This is really useful if you're trying to understand the impact of a particular resource or origin that you're loading. You can block it, and then you'll be told, or you can see visually what it looks like. What's nice here is we aren't faking these being blocked. We're not sort of removing them from the network track and hiding them from you. They didn't happen because they get blocked at a deeper layer than that. So it's a really nice way to very quickly understand the impact that a particular origin is having on your site. And if you'd like to read a bit more about this, there's a link to the What's New in DevTools. This was shipped in 1.8 a few months ago, and there's a bit more information there. And we've also done a lot of work to look at how we can help you focus in on the important parts of a trace. We're very aware that traces are heavy, they have a lot of data in, and that's really good because often you need all that data to be able to understand what you're working on. But depending on the particular thing you're debugging, you might not need all that data all the time. This is a trace of web.dev. Throttled a bit, and you might be able to make out this is about 17 seconds worth of trace. That's a long time. It's also not super useful to me to want to have to see everything at one go. Most likely you might be looking at, say, LCP, in which case you only care about everything that happened up till then. You might be looking at a particular interaction, so you only really care about what happened during that interaction. So we wanted to make it easier for you to zoom in on the bits of the trace you care about, whilst also still keeping it easy to let you zoom back out and find a different part of the trace. There's a few things we shipped this year that hopefully help with this. The first is breadcrumbs, which will, I'll admit, will look quite familiar to you if you've used the Firefox profiler. So thank you for the inspiration there. And this lets you select a time period of the minimap and click a button and zoom in. So you scope the minimap and the rest of the panel to that particular time. You can also nest these. So if you create a breadcrumb, you can still go further and create another one. And you can then navigate back and through with them. So this helps, this is a start, but we've also seen people do a lot of work where they will screenshot the performance panel and they'll draw using a custom app arrows or annotate it to share with their colleagues. And we wanted to try and see if we could bring some of that into DevTools. I think a few of you will have seen this photo before. This is the Wikipedia team in 2015 who printed out their performance trace so they could annotate it on a desk. I really like this, but I don't recommend it as an approach for everyone. I think it's pretty resource, ink, and paper intensive. And not really what we want to be doing. But we really like the sort of idea behind this and what they're trying to do. And performance tracing like this is very useful to do this visually and actually annotate and draw on it. So this photo was taken in 2015, so obviously it's taken us a while to get around to this. Hopefully we won't take 9 years for every feature request. But today in the Chrome that shipped this week, I think either yesterday or the day before, so perfect timing for me, we're now shipping the ability for you to annotate the trace directly in DevTools. So now I can double-click on this entry, and I can type, and I'll just leave myself a label with some notes, so I can come back to that later on or see what I'm looking at. In this case, I'm annotating a network event. It doesn't have to be network. Here, I'm pulling out a long task on the main thread, something I want to come back and look at later on. Anything you can click on in the flame chart to select, you can also double-click to add a label to. So we're really excited, and hopefully this will really help you leave notes for yourself as you're on your debugging journey. Along with that, we also know that sometimes events in the flame chart will be related to each other, and you working on your site, you might want to highlight those relationships. So when you double-click, you can also click to drag this little arrow out, and now you can draw connections between entries too. This is just a nice way for you to leave yourself notes or to highlight something in particular you want to focus on. You can connect any event to any other event, and you can do this as many times as you like. And finally, you can also highlight time ranges. So you shift, click, and drag. That would create this time range in a nice pink color, and you can leave yourself a label for that as well. And then all of these stay on the timeline, and they stay in the right place as you zoom and pan and all the rest of it. And we're really hopeful that this is a really nice way for you to be able to leave yourself notes as you work on debugging a particular problem. What's really nice as well, if your traces are quite long and have a lot going on, is you can also use these annotations almost as bookmarks to jump through the trace. So we have the annotation sidebar, and if you click on an annotation and it's not in view, we'll scope and zoom the panel in to see that annotation. So you can also leave yourself these notes to jump between different periods of the trace that you might be interested in looking at. And you can also use the delete icon here, of course, if you want to get rid of them. So this is really powerful if you're debugging something on your own, but where we think this really begins to shine is the fact that you can now take this out of DevTools and send it to a colleague, and they can see all your notes as well. So now when you go to export a trace from DevTools, you'll get two options. Save trace without annotations does exactly like it sounds like. It won't include any of those custom annotations. It will just include the trace events. This is effectively what used to happen before we shipped annotations. But save trace now will actually include all those annotations and notes. So if you are debugging something, you want your colleagues' help, you can leave some notes, hit export, send it to me over Slack, email, upload it, or however you do that. And then when I import it, I'll see all the annotations that you've created as well. And for those of you who have used Paul Irish's trace.cafe, that also supports annotations because it's using an up-to-date DevTools as well. So in this case, you can even upload a trace of annotations to there. This will give you a short URL you can send to a colleague, and they will see all your annotations. So you think for a sort of shared debugging experience, these are going to be a really powerful feature. If you'd like to know more, we shipped the blog post on this literally yesterday. I think Rick pressed deploy up on the help desk back there yesterday afternoon. So please give it a read. There's a bit more information to them from Alina, who's the engineer who worked on this feature. There's also a link for you to give us feedback. We're really keen to hear how this is working for you, how useful it is, and also how we could make it more useful and iterate on the feature. And I'll put links on the internet to all these resources later on. So continuing the theme of focus and dealing with large chunks of data, we've also had a lot of feedback around flame charts and how they can get pretty large at times. And they can be large because there's a lot of data, but also there's just a lot to fit in a performance panel, particularly if you're traveling, if you're on a laptop, or to be honest, even sometimes for me at home on my fairly large monitor, just the verticality of flame charts can be a bit of a challenge to fit it all in. And also often there's stuff in there that isn't always relevant. To demonstrate this, I built a very exciting React app. You enter a number and it calculates the Fibonacci value for that number. It's pretty complex. But it does let me demonstrate in a contrived way some of the features I want to show you. If I record this interaction in the flame chart, this is what it looks like. And if I'm the developer, if you imagine this is an actual proper application and I'm trying to debug my first-party code, what you might not realize is a lot of this flame chart is almost irrelevant to me. A lot of this is the React internals. And I'm using React here purely as an example. You can swap this out for whatever you like to work with. The bits in this flame chart that are my code that I wrote is actually this tiny chunk down here. That's the recursive Fibonacci calls to calculate the value. And then this here is the Fibonacci calculator component that I built. The rest of this flame chart is not my code. I didn't write it. It's code that I'm using, but I didn't write it. And so this can add quite a lot of noise into your flame chart, and it's stuff that really you're probably not going to be expecting to dive into the React internals to figure out your particular problem. So we've begun to add some controls to let you customize this and slim down the amount of data that's shown. The first now is you can right-click and click Hide Children, and that will collapse the particular icicle in the flame chart that you're working on. Hide Children is the most useful because it collapses everything. You can also hide function to hide that one particular thing as well. And very quickly using this, you can get rid of a lot of the noise. You can also use the C key on your keyboard, so it's a little bit quicker than right-click if you want to do that. You can also use this on your own code, so we also have hide repeating children, which is very useful if you do have recursive or lots of nested calls that actually you don't really need to care about. You can just collapse them out the way. And what's nice about this is all these customizations are included if you save a trace. So again, if you want to send this to a colleague, you can collapse parts of the flame chart, you can get it to just what you want, hit export, and all these will be included. So you can send it to someone else, and they'll see what you're seeing as well. And DevTools has actually had functionality built into it to deal with the fact that we use a bunch of different abstractions for a long time. It's called the ignore list. The ignore list has historically been used in the sources and debugging part of DevTools. And what it does is, as you're debugging through, it will ignore any particular scripts that match particular rules. So for example, if you add a rule to exclude node modules, or for the retro folks among us, Bower components, that takes me back a few years. When you're debugging a script, if it matches this, the debugger won't step into it for you. It will just stay on your first-party code. And what we've done now is we've integrated this more tightly into the performance panel. So if I'm looking at a trace, I can click Add Script to Ignore List, and then any particular calls that match that are from that script will be hidden out of sight for you. So you can see here, this very quickly gets rid of the noise. In this case, I'm using it on my silly little React app, but of course, this can be any code. This can be a particular script in your application that you're debugging, another third-party library that you use, whatever this may be. And when you do this, this will add it to the ignore list. So if you then go back to your settings, you can see I've now added react.dom.development.js. Just a little caution here is these scripts, this ignore list is global across all of DevTools. It won't reset if you import a new trace. So if you're working across different tech stacks, you may have ignore list rules that you might want for some traces but not for others. So make sure you kind of manage this. If you do see something you want to remove, you can always do it via the settings or right-click and remove script from ignore list. And we think these are really nice improvements that will help you clean up the flame charts and focus in on what is important to you at any given point in time. Kind of continuing on with the ability to let you customize the performance panel, we've done a lot of work on extensibility and this vision that we have for you being able to make the performance panel have data that is bespoke to your application. You've always sort of been able to do this to some degree with the user timings API. So if you call user timings with marks and measures, we'll put them into the timings track for you. And this is a really useful way for you to put custom information in. But we've always wanted to give you slightly more control over what this looks like. So earlier this year, we shipped the first version of what we call the Extensibility API. And this uses performance marks and measures, but lets you give us more information, which we'll then special case within DevTools. So if we take this performance.measure call, in the spec for performance.measure, they have this detail field, and in there you can effectively put any arbitrary data you want. If you put in an object called DevTools and give it a few certain keys, and all of this is documented online, we'll actually pull this out and put it into its own custom track. So I've now got my perf.now talk demo custom track, and you can see the tooltip text is there as well. What's nice about this is you can also add extra data, so when I click on these events, you can show custom data in the details drawer as well. What we're really excited about is this is open to anyone. This is live now. All of you could use this and get up and running straight away, and we've already seen the community start to adopt this. So Nolan Lawson, who I'm sure will be familiar to lots of you in the room, he did this on the Salesforce Lightning Web Components library. So now when you use the Salesforce LWC library, you get this custom track that appears. And you as the developer using this library, you don't have to do anything to make this happen. This just happens for you behind the scenes. What I really like about this is you can see that LWC hydrate call in green in the middle, and you can now visually align it with the flame chart. So it's a really great way to give yourself context for what's happening in the flame chart with some more descriptive, bespoke information that you can add that matches what your app does. And we're also exploring this work with other abstractions. This is not shipped. This is very much an experiment. But here I have this very exciting React app my colleague Andres made. He seems to be a big fan of corgis. And if you add a bunch of corgis to this app, you can see it's pretty slow and laggy. But then what we can do is we can have React actually dump a bunch of information about what components it was rendering at any point in time. So again, it can give you some contextual information on what's happening. And this is all live. The React version isn't live. This requires a custom build of React. But the performance API within DevTools is live and can be used right now. And a really nice demonstration of this is a fellow speaker, Daniel, who I met for the first time on Wednesday, who's a maintainer of Nuxt.js. I got talking to him over a beer about the Extensibility API, because, of course, what else would you talk about on an evening in a boat in Amsterdam other than DevTools performance panels? It tells you a bit about me. But anyway, I told him about it, and he was excited. And yesterday, I got a ping from him saying that he'd landed it or sent a PR to Nuxt. So here you can now see Daniel's added a custom Nuxt track as well. And he said this took about 20 minutes or so of time. So it's a very straightforward API that will give you data. Thanks, Daniel, for that one. And also, the darling of the performance community world, Andy Davies, has also done this because anyone can use this to give yourself data. So in Andy's case, he's created this little tool that will add LOAF information to a custom track as well. So you don't have to be building a big framework or an abstraction to make use of this. I really think anyone can make use of this to give yourself some more information based on your application. Again, please try it out, and your feedback is always very welcome. Okay, so next I want to talk about a topic that hasn't had a lot of attention in the tech world over the past 12 months or so. But we are very excited about the potential that AI has within the performance panel. AI, I think, has a lot of potential to take large sets of data and summarize it and break it down and give more useful explanations. And this is not live yet. It's coming soon to Chrome. We've been exploring what an integration into the performance panel might look like for an AI agent. So the first way we're doing this is now when you right-click on an entry in the flame chart, you're going to get an Ask AI button. You get this little AI assistance tool. And in here, you can ask it a question. So I ask it to identify performance issues with this particular part of the flame chart. And once you let it whir and calculate stuff, it comes back, and it actually gives me some pretty handy information. It's able to identify it's a React app that's running. And it also calls out that the performance issues here is the corgi component taking the majority of the time. In this case, this is actually correct. This is exactly the performance problem. Not that you can blame the corgi component. They've only got little legs. And I'm really sorry. I couldn't resist. I couldn't resist one. So when this is coming soon, this isn't live just yet. We're really keen to hear sort of the good and the bad about this. So please feel free to make use of the feedback button and let us know what you think. And while I'm up here and talking to you, I really want to take the opportunity to actually really encourage as much feedback from you all as possible. We who work on the panel, obviously, we have hunches on what we should build and where the problems are and what we should focus on. But sometimes it can be hard for us because our job day to day is to build the tools. Our job isn't to use the tools to debug the websites like most of you in this room are doing. And so your feedback is incredibly valuable to us to help us understand what we should prioritize, where the pain points are, and what we should work on a sort of quarterly, yearly basis. I think there's a bit of a myth that you file a new bug and it goes into this bucket and it's never to be seen again, and then in a year's time we'll just close it. But genuinely, every bug relating to the performance panel, it does get someone's eyes on it. Most of the time it's me, and we do try and look and fix bugs, as well as deal with feature requests. So I just want to take a minute to talk through how you can give us feedback and how you can report bugs and all that kind of good stuff. So here is a good example of a great bug. It's by some CSS wizardry script kiddie hacker with a very odd Gmail name. Sorry, Harry. But what this is a great bug report that Harry sent us a few weeks ago with very clear steps to reproduce the problem, a detailed description, and actually even a narrated video from Harry talking us through it. Now that is going above and beyond to give us a very, very valuable bug report that was very easy to fix. Happy to report this is fixed as of a few weeks ago. But anyone can do this, and you don't have to be able to give as much detail as Harry could in this case. And I really want to encourage you all, ever you hit something that could be a bug or you've got an idea for a feature, to please just let us know about it, because we do look at them. So where you want to go to is crbug.com/new. You get a slightly dated-looking website, I'll be honest, with a lot of form fields, but the majority of them I just want you to completely ignore. The main thing that's important here is this very clearly named component field, which is a little bit odd. This is effectively the category or tag, or you can think of it almost as what team would you like to look at this problem. If you're not sure if the problem is performance specific or just more generally a DevTools bug, please just feel free to select the DevTools one. But if you do think it's performance, you can search for performance, and you should see the DevTools performance component pop up. This just makes sure it gets routed through to the right person. Often myself or Z, the product manager, or someone will look at this and see what we think and if we need to prioritize it. And then if you have a bit more time to give us a bit more detail, a few things you can tell us is how did you reproduce this bug? What can we do to replicate it so we can figure out what's going on? What you expected to happen versus what actually happened. Sometimes people report bugs, but it's not actually clear what should have happened. So telling us your expectations here is really helpful. What version of Chrome you're using. A lot of people forget this, but we do have Canary, Beta, and stable builds. A lot of you, I'm sure, often are using the Canary build. It's great that you're using Canary, and I'd encourage you to do so because it's great for us to get feedback on things that haven't shipped yet. But let us know if you are doing that, because bugs in stable may often have already been fixed in Canary. Screenshots of what went wrong obviously help us out a bunch here. And if you have the ability to, and you're allowed to, because it will be publicly available, so just be aware of that. If you can export from the performance panel the trace where you had the bug, that is the quickest way to enable us to reproduce it by dumping that trace into the performance panel. But please be aware that these are public, so obviously you may not be allowed to do that based on whatever you've been tracing. So you can do this for bugs. You can also, rather than file a bug, you can file a feature request. We do look at these, and you can also, in CRBug, you can upvote or leave comments on other people's bugs and requests. This genuinely makes a big impact on what we focus on, so please do make use of it. Please feel free to be very liberal and submit as many feature requests and ideas as you have. Of course, there's lots of us in the room today. We'll be sort of primarily over by the help desk. Please feel free to come and chat to us. We'd love to hear the good and, more importantly, the bad, because it will make a difference on what we work on. So to round off, I want to talk about a new feature that we've just shipped that's just gone live in Chrome this week called Insights. Now, we're developers, and naming is hard, so I want to be really clear. This is not the Performance Insights panel. This is a different thing. It's perfectly clear. I don't know what the confusion is. But yes, so we shipped the Performance Insights panel a couple of years ago, and this was an experiment into what happened if we stripped performance tooling back and gave you a much more simple version of the performance panel. And it turns out there were pros and cons to that. I think some people liked it. The timeline down the right-hand side was useful to people, and it was less overwhelming. But it turns out when you're debugging performance issues, the more data you can have accessible to you, the better. And so we always felt like the Performance Insights panel didn't quite hit the mark, but some features that we shipped within there were good features that we wanted to maintain. And so the Performance Insights panel is going to be removed. I think it will be removed either end of year or in January, depending on when Chrome releases. But the things that people told us you liked about the Performance Insights panel are now going live into the Performance panel. And that's what we're calling Insights. So we've been working very hard on a system that tries to identify opportunities within your performance trace and tries to just guide you towards them. But what we also want to do is not be patronizing, not try and oversimplify the issue. We want to let people who are experts dive into the tool, but these insights are sort of just nudges in a particular direction or things you might want to consider and think about. We've learned a lot about doing this from our work on Lighthouse and all the audits that we've built as part of Lighthouse. And it's always kind of been frustrating that you go to Lighthouse and you get all these audits, you go to the performance panel and you get none of them at all. And so what we've been working on in our vision long term is to make this more consistent across the tools. So you can use the performance panel, you can use Lighthouse, and you're going to see a very similar set of recommendations and suggestions. And so we'll start by looking at what we've done for CLS. The layout shifts track in the performance panel, I'll be honest, it wasn't very good. I know Barry will agree with me here because he's moaned to me on chat about this a number of times. But this is what it looked like before with layout shifts. You might not even be able to make this out of the back. But there are very, very thin lines that represent each layout shift. And when you click on them, you just got loads of numbers. You got 3 different scores. I couldn't tell you which is which. You got these moved from in pixel values, which is not, I don't know about anyone else, but I can't really visualize what those represent. My favorite thing here is the warning that says it has recently evolved, which takes you to a 3-year-old blog post. So not the most useful insight into the data we have available. I'm happy to say that the version of the layout shifts track that's shipping this week into Chrome looks slightly different. So layout shifts are now represented by diamonds. The size of the diamond will scale depending on the size of the shift. So bigger diamonds means a bigger layout shift. For the first time, we're finally also visualizing the layout shift cluster, which is an important part of the metric. That's the purple line that runs through all the diamonds. You can now click on the cluster itself to see a list of all its layout shifts. And you can also click on an individual layout shift, and we'll just show you the one score for that layout shift. You don't have to try and debug which score is which now. There's more we want to do here, but this is what we're shipping this week, and it's our starting point. What I'm really excited about is what we can now do when you hover over these layout shifts. Gone are the pixel numbers. We've now got this tooltip which will show you the animation of the layout shift in action. So you can hover over one of these, and you'll see a visual representation of what happened during the shift. Hopefully, yeah. Yeah, and this is hopefully you'll all agree, a big improvement from what we had. And again, your feedback on this is really welcome. To go along with this, see, we've been working on insights. So you may, if you've updated Chrome this week, you might have now seen this set of insights in the sidebar. These are opportunities based on the trace that you've just recorded that we think might warrant some of your attention. And the exact set you see will differ depending on the trace, because not all of them apply to every single website and every single recording. So staying with CLS for a minute, you can now expand this layout shift's insights. And what we'll do is we'll overlay onto the performance panel the layout shift cluster that was the worst one. And we'll try and give you some insight into what happened here. So in this case, it's an unsized image that was causing this layout shift. Again, there's more we can do here. Think of this insights as very much the V1 or even V0, you could think of it as. There's a link in the bottom of the sidebar to feedback, and we really would love your feedback on what we can do here and how we can make this even better. Continuing with our focus on Core Web Vitals, we've shipped a bunch of insights to help you understand LCP. So we have LCP by phase now, which this will overlay the phases of the LCP onto the flame chart. This is really useful because, you can vertically work up and down to align this with what was happening in the main track, what was happening in the network track, or anywhere else in the trace. We also have LCP request discovery, which will show you the LCP request and identify any opportunities to improve the time at which this was discovered. And we'll check things like you didn't lazy load your LCP image, which was mentioned a bunch yesterday. What's really nice about all these insights is if you click them, we'll also take you to that right place in the trace as well. So again, if you've got a long trace, you can use these to navigate through. And finally, render blocking requests does pretty much exactly what you think it does. It will highlight the render blocking requests and also identify potential savings as well that come from Lantern. And we also have a document request latency, and this will call out things like lacking compression or lots of redirects, which often can slow down the initial request for the page. Another theme of the conference, which came up a few times yesterday, is third parties. And this is another area that we're actively working on to help you understand the impact of third parties on your website. So we now have this third parties insight. When you expand that, all third-party requests will be highlighted, but as you move down the insight and hover over them, we'll highlight just the request for that particular origin on the page. We also try and name these, so rather than just showing you URLs, we use the third-party web data set that's available to give these nice names if we can as well. And this will help you understand the impact that a given third party is having on your website's performance. There's a lot more we can do here, so kind of keep an eye on this because there's a lot of exciting work in the pipeline around third parties. Another insight that I want to call out is selector stats. And now I'm the one on stage telling you about this, but I want to be really clear that I can't claim any credit for this. This was actually contributed entirely by the Microsoft Edge DevTools folks who upstreamed this into Chromium. So all of this work is really thanks to them, but I did want to call it out and show you. So now in DevTools, you can enable CSS selector stats in the setting. You have to turn this on because it does add a little bit of time to your tracing, so we don't have it on by default. When you do that and you record a trace, you now get this massive table of selector stats. This can be really useful to identify particular selectors that are taking the browser a lot of time to figure out and compute. And if you have this enabled, we'll also show you this insight as well, which will kind of call out the top offenders. If you want to learn more about this, there's a great blog post on the Edge DevTools site as well. Finally, we've also begun to look at what insights we can build to help you with INP. So using the sort of very useful, Phil Walton's very useful INP demo site, sort of created a little example here where we have a bunch of very slow interactions. And again, we have the INP by phase insight. And when you expand that, it's going to overlay the 3 phases of the INP event onto the flame chart. So you can, again, visually line it up and work with it and see the numbers behind it. If you record with a mobile emulated viewport, we'll also call out if that viewport is optimized for mobile and if you've got the right meta tag in place to avoid the potential delay when users tap. And finally, for those of you who record traces that might include page navigations, we wanted to make sure that you don't lose the ability to have insights, but also we make it clear which insights apply to which navigation. So if you have multiple URLs, each insights will be grouped per navigation. So here, I searched on Google for performance.now, went to perfnow.nl, and then clicked a link to Harry's website, and we'll group the insights up based on those navigations. So it's still useful, even if you've got lots of navigations going on. There's also this little icon on the right-hand side that you can click to zoom the trace to the code, to the code that is relevant to that navigation. So again, you can use this as a nice way to navigate your way through the trace. So that is what we've shipped so far for insights. We're very much at the beginning of the journey and the work we want to do on those. And so again, I'd like to really encourage you to give us feedback. It's the main way we prioritize and plan is based on feedback. And honestly, like bugs with lots of upvotes or feature requests with lots of comments do get noticed, and they do make a really big difference. Of course, you can always do this over the internet, but today is a great opportunity. I'm here. Z, who's the product manager for Performance Tools, is also here. It's her first Perf Now, so please make her feel welcome. Feel free to come and grab us. Lots of us are up at the help desk, and we'd really love to hear from you. So with that, I'd like to thank you very much for your time. This is where you can find me on the internet, and I hope you enjoy the rest of the day, and thank you for listening.
Thank you so much, Chuck. Come have a seat with
me.
me.
Sure.
All right, thank you. Wow, all right, that was quite the info dump.
Yeah.
That was a lot of information to take in.
Yeah.
So one question that I have is I feel like a lot of times when I'm talking to folks who are new to web performance, they tend to open up the performance panel and immediately get overwhelmed and close it.
Yeah.
So I'm curious, do you have suggestions on ways for folks who want to become more familiar with the performance panel on how they can kind of level up their knowledge?
Yeah, I think that's a big part of our vision for the insights. The fact that not only we get this data, but when you click on them, they take you to the relevant part of the trace. That's how we see as a way that we can then overlay kind of visually onto the flame chart, particular areas of interest. So I think it's about understanding that you might have this huge trace of all this data, but depending on what you need to debug, you don't need all of that at any given time. And so one of the visions for insights is to kind of call that out and scope people into what they're working on. But yeah, we kind of walk a fine line. We don't want people to feel like, oh, where do I go? We also don't want to hide all this useful data from those of you who need it. So that's kind of the balance we're trying to hit.
Yeah, no, it must be incredibly hard to have to balance the needs of experts and completely newbies when there's so much data.
It's a fun challenge.
Yeah. That actually brings me to the first question that someone else asked, which is, it seems like there's a lot of potential in the AI feature to help folks better understand performance. Do you have any insight or ideas about when that might go live?
I don't know. I could find out later on. I believe it's in Canary now, so it shouldn't be too long. Okay. But I do know that we don't do a release around the Christmas period, so it may be early next year, but I can find out.
Awesome.
Yeah. But not too far to wait.
And I think there used to be a Twitter account that folks could follow.
Yeah,
right?
there is a Twitter,
moving it to
Blue
Blue
Sky,
Sky? Yeah.
I don't know, whatever else accounts. There are, Chromium Dev or Chrome DevTools, I think is the name. So if you find those and follow those, you'll get links to all the blog posts and things. The YouTube channel also has all the what's new in DevTools and all the videos on, so that's another good resource to stay up to date.
Awesome. Have you played around at all with using the AI feature to help specifically with third-party code to sort of help folks understand a little better what the impact of third-party code is?
Yeah, we've done a little bit, and we've done some kind of exploration into, particularly on live production sites that are minified. If we have source maps, we will use the source maps in the flame chart to convert minified calls into more descriptive authored calls. But also we found that the AI often, if you give it some minified code, it actually does a pretty good job often at recognizing what the actual source code is. So it can say, oh, this is React, or this is Angular, or this is Google Tag Manager, or whatever it may be. So we think there's jQuery. So I think there's a lot of opportunity for it to recognize minified code and help out, because that, if you get a flame chart with lots of single letter function calls, it's a tough one. So yeah, I think there's going to be a lot of opportunity there for third parties.
Oh, awesome. A question that came in from the audience is, are there ways to use these new DevTools features to debug natively on mobile devices? Or is it, because I know you mentioned that you can do spoofing in the browser, but are there ways that folks can?
Yeah, so I think Brendan is going to be doing a demo of this, or maybe that was yesterday, so apologies if I've dumped him in it. But we do support remote debugging, so you can plug your phone in and use DevTools on your laptop connected to a real device. And all the features I showed there should work just fine on that as well. So yeah, that's the best way to do remote debugging.
Yeah, I've done that. It works really well.
Great.
So one final question, and then we'll wrap it up here. So if you could wave your magic wand and make a feature appear in DevTools, what would that feature be?
Oh, that's a tough one. There's so much we could do. I think we're really excited by insights. I think we have a lot of ideas for what they can become. I think there's a lot more we want to do. And I think our vision is to have a very much consistency between Lighthouse and the performance panel. So I think wave my wand, I'd like to kind of magically make all that work happen, because I think it'll be very impactful to see very consistent advice, regardless of which tool you use.
Yes.
But yeah, we've got a bit of work to do to get there.
Yeah, definitely. Because I think, particularly when you're talking to folks who are, again, new at discovering web performance, they get very confused very quickly when there's differences between what the different tools are showing them and what the different tools are saying. And I think it can be difficult to understand the difference between lab and field. And so it's been really great to see all of those improvements to the landing page to help folks better understand, okay, what you're seeing now is not realistic, and here's what real users are seeing.
Yeah, and we don't want people to have the confusion of, well, Lighthouse says this, but when I do the same thing in the performance panel, it says something completely different. So if we can bring those together, that would be a big improvement, I think.
Wonderful. Yeah. Well, thank you so much, Jack. I appreciate you and all of your work that you're doing to make it easier for us. So we're going to have our first coffee break. The break goes until 11:30. Don't forget that you cannot bring the glass cups downstairs with you. Make sure to transfer your beverage over to a paper cup. And I can smell the stroopwafels, so I'm going to cut in line when I go up there so I can get one in before the end of the break. Don't forget to visit the help desk and bring all of your questions. And again, the perfnow.nl/QA form is where you can submit questions for our speakers that I will ask them up on stage. So thanks, and we'll see you at 11:30.
Cool. Thank you. Thanks.
Hello, hello, welcome back. Did everybody enjoy the Stroop waffles? Yeah, so good. I am like flabbergasted at how thinly they slice in half. It's like I would never be able to do that in a million years. That's like true artistry. All right, so a couple of announcements. First, if you are missing a gold hoop earring, there are two people who are missing two different gold hoop earrings that have been turned in. PPK has them right up at the front of the stage if you want to grab them at the next break. If you find another gold earring on the floor, bring it up to us and we'll find the owner. Another announcement is at 2 o'clock, the Chrome team is looking for about 5 to 10 volunteers to do a feedback session about DevTools. Z from Google is going to be meeting folks at the front door at 2 o'clock. Also, make sure that you visit the Google Help Desk and talk to the experts there. They're there to help you out. All right. So our next speaker is Mandy. Mandy's a lead software engineer at Octopus Deploy. And I met Mandy many years ago. I don't even remember what conference it was, but we met at some conference. And I just have to say, I feel really bad for every speaker that's coming after her because she's about to like drop the best slides that you have ever seen. Everyone else is gonna like pale in comparison. But she's a fantastic designer, and she's here to talk about font perf strategies so that you don't end up making one of those 17 mistakes that Paul shared with us yesterday. All right, welcome, Mandy.
Thank you. Thank you. Now I feel pressure about my slides. If you can't tell from my accent, I am Australian. One of the things about Australia is that we have all these like really dangerous creatures. And as a result of that, we kind of have developed this fear response where instead of getting all panicky, we just get like really chill and relaxed because that's what you do in front of big, scary things. So if I look really relaxed right now, I'm not. I'm just employing that defense mechanism so that I can talk to you about fonts. I'm really hoping that you enjoy my talk. If you don't get anything out of it, the consolation prize is a picture of my dog. This is Jello. And if you want to talk to me about Jello or, fonts, I'm on Mastodon and Blue Sky. And as I said, my name is Mandy. I work for a company called Octopus Deploy, which is based in Australia. And we sort of aim to automate and simplify complex deployments. But I'm not going to be talking about that. I am going to be talking about fonts. And the thing to know about me is that I really love text. And I've played around with text a lot on the web, mostly just for funsies. So this is kind of more of a passion of mine than anything. And I think what I find so fascinating about text on the web is it's something that every website has. And we often just kind of whack it in and don't really think that much about it because it just kind of works. But as a result of text being so fundamental, fonts have become a really big part of the web as well, whether you're explicitly adding one or not. And it didn't always used to be this way. Many years ago, if you've been around that long, we used to have things like Kufon and Cipher to try and get our fonts, which were awful. But then we got web fonts, and about 87% of all websites now use web fonts, according to the HTTP archive. And that means that 87% of all websites really should be considering, the performance impacts of loading those resources. Now, there are two main areas that fonts impact: the largest contentful paint and the cumulative layout shift, and we'll sort of talk about those as we go through, and the changes that we're going to make will have the biggest impact to these two areas. I will be referencing the Web Font Almanac, which a couple of other people have mentioned. It's a really great resource. I highly recommend you check it out. Lots of really interesting data. And I'll be referencing that data as we talk about these four main areas: hosting, number of fonts, font file sizes, and display and loading. Now, I said I like text, and I've got 3 blog posts about websites about text, various things, update sporadically. But I made these while I was on maternity leave, so terrible choices were made. Probably the worst work I've ever done in my life, except for maybe that Backstreet Boy website I made when I was 13. The fonts on this are absolutely horrendous, and I'm deeply ashamed by it. And we'll get to the slide of my shame soon, but I'm going to use it as an example of what not to do, and then we'll go through and try and fix them. Now, keep in mind, it is a blog, and I'm based in Australia, and my server's in the US, so the timings are all whack. It takes like an extra 300 milliseconds for a request, because it's down under. But let's just focus on the percentages. Now, I'm going to show you how it loads on a really slow 4G connection. Slow poofball was total accidental from Tabby Cat, but I thought it was funny. So this is my website loading, and the fonts haven't loaded yet. And they've not loaded yet. Still haven't loaded. It's still not. Oh, there goes the heading, and there goes the body text. It's a really long time on a slow connection, so hopefully we can make this a little bit better. Now, in the grand scheme of websites, these numbers aren't particularly terrible, but we can make them better, especially that page weight, which we'll get to in a minute. Now, our main goal is going to be how we can get the best font performance we can on our websites. And there is 100% surefire way to do that, and that is to not use web fonts at all and to use system fonts instead. Now, a system font basically refers to a font that's installed on the computer, and its aim is to match the typeface of your website to the operating system UI. So for a Mac, that would be SF Pro. For Windows, it's Segoy UI. For Linux, it's like Ubuntu and a bunch of others. There's a bunch of different fonts depending on the system. If we go back to the strategies, none of these matter if you use system fonts because there's no font file, so you don't have to worry about any of that. But the biggest problem with system fonts is that they lack consistency across browsers. As you can see, they're all different widths and boldness. So when you choose to use a system font, you're handing your design choices over to the operating system, and that may or may not be a good option for you. You also need to make sure that your UI can handle that discrepancy in width, otherwise you'll have some bad times. Now on TextLab, I can eliminate the layout shift because there's no fonts, and my layout shift was completely caused by my really awful fonts. And I can reduce the largest contentful paint by a bit just by switching to system fonts. So it might be a good choice for you if you don't have to worry about branding or any of that kind of thing. So if custom typography is not a big deal to you, system fonts might be the right choice. We at Octopus Deploy actually switched to system fonts very recently, so if you want to talk about that and the ins and outs of it, please come speak to me afterwards. I know all about it. But it does erase the need for any kind of performance strategies. However, if custom typography is important to you, these are not going to be a good choice. So that's what we're going to look at for the rest of the talk. With that out of the way, the first thing that you really need to think about is whether you are going to use a third party or you're going to self-host. So third parties being like Google Fonts, which is by far the most popular third party for fonts that exists. Now, according to the Web Font Almanac, about 70% of all websites across desktop and mobile use a self-hosted font in some capacity, whether that's exclusively a self-hosting or using it in combination with Google Fonts. It's much lower numbers for only self-hosting and only a third party, and there has been more of a shift to using self-hosted fonts over the last few years since the last almanac was released. Could be a number of reasons for the mixed approach, like legacy fonts or a font not being available in Google Fonts, so you need to self-host that one. But one of the biggest reasons that is speculated about the reason that people are moving to self-hosting is because it used to be that when you use a third party, like Google Fonts, you would get the benefit of cross-site caching. So basically, if two different websites loaded the same font, it would only be downloaded the once. But about 2020-ish, this was removed from Chrome and Firefox, and that's because it was possible to track users across websites using cache side channel attacks, so security risk. As a result, the benefit of having that caching is no longer available. So when you use a third party, all you're doing is adding the cross-origin request to your critical path, which is not great for our performance. And additionally, you get some tracking when you use a third party as well, which also isn't great for privacy. That said, privacy stuff aside for a moment, the decision I think about which is better really depends on what you're willing to do. If you want to dump something in your page and you don't want to spend time optimizing the fonts and you don't want to listen to anything that I say today, Google Fonts might be a better choice for you. And the reason for that is that they put a lot of effort into optimizing. Google Fonts are about half the size of the average font file size that self-hosted fonts are. So you might get better performance here if you're not willing to do anything else. That said, realistically, self-hosting is the better choice for performance. It's better for privacy. So if you're willing to put the effort in, this is definitely the way to go. Now, related to your decision about what hosting you want to do, it's really about the number of fonts that you want to use from that. Whether you're self-hosting or using Google Fonts, it's the same question. The less fonts you have to download, the quicker things are going to be. Now, how many you need largely depends on your design. If you have different heading and body fonts, you might have somewhere between 5 and 6 fonts covering bold, italic, regular, and so on. What is really important from my perspective, yes, try and keep the fonts low. I'm not going to tell you how many families to use. That's between you and your designer. I like typography, so I'm not going to put a restriction on that. But it is important that you only load in the fonts that you need. When we were switching to system fonts at Octopus Deploy, I was doing an audit of the site, and I came across this section where we're rendering a Google login button, and we were loading the entire Roboto font family in TrueType fonts, which are very big, just to render a single button. That was well over 2 meg worth of fonts for no reason at all. So make sure you're only loading in what you need. Don't just whack everything in there and leave it at that. Now, another way to reduce the number of fonts that you need is to use variable fonts, which is something that I'm a big fan of. They're very well supported. They've been around for a while. And if you're not familiar with what a variable font is, it basically combines multiple styles of a family into a single font file. This eliminates the need for multiple files. And it does this by creating an axis, for example, a weight axis. It'll create a master instance like bold and regular, and then it'll generate interpolated values in between that, giving you a much wider range of options to choose from. But it doesn't just apply to one axis. You can have thousands of axes. That would be a huge font, but you can have thousands of them. And the interpolation applies to the combination of the axes as well. Now, the reason that I mention this is because you're probably thinking, well, that's going to be a really huge file. And it is true that a single variable font tends to be larger than a single individual font file, but typically they're better than the combination of all of the font styles that you would have on a page. Part of the reason for this is because in a single font file, there's a lot of data that has to be repeated each time, whereas when you have a variable font, that is shared across all the styles. So for example, a single weight of Source Sans Pro is 107 kilobytes. The combined of regular and bold is 214. And a single variable font for Source Sans Pro is 166 kilobytes. That makes the combined 22% larger than the variable font. Now, this might not always be the case. Sometimes they're larger, sometimes they're smaller. It does depend on the font. But it's worth checking out to see if you can make some savings by using a variable font. Right now, about 33% of all websites use variable fonts. Unfortunately, this is predominantly because of Google. They switched their most popular font families to Google fonts a few years ago. About 93% of variable font usage is from them. So if you are self-hosting and you're not using a variable font, it might be worth checking to see if you can get any reduction in your file sizes by doing that. Now, with that in mind, the next thing I want to talk about is making our font files smaller. The smaller the file size, the quicker it's going to load. So according to the Web Font Almanac, the average font size is about 40 kilobytes. This is actually bigger than it was in the last almanac, so fonts are getting larger. And it doesn't sound so bad, but all this kind of adds up, you know, especially if you've got multiple font files. And the easiest way to reduce your file sizes is to use better formats. In this example of Source Sans Pro Regular, the TrueType font is 75% larger than the WOF2, and this is because WOF2 is compressed by default, whereas TrueType fonts are not. According to the Web Font Almanac, thankfully the majority of us are using WOF2. However, we still have a bit of WOF and some TrueType fonts around on the web. If you're still using WOF and not WOF2, highly recommend that you switch to WOF2. You can save like somewhere between 15 and 30% by switching, just changing to a better font format. So if you've not done that, please go and do it. WOF2 is supported everywhere. It's the best format for fonts on the web. And if you're stuck supporting older browsers, you might want to consider using system fonts or fallback fonts instead of trying to manage all the legacy formats and having all that in your CSS. If you have to use TrueType fonts for any reason, I would highly suggest that you compress them using content encoding because they're not compressed by default, and as you saw, they're really big files. At Octopus Deploy, actually, when I was doing that audit, along with the entire Roboto family for the login button, I was actually able to remove nearly 2 meg of legacy font formats that we weren't using. And that was just under 7% of our bundle size. So, you know, if you clean up your technical debt, you can get some savings as well. Now back to TextLab with my page weight, that was 1,972 kilobytes for a blog. This number was directly related to my fonts. I was nearly 70% of my page weight. That's really bad. I was so embarrassed when that number smacked me in the face. And the reason that it was so bad is because the 2 variable fonts that I was using were 754 kilobytes each. That's 1,508 kilobytes for a blog. Yikes. In my defense, because I am a bit of a variable font nerd, it was like 16 different styles, but it's still a lot. And when I looked at that number and was like, oh, this is so embarrassing, something really obvious jumped out to me that kind of made me feel even more shame. And that was that I was using Roslingdale, which is my font for headings, for bold, non-italic headings, which meant I was loading a 754 kilobyte variable font to render a single weight. So, as much as I love variable fonts, I got rid of it and replaced it with a single bold, standard bold font, which was only 67 kilobytes, which means I could immediately reduce that number by 91%. Now, while I am very pro variable fonts, only use them if you're going to be making the most of the features they provide. If not, you're just going to be loading unnecessary data into your website, which will end up in the situation that I had, and that's really terrible. So I couldn't use the same trick for RobotoFlex, but I did go and check. I was actually on GitHub that I downloaded it from to see if they had a new version of Roboto and if they had made it smaller. And they had. I was able to reduce the file by 5.7% just by downloading a new version and switching it out. Now, both of these changes took me about 10 minutes. So you can, granted, switching the variable font was the majority of it, but you can make some significant changes just by checking if there are new files to download. If you can't download it yourself, you can check with the foundry that made the font. It won't always be smaller, but it's worth checking. So we are now at 778 kilobytes, which is nearly a 50% reduction. And again, most of that was the variable font, but we learn. Unfortunately, 778 kilobytes is still really, really big. So now we have to pull out the tools. And this is my favorite font tool on the entire internet, Waka My Fondu, which is an amazing name by Roll. And it's super, super cool. What you do is you dump your font in, and then it'll give you a whole bunch of information about the font on the page. So it's really, really cool. Highly recommend you check it out. Links are in my resources at the end, so don't worry too much about that. What I was interested in was the axes that existed within RobotoFlex. There are 13 of them. They do all sorts of stuff, but I'm only using these 5. So my theory was if I dumped a bunch of the axes, it should be smaller. So to do that, I used a tool called Slice. Now, before you go and do this, make sure that your license allows you to modify fonts, because you can get in trouble if you violate your license. But if you are allowed to modify them, this is a great tool. It looks like this. You dump your font in, and you can either put the default value in, which they kindly give you in square brackets, and that will eliminate the axis from the variable font. You can leave it blank, and it'll do nothing, or you can put a new range in. So firstly, I'm going to eliminate the axes that I wasn't using, and I was able to reduce it by 7.3%. This isn't as much as I was expecting. I kind of thought it would be more because there were so many axes that I was dropping, but I figure it's because the data exists in those 5 that I'm using predominantly, because they are the most common. So then I was like, okay, I'm going to have to, reduce the ranges as well. So I looked at the weight axis for RobotoFlex, which ranges from 100 to 1,000. And I didn't want to go through on my CSS because it was going to take too long. So one of the things you can do is use the CSS overview tab in DevTools. It looks like this. You can kind of get through it through more tools, and it gives you some information about the fonts you're using and like occurrences of things in your page. Or what I did was I made a little stats thing using the CSS stats API, but restricted it down to just the text and font properties. And it will tell you how many times the property, if the property is used, what value, and how many times. So looking at font weight, I'm using from 400 to 700 in my CSS, which means I can immediately drop stuff from the beginning and the end of the axis. So that's what I did, and I used this tool to check the other axes as well, and reduce them all to within the ranges that I was using, and was able to reduce it down to by 67%. So this is looking much better. We're now at 300 kilobytes, which is an 80% reduction in file size. So much better, thank you, yes, much better. But we still have subsetting left. If you're not familiar with subsetting, it's when you create a new version of the font containing only the glyphs that you want to use. Again, get permission before you do this. Not all licenses allow it. There's a great website called subsetting.xyz which gives you some information on this. Highly recommend you check it out. If you do have permission, there's some really great tools out there for subsetting. Zach Leatherman has Glyph Hanger, which is my favorite. This is the one that I use predominantly. It's got heaps of configuration options. You can pass a Unicode range in. It's got like a crawler. You can put a website in, a set of characters, lots of features to use. It looks like this. At its simplest, you could do this if your language that you're subsetting is Latin-based. Always format to WOF2, please, as we've established. This will subset the font to just the Latin characters. This is a really quick way for you to subset if your language is Latin-based, so this is what I'm going to do. But before we do that, if you want to go a bit deeper and you want to get really specific about the characters that you're subsetting, Paul, who spoke yesterday, great talk, Paul, by the way, has this awesome tool called the Web Font Analyzer, and you put a web page test URL in, and it'll give you all sorts of information about the performance of your fonts, so definitely go and check that out. But there's one part of it that I really use quite a bit. It's got this little table that shows you the visible glyphs on the page and how many times they're used. This is really handy for maybe characters that are non-standard in the Latin subset. So, I don't know, like the little arrow that's down in the bottom right for you. Now, I might not need this to render in my custom web font, but if it is important that I need to render in the font, then you know you have to include that when you're subsetting. So tools like this are really, really handy to make sure that you're not excluding things that you might need. So on TextLab, I was able to reduce Rosingdale by 39% and RobotoFlex by 55% by subsetting just to the Latin characters, which means I'm now at 145 kilobytes. This is a reduction of 90% from where I started, much, much better. It does equate to about 9 kilobytes per style, so I was pretty happy with this. At this point, I could spend a bit more time speaking to my designer, which is me, but, you know, and getting rid of some of those 16 styles that I was using. But I wanted to show you what you could do without having to involve a third party. You can do this without changing anything other than compressing everything. You don't have to, you know, negotiate with your designer about dropping stuff. You can just, you know, compress everything and not worry about that. But if you want to, you can go that far to make these files even smaller. Also, you can do some of these and not all of them. You know, you don't have to do it all in one. One day you could use WOF2 and the next day you could subset, you know, like, you can do it piece by piece. It doesn't have to happen all at once. And it doesn't have to take a long time either. So, my page weight has dropped by 61%, and my fonts are now only 19% of the page weight. It is now images that are my biggest problem, which I think is how it should be, really. And that's my next problem that I need to look at. Now, before I move on from here, I wanted to quickly mention the incremental font transfer. This was published by the Web Fonts Working Group earlier this year. It's a working draft at the moment, and its aim is to load only the portion of the font that you need when the page loads. This is going to speed up loading time and reduce that data transfer. It also means that the font can be loaded over multiple requests, where each request is incrementally going to add additional data. So when this is available, it kind of eliminates the need for subsetting altogether. It's a really, really interesting feature. I've included a bunch of resources to go and check out in my link at the end. It's got some really great demos. Highly recommend looking into it. It's going to be really, really cool. I'm really excited about it. So the next thing I want to talk about is displaying fonts. Everything we've looked at so far is about less or smaller files. But we're always going to be faced with the same problem, whether you leave it invisible until the custom font has loaded, or if you have the text visible using a fallback and then you switch it out. And it's kind of that flash of invisible text, flash of unstyled text problem. We manage this using font display, but each of the options of font display have some kind of trade-off between aesthetics and performance. Now, there used to be a bunch of ways that we could handle this with JavaScript. I am not going to talk about that because I think we can solve it without JavaScript these days, and we'll get to that as we go through the talk. What I will do is go through the different font display options so you can kind of see how each of them work. Essentially, it has a timer that begins the moment the user agent attempts to use the font face. They look like this. I will go through them in a little bit more detail. I'm going to skip auto because that's defined by the user agent. But before I do that, the Web Font Almanac shows that the most common font display property is swap, with block coming in second. The prevalence of block kind of surprised me a little bit because it's not really good from a UX or performance perspective. And the reason for that is it renders invisible text for up to 3 seconds, which is a really long time. And then at that point, it has an infinite swap period, allowing the web font to load in whenever. Typically, you'd pick this if the web font is critical to the experience of your web page. As a result, it's most often used for icon fonts because a fallback for an icon font is kind of useless. I don't personally think we should use icon fonts. I think you'd be better off using inline SVG or something like that. But if you are using icon fonts, block is typically the way to go. And the Web Font Almanac does support that because the majority of use cases for font display block are icon fonts. As an aside, if you're using emoji fonts, it doesn't have that problem because emojis encoded in Unicode, so you can use them with no problems. Now, outside of the outside of the icon fonts consideration, the other problem you have with this is that the invisible text is not just not there. It's actually rendered in the fallback text. So you can still get a layout shift with this because of that really long block period. So it's really not a great choice. Fallback is similar to block, but the block period is much shorter, to 100 milliseconds, and the swap period is only for 3 seconds. This is better, and the invisible text is less of a problem because usually that will have rendered before the initial paint. Now, the best option for performance is font display optional because it's got that really short block period of up to 100 milliseconds. If the web font is not loaded by that 100 milliseconds, it will load the fallback and it will never load the web font on that page render. It doesn't swap out at all. At this point, though, the font will be in the cache, so the next time it loads, it'll be really quick and it will load in. So this is why it's usually the choice if you want to prioritize performance. It's much better in the sense that your text loads really quickly and you get a better largest contentful paint as a result of that. Also, because the block period is only 100 milliseconds, you tend not to have the layout shift issues because the font is only loaded for the initial paint as well. So with TextLab, if I switched to font display optional, it eliminated my layout shift, which is really, really good. But I really like fonts, so I didn't want to do that for both of them. Instead, I decided that I needed to have my headings always render in Roslingdale, because the risk with optional is that it might not always render the font that you chose. So swap, being the most popular choice, has an infinite swap period. So it'll render your text in the fallback, and then it will swap out to the web font whenever it's ready. The problem with swap is that it almost always results in layout shift caused by fonts. So it's really good for slower connections in that the text is available immediately, but you do have that extra work of trying to solve the layout shift problems, which we'll talk about in a minute. Now, as I said, for TextLab, I went for a mixed approach, swap for Roslingdale and optional for Roboto. So I still have some layout shift, which we'll look at fixing in a minute. One thing I do want to note, though, is if you've deemed your font not important for the rendering of the page, maybe you don't need a custom web font and you could just use a system font instead. But we're going to pretend I'm going to keep it. I will keep it because I like the font. So the next thing we're going to cover is layout shift. Now, the reason that fonts cause layout shift is because there are almost always going to be differences between the custom font and the fallback font that you're using, whether it's different sizes, that kind of thing. Essentially, it can cause elements on the page to resize and text to reflow, moving everything around the page. Now, the way you can figure out layout shift using the new DevTools thing, really cool. Or like Web Page Test has the film strip view, which is what this is from. Or if it's really terrible, you can just see it when the page loads and it looks really awful and janky. So I've set up this little demo. It's my dog, Jello, Sir Gelatin. I'm using Oswald and Arial just so you can see how obvious it is, because Oswald's a lot narrower than Arial. And as you can see, as the text loads in, it jumps up and the page shifts. Now, the way that you manage this is using CSS, and we used to do it with things like line height and letter spacing, and Monica Dinkulescu had this really great tool for figuring it out, which is how I used to handle it. But now we have size adjust and font size adjust CSS properties. And they do slightly different things, but they both aim to render text in a similar way, regardless of the font that's being used. So the first one we'll look at is size adjust. You use this with font face, and it aims to adjust the X heights of the font. Without going into the deep anatomy of fonts, the X height represents the typical height of the lowercase letters. It is similar to the height of the X, but that is not always true. So in this case, it's the height from the baseline, so the bottom of the U, to the top of the U. It excludes the descenders and the ascenders, so the bottom of the Y and the top of the lowercase f's. So I made myself a little tool. It's up on TextLab. It's also on CodePen, just so I could kind of see how this worked. And as you can see, actually really good demonstration of why you get layout shift, because as the text sizes, you get reflow. And I just pulled the slider to try and match it to Oswald. So I landed on about 81%. One thing to note is that there's also the ascent override and descent override, which adjusts those ascenders and descenders. I won't go into them, but they're also really useful for this problem as well. There's also a really great tool by Multi-Ooble called Perfect-ish Font Fallback. It loads all of the Google fonts. You pick one, and it'll spit the font face out for you. I checked what he had for Oswald, and it was 81.66, so now my tool has decimals. Really awesome. Highly recommend you check it out. The way that you use it, much like we create font face for our custom font, we're going to do the same thing for our fallback, in this case Arial, except we're going to give it a different name. I went with Arial Fallback, but you could call it whatever makes sense to you. Jello would be a good name. For source, you use the local value with the name of the fallback font, Arial, and then you add your size adjust percentage, which we landed on 81%. For the font family, exactly the same as you normally would, but instead of just saying Arial, you give it the new Arial fallback instead. So as a reminder, this is where we started with the jankiness, and with size adjust, that's where we end up. Thank you. Yeah. So with size adjust, it is completely possible to significantly reduce or eliminate the layout shift issues. Now, you're probably thinking, well, Mandy, why do we need font size adjust then? And the reason that we have font size adjust is this is applied slightly differently. Size adjust is, I guess, applied more globally at the font face level. Font size adjust is applied at the selector level. And it's similar to size adjust in that by default it'll match X heights, but it also has some other features. There's the ch width, there's cap height, there's IC width and IC height, which is for Korean, Japanese, and Chinese characters, and some other options. I'll use X height as an example because we've sort of talked about that already. And what it does, so here we've got Arial and Inter, and in this case Arial is narrower than Inter. What font size adjust does is try to render the fallback font at a size that's different to match the custom font. So in this case, we'll render Inter at 16 pixels, and we'll render Arial at 20 so that they align. And the way that it figures this out is by taking the aspect ratio of the font, and then it does a calculation to figure out what the pixels or font size should be. How do you figure out what the aspect ratio is? Heaps of tools online. I like this one by Richard. Really simple. Chuck your font in. Pick the style, the weight, if optical size, and then hit calculate, and it gives you the aspect ratio. It is really important that you fill in those other options because the aspect ratio can change depending on the style, the weight, etc. So I set this one up with Jello again. In this case, it's not as obvious, but now it expands past the line a little bit. So to fix this with font size adjust, you can set it up in your code like this. So we've got our font family, exactly like normal, no fancy font face. Our font size, 16 pixels for Inter. And then font size adjust, which is, this case is 0.516. And now when it loads, we have the same fix, no layout shift occurring. So the places that you would use font size adjust is if you've got a lot of variation in the font. So for example, with Roboto Flex, I use a bunch of different axes to change the stretch, the width, the optical sizing. So applying it at a global level is going to be a lot more difficult, whereas font size adjust at each of the places that I change the font variation settings allows me to have that more fine-grained control. One thing I do want to mention about layout shift is be really careful with relative units like the ch unit. I don't know if that's how you say it, but that's what I say. That unit is relative to the size of the 0 character in the font. So as your fonts shift, you're absolutely going to get a layout shift with that. And the reason is that it's going to change depending on what font you're using. Especially terrible if you use it for letter spacing. So just be careful of those units. You can adjust it with font size adjust. It's got a from font option and the chart width option, but it's a lot more difficult to manage. So if you're having a really hard time and you're using those units, you might want to consider getting rid of them. So for TextLab, I only had to modify Roslingdale, use size adjust because it was global and they were all the same. If I was going to apply it to Roboto, I would use font size adjust for the reasons that I mentioned just before. But I was able to eliminate the layout shift completely because it was all based on my fonts. So now we have no layout shift in the website at all. So to finish up, now that we've fixed our layout shift and we've got nice small file sizes, I'm going to talk about loading. Now, the first thing that you want to do, I'm going to say this the Australian way, you need to cache your fonts. And it's a very Aussie way of saying it. I'm very sorry if you want it the other way, but this is what we do. Now, because fonts are static and they're not typically updated regularly, it makes them ideal for long max age expiry in your headers. So make sure that you're caching your fonts. If you're not already, this will do it for a year, adjust to suit your needs. Really simple, easiest thing to do, will improve things quite a lot. And the other thing to know is that a font is only downloaded if it's referenced by the styling in the page, meaning your CSS needs the font face. It also needs a selector targeting an element that's on the page that references the font family. This means that how you set up your CSS can have an impact on how your fonts load. A simple solution to this is inlining your fonts in your critical CSS in the head of your HTML. Just make sure you're only doing this for fonts that you actually need right away. You don't want to inline all of your fonts if you're not using them straight away. I think this section kind of comes with the caveat of like, use with caution, because you can do bad things by doing it wrong, as Paul's performance mistakes talked about yesterday. You also want to make sure you prioritize the most important font first when you're inlining them, because that will kick it off quicker. You can also use resource hints. I'm not going to go into a lot of detail here because Paul talked a bit about this yesterday, but also Robin's talk last year at this conference called Resource Loading at the Cutting Edge was so amazing. If you weren't here, even if you were, you should go and watch it. It's one of the best talks I've ever seen. Go check it out, really awesome. From a Web Font Almanac's perspective, pre-connect and DNS prefetch are the most commonly used, with preload coming in third. And the reason for this are primarily third parties, particularly Google, which uses pre-connect for speeding up the connection to the web font services. Preloading is the most commonly used for self-hosted fonts, and it is the most impactful, but as we've heard, it does come at the cost of deprioritizing other assets. Now, Paul mentioned this yesterday, use it with caution. Whether you use it really depends on your situation. It's really good for a small number of fonts. Not great if you've got a lot of really large fonts. And you also really don't want to be preloading your legacy fonts either. Only preload WOF2, please. So it's kind of a depends situation. I can't really tell you if it's right for you or not. Always test these things. You might find that inlining your CSS font declarations and adjusting your style sheets a bit might be a better strategy than preloading, so it's definitely a testing scenario. But, you know, if you're interested, font loads down lower, starts at 1.32 seconds. With preload, it's a much higher priority and starts a lot quicker. Again, Australia, if you're wondering about these numbers, it's slower for us down there. This is how you use preload, which we saw yesterday. Really important you use the as font type so that it will preload. It also tells the browser what asset it is, and it helps with the prioritization. Also include the type, so in this case it would be WOF2. If the browser doesn't support that format, it won't try to preload it, which is really good. Most importantly, include the cross-origin attribute. If you don't, it will fetch it twice. It'll preload it, and then it'll forget, and it'll do it again. It doesn't matter if it's on a different origin or not, and that's because fonts are caused by default, so do make sure you add this on, otherwise you're just going to make everything worse. And if you're using like JSX, make sure you capitalize the O, because otherwise you'll be wondering why everything's so bad, which is what I did. It also depends on what you use for font display as to whether you use preload, and Paul talked a bit about this yesterday. You don't want to be preloading something that you have deemed not important. When you Google this, it's really confusing because everybody says something different. And a really good example of that is font display optional. Some places say, you should definitely preload font display optional, and some places say, no, you shouldn't preload font display optional. In my experience from testing this stuff, particularly with font display optional, I kind of landed on the side of don't preload it. Come and tell me if I'm wrong. But the reason that I was on that side of the fence is that the font is either already in the cache, so preloading it is a waste of bandwidth, or it's not likely to load quickly enough and you're going to get your fallback font anyway. So again, it's kind of a waste of resources. So you're better off assigning that bandwidth to other more important resources that you want to load, given that it's probably not going to make that much of a difference. So I guess what I would say about that is don't preload and pre-connect all the things. Consider it against your other assets. Make sure that you're testing. It's going to vary for your situation, what kind of fonts you've got, what other assets you have. This kind of performance optimization can't be done in isolation, like compressing files can. You have to think more holistically. So it's kind of hard to say what you should and shouldn't do. Just do your best is probably how I would approach it. So to recap, we ended up here. No layout shift, 61% reduction in page weight, and my LCP dropped by 33%, all by optimizing my fonts. So I sped this up to normal loading time to remind you what it was like, but it's not as painful this time. So in case you missed it, that's what it is. Not too bad, but it's a little bit janky. But with the optimized version, that's it. It's much better, right? And this is a blog, so doesn't take a long time to load. So if you can imagine on your much more complicated, much more serious websites, you can find that you can improve things quite drastically just by looking at fonts. Now, just to summarize everything that I've just said, just to make everything I've talked about totally useless, you want to self-host as few probably variable WOF2 fonts as possible that have been sliced if they're a variable font, subset, and maybe preloaded. They'll be cached, and you'll either swap or probably optionally display them. And you want to make sure you're either using font size adjust or the size adjust CSS properties to reduce that layout shift, or hopefully eliminate it altogether. The other option is to use system fonts. So thank you so much for listening. This is my obligatory Jello picture and my resources up on GitHub. The choice is yours, how much you want to do, how deep you want to go. When you're applying these strategies, do all of them, do some of them. But a few simple approaches, they don't have to be time-consuming, and you can definitely improve your performance by doing all of this stuff. So thank you so much. My resources are online.
Thank you so much, Mandy. Come have a seat.
Thank you. Hang on one second.
Oh gosh, my voice is like progressively getting worse as the day goes on. I apologize.
I'm so happy that I put Jello on this slide so you can all look at him.
So how is Jello? Is Jello being taken care of while you're here?
Oh yeah, he's with my mum, so he gets to do whatever he wants.
Awesome. Okay, so a couple of questions have come in. We're not going to have time for all of them, unfortunately, so folks will have to grab Mandy at the next break. So the first question is, do you recommend self-hosting web fonts on your CDN or on your origin?
I think it depends on how you set things up. Either is fine, but if you're going to self-host on the CDN, that's when you want to use things like pre-connect rather than, not at all. So it just kind of depends on what your approach is. I don't really think there is a right or wrong there. Just make sure that you're probably using pre-connect. It's so hard to say if you should or not because everyone's situation is different, but that would probably be how I would do it.
Yeah, I mean, I think really a lot of it depends on if your CDN is hosted through the same origin or not. Yep. So there were a couple of questions that came in that were sort of around subsetting and predicting the future. So what happens if you subset a font to load only Latin, but then someone uses like Google Translate and they translate to a different language? What do you do if you subset characters that you don't need now, but maybe you need them in the future? Yeah, so it's not like it won't render anything. It'll just render in the fallback font. So it might not look as nice, but you'll still get text. So yeah, if you find that that's happening, then you probably want to go and adjust your subsetting. Also, if you're, rendering, how sometimes you change the language, you could just load that font in when you need it, and you can subset to the different languages and only render them when you need them. But you're not going to end up with nothing if you've accidentally subset and excluded a character. It'll just look slightly different because it'll be in the fallback font. Yeah, so makes sense.
Yeah.
Awesome. Well, thank you so much, Mandy.
Thank you.
That was an excellent talk. I learned a lot.
Good luck.
All right. Next up, I think this might be a Perf Now first. Our first ever married couple doing a joint presentation. We have Erwin and Karlijn. They're both, they work together. They're at Rum Vision. Karlijn is the CEO, of course. So they work together, they live together. They care about INP together. So they're here to share with us some case studies on INP and how to improve it. So yeah, welcome to the stage and thanks so much.
Thank you. Yeah, hi everyone. We're very proud to be here today and to talk to all of you. And we are here to talk about INP. And you know what the fun thing is about INP? It measures interactivity. And we figured, after a day and a half of only listening to people, what about... but I didn't, so yay, Akamai.
We actually have some merch as well. Maybe Jordi can pick it up from the Albert Heijn task.
Oh yeah, we do that.
Yeah.
So Please join us, and I will wait a little bit for you to do so. And just to say, well, how awesome has this been for now? I mean, what incredible insights have we had? I've loved it. So please join us. I'm kind of waiting.
Apparently, 14 people are already questioning their presence here today.
Oh yeah, no, worse yet. 2 people are actually doubting their decisions to, partake.
All right. Well, nevertheless.
Because, well, guys, as we're waiting, hey, Erwin, stay away from me.
Oh, sorry. Responsiveness. It's all about responsiveness.
Yeah, no, sorry. As we're all here, welcome to field data versus lab data. You guys are my field. So if we're going to talk about core web vitals and stuff, we like to look at field data, which is the one that you're seeing on my right, and not to Lighthouse, if we have that field data available. And I'm guessing we are now at a maturity. So I would like to ask you something. When we're talking about interaction with a page, what annoys you the most? You can give us a score. Do you hate the most that it has lag when filling in an online form? Do you hate the most that there's a menu that is slow to open, or a delay after clicking and add to cart or FAQ? I would actually be quite interested to find out where this leads us.
Quite equal.
Yeah, really quite equal.
Yeah. All right, cool.
Yeah. So actually, to me personally, I think that lag when filling in an online form is the most annoying. But the good news, guys, is no matter what frustrations you have here, IMP will measure it, which is awesome. So who are we? Well, we figured we could introduce each other. So hey, meet Erwin Hofman. He's the co-founder and CTO of Ambition. He's a web performance consultant. He's a Google developer expert in web technologies. He's a trainer and public speaker on helping you get better performance on your website, mainly to e-commerce. And he's kind of famous on LinkedIn.
Thank you. Do you go to the next slide?
I will.
All right. Well, this is Karlijn Löwik, my wife as well, CEO. So yeah, she is my boss, in fact. Co-founder of Runvision, MageWest, the Netherlands, board member, as well as Lady Magento. And obviously, she also yesterday announced that she is part of the, co-chair basically of the W3C community group. And she also talks at venues in New York, London, Nantes in France, and Amsterdam again. Yeah.
So the last time the 2 people were on stage,
This happened.
yeah.
So let's hope it will be better today. And this was also, by the way, the talk that Mandy was referring to.
Yeah, So who are we? Who is Runvision? Well, we are a real user monitoring solution, and we're actually built on the Web Vitals EAS. So if anyone was ever struggling with that, I understand. We are 3 years in, and we're still developing as we go. So we are based here in the Netherlands. Yay! Who is from the Netherlands as well? Give me a thumbs up.
Or a thumbs down.
Nice. Yeah. So, we have been having the IMP breakdown and LOAF since 2023, which gives us an awesome data set today to talk to you about IMP. And our goal is to get real user insights to all stakeholders, whether they are SEO, developers, front-enders, business owners. We just want to improve performance.
All right. If you want to learn more about the Web Vitals library, by the way, Jeremy talked about it during Google I/O. You can find the video online as well. By the way, all links will be found afterwards and shared on the internet, so you can take pictures, but don't worry if you miss any slides. But he's talking about using the Web Vitals library to collect IMP data as well as LOAF data, and that's what we have been doing as well.
Because you can't improve what you don't measure. So this I actually need you for.
Yeah.
Because when we talk about interactivity, well, all of us, this is a 2-day event. We had to book a hotel. And the interesting thing is that when you think of interactivity, especially when you used to think about first input delay, you only measured the first thing.
Yeah, this one is failing us, so I'm going to try again. Typical example of IMP, maybe.
Yeah. So what do? Well, you do many interactions. You choose where to go. We went to Amsterdam. Then you need to add the dates. What date do you want? In what date range? Now I'm done. That's an interaction too. How many rooms do I need? How many adults will I take? I mean, I had to take my whole team, so we're present here. Actually, we left the child behind, but I didn't know that when I made this. All these things are interactions, and they are all measured in interactivity delay. So this is why Fit got kicked out, because IMP is better, because every single one of those interactions gets measured in IMP, and it will report the slowest one. So on March 12, 2024, it was a memorable day for all of us in the web performance community, because we got rid of Fit. Actually, I believe Rick Viscomi made a song, and you should ask him about it, because it was amazing.
Using AI, I think.
Of course. Yeah. So on September 9th, 2024, Fit got completely kicked out of everything, and we no longer have to talk about it. So this is actually our farewell to Fit. Bye-bye. Because, well, this was actually referenced yesterday. The front-end sadness index told us that actually IMP and interaction got much sadder, but it wasn't. The sadness was always there.
We just have a better metric.
Yeah. So here's an interesting thing to back up that hotel booking that we did. More than 25% of IMPs actually happen after 20 seconds in a page, or even more interesting, 50% happen after 10. This means that if you're going to improve interactivity, you would want to measure all of those interactions. And we actually got this out of our own data set. We made it for the Perf Planet, which is happening again this year. So if you have any great ideas, reach out to Stojan. He's over there.
Afterwards at the help desk.
And he would be happy to talk to you about it. It's aside from this conference, the performance happening of the year. Because when we look at our own data set, what is actually very interesting is that the most interactions actually happen after it's been completed. And this is why having real user monitoring is better than only looking at Lighthouse, because that won't show you the things that happened after it got completed. So just to recap, meet the core vitals, and this is IMP. We would like every interaction to be below 200 milliseconds, preferably even faster. We already learned that 100 milliseconds would be even better, because you can't feel that. But as we are both working for mobile and desktop combined here in IMP, we like it to be at least below 200 milliseconds. Yeah, so, well, I mean, the Web Almanac has a great showcase, and we're actually doing it again. Because what is really interesting is that we see in the Web Almanac that the difference between mobile and desktop has improved massively over the last 2 years, which is great. However, there's still a 23% gap between mobile and desktop. So let's stop talking about us and start talking about you.
Yeah.
Who are you?
What kind of roles do we have today?
Yeah.
Mainly developers. All right. Other people? Anyone that wants to elaborate on other people? Other roles? No? Fully anonymous today? Fair enough. All right. Let's continue.
No, actually, let's
Yeah?
I mean,
Okay.
we are here with 350 people. We can get this up. Come on.
No, but I think only about, well, this amount of people actually joined.
Yeah, okay. Well, I think we can say that the majority of people here today are developers, which is great because you guys are the one that actually can fix Core Web Vitals. So you absolutely came to the right conference today. So what was your knowledge of IMP before, well, attending today? Did you actually have you never heard of it? Have you heard of it? Have you looked at it? Have you worked with it? Have you improved it? Or, because this is a special room, have you basically invented it?
Could be the case today, apparently. Yeah. So we also have a quiz today, so maybe 8 people should not join the quiz,
Yeah.
as you have an advantage.
Yeah, but this is actually a really interesting data set.
It is, yeah.
Yeah, so thanks for that. This is why I want field data. So, because I'm giving it to Erwin now, let's gear up.
Yes, all right. Well, here we go. The faster you answer, the more points you get, if the answer you gave is correct, obviously. And you should be able to pick a name, use the name of your pet, like Yellow, or if you think you're going to be good today, then use your own name. And then maybe people from Google should use a prefix, and Google people from SpeedCurve, etc., so we can recognize them, like GC and SC or whatever.
And if you're not feeling confident, then use your competitor's name.
All right, 212 people ready. Okay, cool. Going to be fun. Here we go. 213, 14. Yeah, let's go. Start the quiz. Once again, the faster you answer, the more points you get.
As this is a performance community.
What matters for SEO? Is it Lighthouse score, Core Web Vitals, page load time, or nothing? Well, some things matter for SEO, but from a page speed perspective. Okay. I'm not sure if I should elaborate on Lighthouse. It has been talked about before by Harry, for example. But yeah, you should focus on Core Web Vitals, as that matters for SEO, but also, obviously, for real users and eventually revenue as well, or conversion in whatever form. All right, next question. What has the biggest impact on IMP? The faster you answer, the more points you get. What has the biggest impact on IMP? Is it CSS, HTML, JavaScript, or my patience, or your patience? Let's find out. All right, I don't have to elaborate too much here. Just moving on, third question. Here we go.
Did we not already have this one?
What has the highest correlation with IMP?
Oh, we
Is it
don't.
internet speed, someone's device, or user location? So user location could be correct, although indirectly I would say, because maybe people in other countries not as wealthy, where, well, yeah, people might not be as wealthy in, for example, the north of Europe. They might buy different devices, so it is an indirect factor, but eventually it is someone's device. What kind of devices do you have? No points to be given here, but...
It will be interesting, because we keep talking about all of us having high-end devices, but is that actually true?
So this is basically illustrating that, well, it has been said before, yesterday, and maybe even today, that no one is using the same device, so everyone is browsing under different conditions.
Yeah, but it also illustrates an interesting fact, that congratulations to all iPhone users. You are not part of the Core Web Vitals dataset, and we cannot measure IMP on you. You are therefore not representative.
Not in Crocs. No.
So if you want to improve your client's Core Web Vitals, my tip to you, buy a high-end Android phone. That will actually improve their Core Web Vitals if you use it often enough. But however, hey, you know, those low-end devices, actually maybe all of us should be testing on those, as has been made as a point many times today and yesterday. Because what do we see? We see that IMP device memory has an incredible impact. You see that if you have 1 gigabyte or 2, your IMP on the 75th percentile will be much, much worse than if you have an 8 GB device. So those people are really, truly suffering on IMP, and we should help them.
This is a clear correlation, I would say.
Yeah. So let's get even more technical.
All right. Well, as shown before, users are doing multiple clicks or in interactions in general during the page life cycle, which is why FID came short. And it's not like, well, yeah, we don't know which one is resulting in most frustration. That's what IMP is about and what IMP is able to show us. If we're looking at a main thread, my wife likes to joke that men, for example, can only do one thing at a time.
You can't multitask.
So if I'm watching Netflix or playing a video game and she tries to communicate with me, then I first have to switch back, pause, and then processing what she has been saying. So I cannot join the conversation right away, for example. Or otherwise, if you're trying to take a picture of the slides and then the next question is coming up, then you first have to switch back to your browser to participate. That could be called the input delay before you can even participate. So that's as shown over here as well. First of all, this is basically the IMP breakdown, the so-called subparts. So we've got the input delay phase, processing time, and then presentation delay, where whenever I try to interact with a web page, some other JavaScript or other tasks in general might still be running. So the browser cannot come back to the event handlers or to your click interaction. And that's also something to take into account. As a matter of fact, FID was only tracking the first part, only the input delay, while in reality there is happening way more. And that's why, as we could see in the sadness index, a lot of sites started to score worse once IMP was introduced. You might figure, okay, could we then just delay all JavaScript and be done with it? Yes, you can, technically speaking. As a matter of fact, you might even get a better Lighthouse score, which you can then post online on LinkedIn and get a lot of likes, probably. But in reality, and as it's about real users, and as most interactions are happening after 10 seconds, maybe even after 20 seconds, you might only fool yourselves and stakeholders, while in reality, IMP might still be happening. So always be sure to keep looking at the core Web Vitals IMP metric instead of, only using Lighthouse or synthetic testing in general. And over here we can see that looking at percentiles, again, data from Web Almanac. You can easily see that once you go from the 75th to the 90th percentile, it is especially the input delay and the processing duration phases that are hit the most. Maybe Alex Russell would even say that the P90 is caused by React, but we can certainly see that that's where most challenges are. Another question. 4 out of 6 questions, actually. All right, I think we actually had about this amount of people, maybe? No, 214, I think. So maybe
some people got scared
40
after the
people,
SEO.
yeah, dropped out already. So I'm going to continue. Once again, the faster you answer, the more points you get, if it is correct. Which Lighthouse metric is closest to IMP? So if you cannot measure IMP, which Lighthouse metric is closest? Time to first byte, time to interactive, or total blocking time? All right. Maybe 13 people are at the wrong conference or should have a chat afterwards with us, as we will be at the help desk later on. But it is total blocking time. As a matter of fact, although most people voted time to interactive, it isn't even part of the Lighthouse interface anymore. It's still part of Lighthouse under the hood, but not part of the UI anymore. Even if you would go to web.dev, you would see it has been changed recently. You would see
Thanks, Jordi, by the way, and Barry.
You would see that Google is stating over there as well that you should focus on IMP over time, total blocking time. A lot of things has happened, changed, improved, as a matter of fact, because yes, the performance panel has been overwhelming and will certainly still be overwhelming when opening DevTools for the first time. But this has made my life, and probably the life of many performance consultants, easier. Whisker certainly did. The new performance panel that Jack talked about as well. Schedule yield, for example, that was being introduced. And I think Jeremy is going to talk about schedule yield during the live demo later on. But also the introduction of LOAF. And although LOAF isn't directly part of the performance panel, it does make our lives easier, especially, once again, when tracked in the field.
Because actually, talking to many of you the last year, and Erwin as well, when we were in 2023, IMP was hard. Debugging IMP was hard. So if your site had good IMP, then all was fine, no issues at all. But if it wasn't, what kind of tools and solutions did you really have to help you? And these four things actually improved our lives by a lot. And actually, they're all Google solutions. And I really want to give a shout out to the Google team to give us this.
I see one question mark, so maybe I should elaborate a little bit on this, but what you're able to see when using the LOAF API is you can see an array of scripts where, indicating basically which scripts or tasks were blocking the main thread for what duration, and it's only anything that is running for more than 5 seconds that is being reported by the LOAF API, but that's already valuable information, as we can see, the exact line number, function name, although often obfuscated in real life, so it's not really usable. But the source URL is, as we can now, you could say, point fingers, maybe. And if we dive into the invoker types, we can see that, based on our data, at least from Vision data, 88% of IMP issues are coming from, interactions. And they do result in the best IMP score. So the other invoker types typically result in higher IMP scores. But this does explain and illustrate that it's not only third parties that were running during an interaction, it might also be caused by maybe first-party JavaScript responsible for event listeners and coming back with feedback once an interaction happened. Just to showcase, illustrate what each invoker type is, although I did not include all of them, but this is what you have to think about when talking about event listener, user callback, and, for example, classic scripts. Another question, almost last one, 5 out of 6. All right, I'm going to continue. Here we go. The faster you answer, the more points you get. Which category of scripts has the greatest impact on IMP, the biggest impact on IMP? Is it advertising, consent providers, RAM scripts, social pixels, user behavior, or other third parties? I did not even mention Google Tag Manager. But it is, yes, user behavior.
Well, it's actually not advertising, I think we should say.
Yeah, correct. Yeah. But we'll come back to that later on. Because we've got the 6th and last question of today. Maybe a trick question, so, or not. All right, more people joined, so I'm going to continue. Who was the first and last Dutch speaker at performance.now? Was it Max, Jos, or Bas? A lot of people are quick to vote. So it is Bas. Bas Schouten talked last year at performance.now. But the interesting part is of this data, either you are Bas, or you know Bas, or you know Max and Jos Verstappen, and know that they did not talk at performance.now. But we don't have that kind of data. So we don't have additional data to prove and say and segment what is happening here. Basically, we are missing attribution. And that is what LOAF is giving us as well. It is giving us way more data to digest and to segment and to draw solid conclusions, for example. As a matter of fact, based on our data that we collected with, as part of RUM Vision, I initially called this our Git blame, but I wasn't allowed by my CEO and boss and wife to do so. But this data is basically showing what is blocking the main thread during an interaction. So I could try and chase all third parties on my web page in synthetic data, for example, while in reality some third parties might never really be a bottleneck. And obviously, as a performance consultant, I only want to spend time on those that are actively blocking the main thread during an interaction. And that's what this data is showing. And we can see the Google Tag Manager in reality is not really the biggest issue. Even Facebook Pixel is not the biggest issue. This is recent data, by the way. On mobile, P75 mobile data. All screenshots are P75 mobile data. While we are able to see that Bugsnack or Heatmap or Hotjar might not be the best third parties out there to use on your website or use with care. While the data is also showing that some cookie notices might not be the best pick, Consent Manager, for example, while other cookie notices are doing way better. And with this data, we can show site owners, if they see that some third party is causing issues and they click on their own Consent Manager platform, they can basically compare their solution with other CMPs to be able to tell that the CMP that they picked might not be the best pick, and maybe they should move to, I think it was Accept.io, and there was another one, Cookie Yes, which aren't blocking the main thread for that long during a user interaction.
So Jason, to get back to your talk yesterday, we actually have good news. We can do this.
Apparently Google Chrome already heard your
They heard your cry for help, and they provide it. And we can visualize it for you.
All right, let's move on to some IMP cases. Talking about long animation frame, Google introduced it, it was last year as an origin trial, and Taboola was one of the first, well, maybe you want to explain?
Yeah, Taboola was actually one of the first public use cases that was available based on the LOAF API. Taboola is a content recommendation provider, and what they were struggling with was that total blocking time actually wasn't as valuable to debug their issues. It had limitations. And then they tried the LOAF origin trial, and that got them really good insights. And based on those insights on the animation frames and on which issues were actually harming the user's experience, they improved. And they improved a lot, because that's the fun thing about being a RUM. We actually have the data to show that that improvement was, in fact, 88.3%. That they were taking less JavaScript to get in the way. That's from the last year. Our data shows actually a 54. This also trips me up in English. 45%, no, darn it, 54% for 2023 December to 2024 example improvement. And if you want to know how they did it, they actually wrote a great case study of it that I would recommend you looking at, because this is really the first showcase that we had for LOAF that showed its value to developers, as you all are, to get better insights to improve interactivity. So here's the second one with Guru, who is a Shopify merchant. This was actually the first one that we spotted when we started to take place in the origin trial of Google as well. They asked us, as we were already collecting IMP and were running on the Web Vitals library, and so could quite easily fit it in our tech stack. So what did we see? Well, we saw this really weird thing happening, and we looked into it, and we saw that it was Moment.js that was still around. So, you know, that wasn't good. So we reached out to them, and they were like, hey, Big Sur AI, we know you're having a moment here. AI is big now, but could you maybe remove Moment.js? And they did so, because they weren't even using it.
We actually ended up asking them to, advising them to replace moment.js. And when we looked afterwards, once IMP improved, we figured, okay, maybe they did replace it. We were surprised how fast they did, by the way. And then we looked into the source code, and there was no date formatting library to be found anymore. So apparently, it wasn't even actively used, basically, as Alex Russell talked about yesterday as well.
Yeah, so what do we learn from this? Well, regularly check your dependencies. But there's another interesting learning that I would like you all to keep in mind when improving IMP. IMP is not a magical solution. Even though this win was really great, as we can see from the data set from moment there to there, this third party wasn't in the way anymore to users' experience. That does not mean that on origin, all issues in IMP were resolved. It actually was only a 2 millisecond win, because IMP is many interaction in a page. So you might think that you have improved your slowest IMP, and you probably have, but what happens then? Well, your life is not easier, no, you get a new slowest IMP. So IMP is quite a process, and probably will take many times to improve small things or larger things, but just, don't get frustrated, it's part of the process. But hey, when you're wondering whether you actually are running deprecated JavaScript, Lighthouse actually has a really good check on this, and I would recommend looking at it. Look, I don't hate Lighthouse completely. There are absolutely values to it, and this is really one of them. Check your dependencies and see if you can update them or remove them when you're not using it.
Which is, I would say, also the power of LOAF, because I would say this was the responsibility of the third-party supplier to do so, to check in Lighthouse. The website owner that is just installing a third party isn't really going to do that, and also thinks, I cannot fix this because it's a third party. And that's where LOAF data comes in as well. It is able to really, once again, git blame a specific third party. All right. Another case, the online drogist, a Dutch pharmacist, you could say, online pharmacist, the biggest one, if I'm correct. And we only did two things, and it's only one, I guess, that really improved IMP, but I still want to elaborate on the other one as well. We only did two things and saw IMP improving. One of them was CPU versus GPU animation, where we basically ended up offloading the animation to the GPU, so that it was not happening on the main thread anymore, and as a result, not blocking the main thread, meaning that other JavaScript could run at that very moment, for example. And it only involved these two changes. So we basically, they used a probably third-party supplier for image gallery, and they were using the left property, which we changed to transform. And luckily, you still have a lot of freedom and flexibility when using transform. You can use skew, scale, rotate, and translate to move pixels to the side using the GPU. So that was a technical win. Unfortunately, they deployed these two wins at the same time, but with the knowledge of a performance consultant, I'm able to say that the wins especially came from this, because they just added event listeners to a lot of interactions on the web page using Google Tag Manager. So as a result, obviously, if you try to click on something, even the next slide of an image, I don't know why people and merchants want to track how often people are sliding to the next image. But they did. They ended up tracking that as well, meaning that whenever I tried to click, and I did not elaborate this over here, but I did so in the next slide, we can see a lot of event sending activity caused by Google Tag Manager. And we wanted to get that out of the way, because we can also see the whiskers and basically my interaction with input delay, processing time, presentation delay. And only at the end of the presentation delay over there is when the next frame is presented. So that's where the visual feedback came in for an actual user, which we want to improve, because that's what non-technical people are basically focusing on. This is what we ended up doing. In short, there's a link to be found, but once again, you will find that afterwards as well in the resource that we're sharing. But we basically ended up yielding, again, Jeremy will be talking about scalar yield as well. We ended up yielding those events to get them, well, basically away from the main thread, or basically deferring them until after the next frame was presented. So that resulted in the next scenario. Unfortunately, we can still see some Google Tag Manager activity outlined in red. We were not able to get rid of that, but the main blocks outlined in blue, we were able to defer them until after the presentation delay. And this is still a shame, this scenario, although it already resulted in an improvement, 53% improvement. What I outlined in green is the only part of JavaScript that was really necessary. That actually called the slide function, causing the next image to appear in the product gallery, image gallery. So I would say this is still way too much JavaScript on the main thread, but at least it was already a win, as we were able to defer big blocks of those event sending activity.
And always celebrate wins, guys. Don't forget about that.
It was a real win. Yeah, absolutely. I could have been doing better than using Paint over here. I only learned about annotations today. So that would have been cool if I would have used that in my previous slide, but as we can see at the date, it was only published recently. So the IMP gains 12% win at mobile P75, but we actually saw an improvement, well, basically from P47, I think, P46, up until P97, having a win of 8%. So that means that a large portion of people, 51% of all visitors, page hits, actually well, had an improvement, benefited from this change. All right, and also other events as well, clicking on the CMP, clicking on accept cookies or whatever, the add to cart button, etc., etc.
So yeah, so let's get back to third parties. This is actually a really cool book, and I would recommend that you read this, but I am going to slide through it. Because third parties, as we all know, can be a huge bottleneck in IMP. We saw the data, we saw the benchmark, but does that mean that there are no wins to be had when dealing with third parties? No, there actually can be improvements. And this was a fun one. So we were trying to improve this merchant's site, and we were looking at the data, and we saw this really weird script that was taking forever. That's almost 4 seconds for a single script. And we actually couldn't figure out what that script was doing. So we asked, you know, what if we would remove it? Well, they did, and it proved almost 77%, and the IMP dropped to 260 milliseconds, which, as you can see, is a huge win. And then just by knowing what that script was, I mean, actually, we never figured out what that script was. But by removing a script that we weren't too sure what was doing anything, we had that win. So the learning here is keep an eye out on scripts. Check it in your performance panel, or better yet, your ROM, and know what you're running and why you're running it. And if you're not sure why you're running it, and your marketing team is not sure why you're running it, then remove it.
Well, start asking questions first. This client just removed it. Yeah.
Yeah, or remove it and see if they call you to complain they're missing data. Because we asked the merchant, hey, you know, did you ever figure out what that was? And he said, no, no idea. Some absolute crap, though. We just removed it. It wasn't even working properly.
This is a 100% quote. We did not add any words here. This was the response of the client when we asked what that obfuscated script was actually doing.
Yeah. So know what's running and remove it if no one's sure in your organization. You can always get it back if it turns out it was important, but in many cases, it probably wasn't. So here's another one. This is one we probably all suffer from. marketing and CRO wants to run Hotjar because it can get you valuable insights. I agree. However, we saw this huge worsening in user experience by almost 50%. When Hotjar,
it's
oh no, the
actually sample
Hotjar was
rate.
running 50%.
Yeah.
You're right.
Yeah.
I'm sorry. It was even much, much worse. I think this is almost 500%. But they set the sampling rate to 50%. Now I'm gonna ask you, who wants to look at 50% of playbacks of users? Who has time for
to do
that?
so. Yeah.
I don't. I like to look at some of them. I don't have to look at all of them. And I think actually your CRO team would probably agree with you that they have better things to do. So we asked them, hey guys, could we maybe reduce it so you still get the insights, but our performance actually doesn't get screwed up as well? And they did. They reduced it to 10%. And what you see here is that at least we see that while there's still a price to pay, the price is less high than it was. And there's actually another interesting win to be had here for running very heavy scripts, especially ones like Hotjar. We can consider a device memory condition. So if they're actually running on 4 GB or worse just on 2 GB devices, then don't include them on Hotjar. Or with a very, very low sampling rate, at least, if you really want to know what they're doing. But I'd say just don't, because your users do not want to ask. They're not asking to be part of your experiment, so keep them out of it.
All right, I'm going to speed up a bit. Again, data from Web Almanac, although based on our Run Vision data, confirming that it is, in fact, user behavior that is often resulting in the most IMPs and the highest IMPs. We can see a distribution bar as well, confirming that. We've got another case, Huva case, where we implement, well, not we, as a matter of fact, Huva came up with a implementation for speculation rules, and it also led to an improvement of IMP. I've also seen some cases where IMP regressed when in, well, very specific scenarios, but I did not have very good data to back that up, so I didn't publish that in my slides. But this case did see an improvement after implementing pre-rendering and comparing that with the baseline. And the baseline would have been worse without pre-rendering, obviously, so the win of 27% is actually a bit more. And we can also see a win from back-forward cache, which is also, I think, demonstrated later on. No, the speculation rules is demonstrated later on. But the back-forward cache also makes sense, as discussed yesterday, as basically the same state of previous page is being reloaded, and well, not reloaded, obviously, but clearly showing a win as well compared to back-forward attempts that did not came from cache. And loop earplugs, the biggest win, because this is a Shopify merchant, and it was a third-party, a Shopify extension that was improved, as Matthäus started asking questions after analyzing a Shopify site, and this resulted in a big win, because before, whenever interacting with the Pendectest GDPR cookie banner, its own IP value was 786, and its pure JavaScript time, which contributes to the whole IMP, was also 464 milliseconds. Matthäus reached out, and we saw a clear win for event listener invoker types. So when users click on something, we saw a clear win overall of 22.8%, meaning all Shopify sites now have the potential to improve big time because of this one change within a Shopify extension.
So also, third parties are subtle to change if you just tell them and are in fact important enough. Remember that. Find the important people.
I think we both clicked at the same time, maybe?
We crashed the system.
Yeah, we did.
Yeah, well, that's too bad for us. Yeah, all right. Giving it back to you now.
Yep. All right.
Oh no. And this is what happens when you introduce interactivity to unknown conditions.
All right, let's try this way, the old school way. And this was, well, we also saw a clear win within the processing time specifically. I'm not going to elaborate on this because we've also got an article explaining this, but this is typically my working flow, you could say, a flow chart of how I address and look into our RUM data to then dive into DevTools, where RUM data, especially LOAF data, is telling me how to reproduce a situation.
So
the flowchart itself is also published online already.
yeah, so going forward, what did we find out? Well, that my clicker is not working anymore.
Okay.
It's back. All right. So actually, third parties have been improving. They are actually listening and trying to improve, and having better instruments like IMP is helping them because it makes them see what is happening. And most third parties actually don't want to screw up your performance, especially if you're going to get mad at them. So browsers have also been improving. And actually, the IMP and the Web Vitals got fine-tuned over
Even
this
Google
last year.
published a tag, made a change, and introduced a yielding option as well.
Yeah, so all of us are improving. Actually, if we want to improve even more, then sign up for this proposal for async and event listeners, and we might be able to improve things even further. Because everyone will benefit if we improve IMP. I think we can all say now, after a year, IMP has value. Platforms improved, merchant got better conversions and happier users, RUM providers got better insights to give to you, the developers, to debug IMP, and your visitors, the most important of them, will all benefit. However, do you know that we ask you about your phones? Well, that's an issue. We are lacking almost, I think it was 60% of your experiences, and we would like that to be more. So please give Ryan's proposal to get Core Web Vitals in all browsers supported a thumbs up, as that would be amazing, and I would love to be here back next year and say, look, Safari has IMP issues as well. So to have the key insights, real user monitoring actually gets you much better insights than simply running a lighthouse test will do. Know your audience and restraints when you're making decisions on what you can run in terms of JavaScript and third parties. Keep challenging marketing and user behavior tags. Either get them out of the way, yield them, or get mad at them and see if they can improve. IMP is already very valuable when combining attribution, and third-party benchmarking is actually available to us, and you can even do it yourself when combining IMP with LOAF. And then we can all increase user happiness. So who won?
Slightly off, okay.
Who is that?
I think that's Alex Russell. Take a picture, maybe.
Yeah, bragging rights, LinkedIn, happy moments, and actually, where is the Rummy Cup? So come get your prize. No? No?
Later on.
Yeah? It's suitable for the family?
Family friendly, yeah.
Yeah. And actually, that wraps us up today. So we would all like to thank you for attending, and we get that you all want lunch now. So if you have any questions, we are actually at the help desk. Please ask us anything you want. If you want to check the slides again, or just go here, and they are all available, including
Not yet.
the resources.
I will publish them in a few minutes.
Okay, well, he has a bit of an input delay on that one. And if we can do anything else for you, like provide you with a RUM Vision demo, then just let us know, because both me, Erwin, and Jordi and Max are available all day. Thank you.
Thank you so much. So Erwin and Karlijn, we have time for maybe just one quick question. If you want to come have a seat with me. Okay. First of all, I do not think it's fair that Alex Russell won. I'm just being a sore loser. So someone had a clarifying question. So question 4 out of the 6. One of the choices, was like advertising, marketing, third-party cookie consent. The winning choice was user interaction scripts.
User behavior.
Or user behavior scripts.
Yeah.
Could you elaborate on what that means a little bit more? Because I think for a lot of us that was maybe a surprising.
Okay. Well, it's typically a heat map solution or a Hotjar that is typically tracking user behavior, link clicks, the position of the mouse, etc.
Yep.
Mouse tracking maybe. Yeah, I think that's the best summary.
Okay, thank you. And just one final question. So you shared a lot of really great case studies, a lot of options for how to improve INP. If folks are going to go back to their job and on Monday and they want to work towards this, like what is the first most important thing that they should do?
I would summarize it by
Get a
saying,
ROM.
yeah, well, and start using LOAF, long animation frames.
Use ROM with LOAF.
Yeah.
Yeah.
Awesome. Well, thank you so much to both of you.
All right.
That was fantastic and a lot of fun.
Thank you.
I love me an interactive presentation. So lunch is starting now. I see folks are already starting to leave. But just a reminder, please don't bring glass dishes downstairs. But you are more than welcome to bring food on paper plates. There's a lot more space down here than there is upstairs. We'll be back here at 14:40, which is 2:40 for us Americans who don't do military time. And again, a reminder that the Chrome team is hosting a feedback session at 2 o'clock. So if you meet Z by the front door, they'll take you for the feedback session. So looking forward to seeing everyone at 2:40/14:40. Thank you. All right, welcome back, everybody. So the first announcement is, in addition to our Ms. Pac-Man rule, we have a new rule. It's called the Tetris rule. So the Tetris rule is that, see, there all this empty seats. Everybody needs to move in, and everybody needs to move forward so we can fill up all the seats, because people have been standing in the back. They've been blocking the videographer, which we can't have. So the new rule, be like Ms. Pac-Man and play some Tetris. And there's plenty of seats up front. I promise we won't bite you up in front. Did everybody enjoy the stroopwafels? I got my second stroopwafel. I will have a third later, maybe even a fourth. Yeah, Tim's had quite a few too. Well, we have Catchpoint to thank for the stroopwafels. Catchpoint, again, is one of our sponsors. And in case folks missed it, they announced the winner of their raffle. So Laurent Chien, who works at Chanel. So Laurent, if you're here and you hear this, then during one of the breaks, go on up to the Catchpoint desk and they will give you your prize. All right. So I think that's all for the housekeeping. Don't forget the Tetris rule. Move forward, fill in the chairs. To kick us off, we have Jason Williams and Paul Williams. Their third presenter, Serena Williams, actually couldn't make it today. But Paul and Jason both work at Bloomberg on the cross-terminal performance team. Paul actually founded the Bloomberg office in London, which has grown to like several thousand engineers. And they're here to talk to us about how Bloomberg is doing that thing that Alex told us all to do at the end of the day yesterday. And they're embracing web technologies as the foundation of their their Bloomberg terminal. So it's going to be a really interesting talk. And put your hands together for Paul and Jason.
Here we go. Thank you so much. Thank you so much. It's really wonderful to be here. We've had an amazing couple of days. We came for the first time last year, and we just had to come back. And amazingly, we got invited to speak. So we're really honored, actually. So thank you to all the organizers for having us. Yeah. Okay. Yeah, round of applause for the organizers. So I'm Paul Williams. This is Jason Williams.
Hello.
We're not related, but we are brothers in performance. We are part of the JavaScript infrastructure and terminal experience team, JITX, at Bloomberg, based in London. This is our wonderful team of highly performant people here, and we're here to tell you about our road to embedding browser technology and what web performance work we have benefited from and supported. Because it's not all about what we do for ourselves. Bloomberg. Who's heard of Bloomberg? Not bad, actually. But for those that maybe haven't or don't actually know what we do, just a very, very quick summary. We have data. We've had data for 40 years. We have news. We generate news. We aggregate news. We have TV, radio, media. We have analysis of data. We have communication tools. We are a large community of people in the finance and business industries. We have trading workflows. We have enterprise integration to get our data into clients' own systems. And we have philanthropy. Bloomberg chooses to actually give away most of its profits to great causes like education and health around the world and so on, which, for me is a really, great reason to stick at Bloomberg for such a long time. We're also a technology company. What does that mean? We build large-scale, high-performance software. We have to support 400 billion market ticks per day coming in real time. At peak times, that could be 10 million updates per second coming into our data centers. And we have decades of financial data and news analysis. So we were one of the early big data platforms. Of course, I have to mention AI. We've actually been doing AI for 15 years or so in natural language processing, machine learning, and particularly nowadays processing structured and unstructured information, news summaries, social media sentiment, extracting fundamentals and environmental, social, and governmental governance data from findings, from company findings. Open source. Open source has become the heart of what we do, particularly in our part of the organization. We're part of the C++ Standards Committee. As many of you know here, we are involved in the W3C, particularly the Web Performance Working Group, TC39. The chair of TC39 is here in the audience, my boss, and various other things to do with Python and machine learning. And for us, all this comes down to the thing that we build, which is the Bloomberg terminal. So this is the system that is on the desk of financial professionals across the world. And it's the thing that we live and breathe when we're at work. What is this thing? It is a high-performance, near real-time data display. Has to be low latency. Has to have a responsive UI. That might ring bells for some people here. It supports hundreds of desktop windows across multiple monitors. It might have 50,000 streaming updates coming in per second to each desktop. And it has to be scalable so it can run on varying hardware. I like to think of it as a virtual data center of 350,000 plus machines. Now you think, 350,000, that's quite a small number compared to the 5.52 billion users of the internet, right? But it's an interesting number for us because we know every user. So when our sales organization actually encourages a client to pay for a subscription, they will actually get to know that person and their needs for the terminal directly. So it's a little bit different from typical web clients. The terminal didn't always look like that, though. It was when Mike Bloomberg decided to start the organization. He likes to call it the original startup over 40 years ago. This was the time when financial professionals didn't really know how to type. They had secretaries to do this, as you can see here. And the data displays were quite primitive. But this was very much a system to for the first time, really, to computerize the kind of workflows that were happening on paper or with calculators on trading floors of the world. One of the characteristics of the early Bloomberg terminal were specialized keyboards and actually some of the first flat panel displays as well. When I got involved in Bloomberg in 1995, I was presented with one of these, which was an interesting keyboard, and the first time I'd ever seen a trackball, I think. And this is what you use to actually to enter data into the Bloomberg terminal. So why am I here? Actually, keyboards kind of connect us. The first computer I used was back in about 1980. We had one of these at school, Commodore PET, and it actually had quite a similar keyboard, actually. Notice it has a cassette tape drive. But actually, that was a luxury at the time. When I was first actually programming, I was writing games and getting them published in computer magazines where they would actually print the listing, and you had to actually type it in to actually play the game. And interestingly, somebody found this online and has fixed the bug that's been there for 40 years in that game. So I actually moved on, and I started going kind of lower and lower level, and got involved in writing early arcade games. And this is where really interpreted BASIC was not going to cut it. So I learned assembly language programming, machine code. So I kind of went low level quite early on. Also, I used this for music software so that I would feel less uncomfortable if I was in the student union bar, because I could actually be playing music. And you notice in this picture, I'm really sorry about the 80s fashion, but it was the 80s. Sorry. Notice we've now progressed to floppy disk drives now. And also in this picture, you might notice there's a kind of hacked drum machine here. The drum machine is actually plugged into the printer port. Because I was writing my own software, I could actually print drum sounds to the printer port and to use this live. But yeah, this was very much, I was kind of cutting my teeth with proper low-level, real-time programming here. I moved into high-performance computing, actually for a startup, for 9 years or so, until I got the call from Bloomberg. And initially, I was working on real-time data feeds for a couple of years. And through a few happy accidents, I ended up co-founding the London engineering department for Bloomberg. And after doing the feeds, I was very lucky to get asked to be the person to lead the modernization of the terminal. So what is the architecture of the terminal at a very, very basic level? This will look very familiar, I'm sure, to many of you. Server-side, basically server-side rendering, application engines, sending down UI definition and data rules to something at the desktop, backed by some data services. Something we add to that is this thing we call the ticker plant, which is our real-time high-performance database that can stream updates out to each terminal. Plus, there are some static resources and a kind of CDN as well. And you can imagine this has to scale across the world so that we actually have efficient ways of fanning out these real-time streams to all these terminals, plus proxies for the CDN work. Initially, if we actually look inside the terminal, it was actually running on custom hardware. It really was literally a terminal. So you'd have the box in the cupboard on the trading floor, and then you'd have these yellow cables, thick yellow cables that were actually carrying video data out to each trading desk. And it was almost like the system was water-powered, because these were really like thick hose pipes. And you could see them snaking across trading floors. We stopped using custom hardware and actually moved to running on Windows. And initially, it was literally a terminal emulator. So we ported the custom code that was running in this hardware system onto Windows and allowed clients to actually either rent from us Windows PCs or buy them themselves so they could run these displays. So that was a good step. And really, that's the point that I got involved. So I was asked to modernize the terminal. And of course, being a programmer in infrastructure, the first thing I'm going to do is I'm going to say, we need a new framework, because that's what all programmers do, right? So I actually got to do this. So I started to design and build a plugin framework that would slot into this existing terminal emulator. But it was really doing the same thing. As far as our servers was concerned, it was sending these, what we call schema messages, down to the desktop, which would then be interpreted and program these quite low-level controls. And we were building things like charts. And of course, because of my games programming background, we were kind of doing these kind of very similar. Now, I wish we had this function in the terminal. I think that would actually be quite a good selling point. Scaled this up. So at this time, this was all basically homegrown C++, basically running in a single thread in a single process. And we really got to the point where we could literally run. I mean, here we have 90 separate desktop windows for each of these charts, actually live monitoring the NASDAQ US tech stock exchange at the top here, and various interactive displays. So we were doing OK. This was quite a powerful system, but we did reach a point where we'd kind of reached the limit of how much we could optimize, and also we were getting to the point where every time we needed a new feature, we were having to actually load in, give to clients a new native build of the software. You can probably see where this is going, actually. Something that we did have to do to support this high-performance streaming of data was devise something which we called data layer. So data layer, it was a programmable subsystem that could process all this streaming data that was coming through. It consists of cascading building blocks, each responsible for one type of data processing. So, for example, you would have a worksheet component, which is basically doing what Excel could do. You'd have join views and filter views and sort views to manage that stream of data in order to transform it into what we would need for the UI components, whether those were grids or charts or sliding tickers or other kinds of components. So this data would just stream through this system, which you would set up at the beginning of your application run. This data layer system, we've been developing it more recently, actually, just to take advantage of parallelism so that we could actually effectively process this stream actually quite efficiently on up to about 32 cores if you've got a high-powered workstation at your desktop, to enable us to reach back into this data layer pipeline and process on demand the data that we need to display. These things, the use of this data layer actually got really complicated. And this is one of our more complex applications running in the terminal. And this is the data layer pipeline for it, which is quite large, actually. The colors are actually how hot each component is working. So red is danger, of course. But you can see there are little hotspots here as this thing is running live. But it was starting to get unwieldy at the desktop. The UI controls in particular, they weren't very consistent. They were kind of, oh, that's a good idea, let's add a new feature. And we did that over and over again until this code base was definitely millions of lines of code. To give you an example, for one grid cell, this was the state of one grid cell. And sure, in the web, you could have a table element that's also this complex, but it wasn't very consistent. It wasn't very uniform in the way we were setting it all up. So we needed to do something a little bit better. So I noticed this LinkedIn update from Henri, intrepid roving hallway reporter, which he posted earlier this week about to commemorate the 20th anniversary of Firefox. And it just so happened that early 2000s, we were dabbling in this technology. We'd started looking at this intriguing Mozilla project, which was, for us, it was one of the first open source projects we'd looked at. So this is obviously the project that gave birth to Netscape Communicator, Mozilla 1.0, Phoenix, and Firefox. But the common thing which we found very interesting was the fact that these all use the SpiderMonkey JavaScript engine. And hey for SpiderMonkey. So this was interesting, open source, something that we could actually play with. So we tried plugging it in. And to replace the kind of the UI definition and the UI processing for this data coming through this pipeline. So it was an intriguing possibility for us because now we could define these UI rules in script rather than having to burn them into the C++ that we were developing. The next little development, and you can probably really see where this is going now, is we wrote a little HTML parser because that was a much more uniform way of describing UI in this JavaScript we were writing. So some of our UI controls started supporting HTML. And we actually built some quite sophisticated applications here. For example, when we released our instant messaging product called Instant Bloomberg, day one it had live data in it, which was basically caused by us being able to stream data into the DOM effectively of this homegrown UI. So that actually became a real success for our clients to the day nowadays. It is one of the primary ways that all financial professionals, certainly all financial professionals that have the Bloomberg terminal, will use to communicate with each other. So JavaScript and HTML and live UI and rendering. Could we embed a real browser to do this rather than all this homegrown code? We tried a few things. We tried Gecko. Shout out for Gecko, which was the embedded browser from the Mozilla project. We tried Opera. We tried embedding IE. Initially, this was the point where some people still had IE2, which wasn't actually embeddable. IE3 was the first one that we could actually try embedding. But Chromium was interesting. Chromium had quite a powerful embedding framework built into it. And V8, the JavaScript engine in Chrome, was really starting to gain traction. And I think at the time, it was the only one that actually had a jitter in it. So we were thinking, of course, we were thinking performance, and liked the idea of being able to JIT the JavaScript that we were writing. So Chrome process architectures. Have you run Chrome at the desktop? What have you actually got? You've got a browser process which actually manages the windows and the Chrome around the edges, and also processes UI events that are coming through. Then for each tab, you have got a separate process that is responsible for running the JavaScript, processing the HTML for that particular web page that you're looking at. And then there is also a sub-process, the Chrome GPU sub-process, which will either use the GPU or do software rendering to actually get the pixels onto the screen. So within each of these renderer processes, there is code running. This is where Blink, the actual Chrome itself, is interacting with JavaScript to generate the DOM in a web view and send a display list across to the GPU process. If we look at Chromium, Chromium is exactly the same thing, except with an embedding SDK around it. So again, very compelling for us to try. So imagine this is the terminal architecture right now. At this point, with a SpiderMonkey, when we plug in Chromium, it fits in really nicely, actually. So we replace SpiderMonkey with V8. We replace our entire UI stack with the Blink renderer that is built into Chromium, and see if we can actually make it look like the original terminal as a starting point. By the way, we still have the other parts of Chromium. We have the browser process managing Windows, and we have the Chromium GPU subprocess that's actually drawing the pixels on the screen. We can also introduce scalability, because like in Chrome, we can have separate processes running for different applications that a user might be running. Now, if you've got 200 top-level Windows, you might not want 200 processes. We'll come on to that a little bit later. So what's actually going on inside here? We have JavaScript and Blink building the DOM from HTML and from JavaScript updates and rendering it into the web view. For external updates coming in, for streaming through, for example, from our data layer, the DOM cannot be controlled directly by the Chromium API, only from JavaScript. So we have to be very careful to make sure to optimize the path for JavaScript coming from the streaming layer. So you can imagine UI rules and this streaming data layer feeding in to JavaScript. So does it work? Does it work for everyone? All our clients? This was a big change to move out to our clients, and we were concerned that the performance wouldn't be as good as this fully homegrown native system. The good news is Chromium infrastructure has had some amazing work that's gone into it, and the rendering layer and the way it actually constructs pixels on the screen is absolutely best in class. It's really, really, really been good for us. But how do we actually measure this and prove it? So really, it comes down to how can we define whether this is working well. How does it feel? Is there a fast reaction to mouse clicks? i.e., is it responsive UI? Is there a lack of stutter during keyboard input? We know all about these things in this room. No jank when dragging with the mouse. This one's a little bit janky, actually. I'm not so happy about this one. This one's a bit better, actually. Is new data displayed immediately? Now, this is really important for us. When we publish a news story, we actually have a separate team that will publish the headline while somebody else is writing the story. And we'll put the headline out before the story even exists. Obviously, it has to be fact-checked, and then we'll put the story out. So by the time somebody goes to click on that story, click on that headline, the story will probably exist by then. But of course, the most important thing will have been in the headline. And if that is market moving, it's really important that in the UI layer, we don't introduce any delays to actually get that out to the screen, or else it would negate the whole point of having a separate team writing the news headlines. So actually, we have to be very careful about doing things like coalescing updates together, because if it's something like a news story flying through, we need to get it through straight away, even if it means that processing every headline separately is going to be more cost in terms of the work we have to do. So really, we need to understand how ready is the UI thread for the next event. Also, how close to capacity is it? If we do any more, are we going to start to introduce delays? And how long does indivisible work take? Of course, there is Chrome DevTools. We love it. Chrome DevTools is amazing. Thank you, Jack, wherever you are, and your team for building an incredible diagnostic tool with Chrome DevTools. However, for us, it's not always the best thing. When you're using Chrome DevTools, it's great if you've got the thing in front of you you're trying to profile. You need to enable profiling and then look at the analysis, or get the person experiencing the problem to enable profiling to to record the trace, or the cooperative collaboration that's been introduced in Chrome 131 this week. Fantastic to see that, but it doesn't really, you can't really ring up a trader and say, "Oh, do you mind opening the inspector and trying that trade again?" and was a bit slow. So it's a difficult thing to capture from clients. What we really need is the ability to have always-on measurement of what's actually happening inside the event loop in the main thread. UI event processing, JavaScript execution, DOM manipulation in Blink, and significant parts of our data layer subsystem as well. So we have come up with some extra metrics that we measure for all terminals all the time. One is called UI responsiveness. How ready is the main thread for new work, effectively by pinging that thread. Busyness, which is the percentage of elapsed time doing work. And time and delay, that's a good capacity measure, particularly on Windows, which is our primary platform, because on Windows, timers only fire in the main thread if there's no other work to do. So if a timer is late, that means there's too much work to be done right now. And you can actually see that on this real-time display here. The white is this busyness on a 100% scale, and the little yellow triangles are UI responsiveness. So you can see the points where the UI thread was busy doing work, indivisible work, as these applications are loading. And then the red are actually time and delay, when there was basically queued up work for the main thread that was going to get processed ahead of a timer. So you can imagine a UI event would get created in the browser process, would get sent across to one of the renderer processes running the application, and would propagate through into the main thread event loop, then would go straight into Blink, most likely, which would then come back and wake up JavaScript, run a handler. JavaScript might then update the DOM. Or maybe JavaScript is going to reach out to our data layer subsystem and pull in some data to update the DOM again. Now, if a data event comes in, we actually need to sort of shoehorn that into the main thread so we can synchronize with JavaScript. So we will put that data event in a queue inside data layer, and then we will trigger either directly or via a timer a new work event from the main thread, from the event loop, into data layer, which will then be able to wake up JavaScript in the correct context, and maybe reach back and say, I'd like, tell me what that update was, and then update the UI. So these transition points between these different subsystems are really interesting places to be able to try and instrument what's going on, to understand how this event loop in main thread are behaving. Something that we've introduced, which we have the luxury of being able to do because we are the embedder of Chromium, is to introduce what we call observable timers at each of these boundaries. Now, these are very low level, implemented in C++, basically using a single atomic. So we can intercept every transition between these different subsystems with only a cost of about 50 to 100 nanosecond. So it's not the kind of thing you'd want to do inside a loop, but on these major transitions between these subsystems, you're not going to impact the overall performance significantly to actually cause the application to slow down if we can do these measurements at such a low overhead. So this is cheap enough for us to run all the time. And that allows us to build these kind of displays. So what you see here are the different colors are basically any work that is triggered by Chromium is this kind of light yellow. The orange is JavaScript running. The blue is our data layer running. And you can see there's a chart with the little triangles right in the middle, with the white line below it is, as I was showing you before, the busyness of the main thread and the UI responsiveness and the timer latency. So we can actually look at this live as we're interacting. So you can see here we're actually interacting with these 3 different applications and seeing, which are running in the same process, to see what effect that has on the main thread. And we can collect this data. So we can actually, if we need to, we can ask a client for permission to really look inside how their terminal is performing and really drill down into finding out what's busy or what's slow for that client. We can go one stage further, particularly when we are what we call co-locating applications into the same process, where effectively they're time slicing this event loop. And we can have a concept which is current executing application and include that in our instrumentation so that we can actually attribute across multiple applications within the same main thread to understand whether there's a particular application that is busy. So this actually has proven very successful for us. And I really want to talk to the Chrome low-level folks about how much of this kind of thing could actually be enabled for real in Chrome, because I think it does add an extra dimension of understanding of how applications are performing. So we've embedded a browser. How else does this help us? And more importantly, how does it help you? So I'm going to hand over Jason to tell you all about that.
Hello, everybody. I'm Jason Williams. Wow. Well, yeah, it's nice to meet you all. I'm Jason Williams, software engineer in the terminal performance team, and yeah, our team is also in Paul's department. I'm not Bloomberg.com. Okay, I've had somebody ask me that before. In fact, sadly, the Bloomberg.com team on here, in a small way, I'm happy because I think they would have been too nervous yesterday seeing Paul Gavano's talk about HTTP, mistakes. I think they would have been sitting there thinking, "Oh my lord, are we going to be next?" But I think so they're watching, but they'll be all right. I'm concerned for their health. But yeah, this is there we go. That's me. I also DJ'd and made music at university as well. As we not looking after my CDs. To be honest, if it's scratched, you just made a new one. So come to think of it, it wasn't great for the environment. But I used to DJ and stuff at uni. I had a Commodore 64, but I didn't make music off it. I worked a little bit on Servo, which is an open source rendering engine that eventually went into Firefox. I think some of you know about that. And then later on, went on to build a JavaScript engine called Boa in Rust. And that's me, sort of me talking about it there. Actually, I just realized that's the last time I've been on stage at a conference. That was 5 years ago. So please be nice to me. But up until that point, just doing web development and HTML back in like 2002, 2003, just doing like tables and attributes. That's what it was. That's what it was then. I went off to do some audio engineering. I came back in 2007 at university, around the time that picture was taken. And we had to do like a website and web app, and I did the same thing. Tables and style attributes. And I think everyone else around me was like, "What the hell are you doing? We have CSS now. We have modern layout. You don't need to do all of this this sort of stuff anymore." And I realized actually how far forward the web platform has really moved forward. Even then, I was 2007. But that was sort of what I stuck with for most of my career and stayed on the web, made a lot of websites for BBC, and then later on eventually came to Bloomberg as a sort of champion of the web platform. We can do this on the web. And I joined Paul's department to do performance and try to utilize the web platform. And yeah, Paul showed me some old stuff, so he showed you some things as well. And I feel like Bloomberg went through a similar renaissance of like, actually, yeah, we can use the web platform. I saw some of the old functions that Paul showed me. And I guess if you're from UX, UI, this is a good time to close your eyes. Because I saw this. Whoa, oh my life, wow. I looked at that, I was like, wow. I don't know, Eric Bailey yesterday talked about, what was it, cognitive overload? I'd love to see the NASA score on that. But I saw some of these functions, and actually back then, this was 2004, it was all just low-level C++ APIs. So, there wasn't really much styling or a style team or anything like that. You had to dig deep down to get the things that you needed. And that's why back then it was just programmers doing the UI. A designer wouldn't have had a chance. That was about 20 years ago. Fast forward to today, we do have some modern UI. It's much better. It's much more consistent. We can actually have designers come in now. As Paul talked about, we've got a browser, we've got HTML, we've got CSS, we've got modern tooling. We've got a really powerful rendering engine, GPU acceleration, and finally, some good accessibility. We can make good on our accessibility commitments. It's much, much better today than it was before. And also, what really impressed me was how we managed to migrate to this, all while the clients were sort of using it. The clients didn't even know, really. This actually is you see on the left is the old C++ UI, Chrome on the right with just JavaScript, HTML, CSS, and most of our clients didn't even know. So it was like changing a jet engine while the plane is in the air. We were able to sort of do a nice migration. We were able to get design teams in actually, and they were able to sort of be a bit more creative. We could have a style guide. We could have UI frameworks, and we could be a bit bold and make some nice things. We didn't just stop there though. As Paul just mentioned, we did join up with standards bodies. Joined up W3C with the CSS working group and WebPerf working group. on the left, and TC39, Technical Committee 39 in ECMA, standardizing JavaScript. Yeah, we also got involved in that as well. Now, people probably in the audience thinking, well, why bother? You know, you've got a fork, you've got some issues, you can fix them. Why even bother going to standards bodies? You don't really need. Well, the thing is, I feel like for us, first of all, anything we fix just stays with us. It doesn't really help anyone else. It doesn't benefit the web at all. And I feel a lot of us don't feel like that's a good thing, especially after everything you've heard yesterday, which I agree with. But also, as well, it's not good for us, right? Because if we fix something, we make changes, every change we make, we're diverging from the web, right? Every change we make, we're getting further and further away. And I don't think that's good for us either. So I think it really makes sense for us to collaborate as one. I just want to show you some examples of things that happened. This is just to build some context, because I'm not sure everyone is aware of some of the stuff we've worked on over the years. Maybe even some features that you may have already been using. So it's just to sort of show you what's been happening. One of the things we did was CSS Grid. I think a lot of people know of CSS Grid. When we migrated from that C++ framework across to the rendering engine, as you can imagine, a lot of our views are sort of like very grid and table, cell heavy. And the current layout models just weren't good. Well, just weren't suitable at the time. And we actually had a fluid grid framework in the old system, and we really wanted to bring that across. So what we did is we collaborated with Igalia, an open source consultancy, and we got to work on the grid spec, or I guess the second version of the grid spec. There was also an earlier version that Microsoft did. I think it was an IE 10, maybe. But basically, we got to work on that and also collaborated with other browsers to eventually bring that out in, I think it was around 2016. So yeah, we got grid, we got a better fluid layout, we've got our tables, we've got a modern browser, but we still had some performance issues. We would update a cell, market data would come through, we'd make a change, and when that cell updates, it wasn't just triggering star recalculation for the cell, it was triggering star recalculation everywhere. It was actually quite slow. And obviously, as you can imagine, we didn't have this before, but now cell updates and market data is just triggering star recalculation all over the place. And it's something that we needed to fix. And again, you know, to begin with, we did fix it. We essentially just stopped propagating any star recalculation outside of that element. Now, if you do that, your site's going to break. I guess in this particular case, the developers knew that any change that happens, we can guarantee is not going to affect anywhere else, because the values in that cell aren't going to expand, the cell isn't going to expand, it's pretty fixed at this point. So the developers could make a guarantee, right? So it's like, can we tell the browser, don't worry too much about calculating anywhere else? And browsers do that because sometimes they don't know where style invalidation starts and ends. So they can err on the side of caution and just do revalidation everywhere. And so they fixed it. They basically put in any element that has a particular property, don't worry about anywhere else, don't worry about restyling it. It's all fine, it's all good. They actually had a really nice, slick name for their property. It was very like short and sweet. It was BB set text no relayout. True, because you need a value. But actually, a few years later, the CSS working group actually needed something similar for container queries, right? We need to actually be able to control the style and keep that contained and isolated. So they collaborated with, Igalia and Bloomberg, and about 2 years later, along just after container queries, actually, between the three, and there was much more parties as well. We managed to get this to CSS containment. Has anybody used CSS containment? Anyone heard of it? Okay, that's a fair few. So being able to control that is being able to control your layout and isolate it and set boundaries for performance is great. And yeah, now it's much better. It's a better name. Just rolls off the tongue. But we got that, and then now we can update cells, and we have much better layout. I highly recommend taking a look. It could help, obviously, measure first, but in our particular case, we managed to get some good improvements on that. Really briefly, TC39, big int. As mentioned yesterday, big int, so stock exchanges, some stock exchanges all over the world, they measure trades, some at nanosecond precision. And that's data that comes back into our infrastructure. We've got to deal with that. And BigIn obviously was quite important for us. It's something that we had, but a lot of people in the web wanted BigIn. For instance, tweet IDs overflowed on the F64. They started giving you the ID in a string. So it was very important for a lot of places. And now, I'm happy to say that BigIn has been in all browsers, I think, for the past 4 years. And temporal. I'm sure some of you have heard of temporal. It's in progress. It's a replacement for the date object to give you a better dates and times in JavaScript, no library needed. And you can have epoch, you can have durations, time zones. It's even supports times in different calendars. But yeah, the proposal's been going for about 7 years. I've been a champion for 5 of those years. But no, don't clap yet, because the spec is pretty much virtually finished. It's virtually finished. And I can say we should be seeing it land in the first half of 2025. It's been a long effort, and we're finally getting browsers to start implementing it. One browser is virtually finished. We're talking about 96% done. Another browser hasn't even started. I'm going to let you imagine which one is which. But it's virtually there. It's virtually there. Yeah. Rust Cox. Wait, yeah, sorry. So, yeah, there we go, virtually there. We got BigInt, Moment, Alex Russell, I don't know where you are. We've ticked off 2, so we're helping with a good fight. That's what I like to think. There we go. And there's some other things as well we've been working on. But look, this is Perf Now, right? This is Performance Now, fifth edition as well. Wow. We're here to talk about performance. And if you're playing the Perf Now drinking game, get ready, because I want to talk about largest content for Paint. We've got a browser, we've got some of the same infrastructure that you have, which means we can measure the same way that you guys measure. And so we managed to implement LCP into the terminal and see if we can actually make use of it and see how well it works for terminal functions as well. I'm just going to show you, this is me refreshing a function. This is world equity indices. Don't worry too much about that, but just giving you all the indexes across the world. You saw that refresh. Don't worry too much if you didn't. But that's pretty much day-to-day what somebody would look at. Essentially, at some point in there, we're going to have LCP. So I'm curious to know where you think LCP may last for. Yeah?
I'm trying to keep up.
Okay. So I'm going to say we've got the table here. That's the data. We have some stuff over here. We've got some checkboxes. We've got some drop-downs. And we also have, if it keeps up, there we go. We've got a title just there. There we go. I've got some delay. So, do you think it's the table, the checkboxes, or the title?
Surely it's the table. Who's with me? You're all too smart.
All right, so show of hands if you think it's a table then. Okay, be brave. B, checkbox or button. Show of hands for checkbox or button. Some people. C.
They're good.
All right, it is, as you know, C. Give yourselves, you know this. We're definitely in the right conference,
Yep.
But it's not, I don't know, man. Is that ideal? I don't think so. The main content is, for us anyways, we want to see the table, or in my opinion, people who come to this function are looking at this every day. They want to see market data. It's actually called world equity indices. As a performance team, I don't know about you, I want to measure when someone sees world equity indices. But that's the data that somebody looks at. They're scanning for that. That title there on the top right is, they are so accustomed to that. They will have conditioned themselves to even ignore that at this point. And the data that they want to look for is in the middle. It's also misleading as well, because this is the same video I just played, but yeah, we get LCP on that, 190. Actually, the main table comes in at 320. So, I mean, right now, we're recording 190, but you can see the function's barely even finished. So, the team who manage this function, they are aware, they know they're getting about 400 milliseconds. They go into Grafana, And they're like, yeah. Just like how Harry Roberts looks at speed scope. It's not ideal for us as a performance team. Why is this happening? We've got, well, LCP, based on element timing. We know it's picking just an image element or a single text node. And if you look at our table, it's just a collection of text nodes and images. And even actually the checkboxes on the top left as well. None of those are bigger than the title, as most of you in the room know. And we just think that's, we want to be able to change that. That table is a component. That table is, we see that, or the developers see that as a single unit. And so do some of our users. And I don't think this is just a Bloomberg thing. I think people in the web have components, right? We make things as components. You might want to time an island. You might want to time maybe even a slow cookie banner so you can have attribution and then maybe send that to the team who do it. Not just because you see one site, it's not made by one team, right? We break it up. So we put together a proposal. We sort of hacked around a little bit, and we made a better timing API that could give you information about subparts of the DOM. You can point to a component, right? Because we can build components. We have toolings to build component. We can't measure and time components. So for me, that doesn't feel too right. But yeah, you can point to a component. You can point to a container and get some paint timings. Right now, TBC, we're calling it container timing. And the way that it works is very similar to element timing. You can set your attribute on any DOM node that you are interested in. You can use a performance observer to get entries back from that. Imagine a div, essentially, you've got your attribute, and then you get some entries coming through. I won't go through all of those, but essentially you get the first render time, you get up-to-date render times, you even get the size and how much of that container is painted. And just like in LCP, when you get your candidates, you can pick and choose. Usually, you can just pick the last one, and that will give you everything you need about when that's rendered. And then again, more data comes through. For obvious reasons, the first render time's the same, but now we've got an updated painted element inside of the container and an updated size. The size should actually only just get bigger. We don't want to keep giving you entries forever, by the way. If you can imagine, like, if an image changes, if you imagine a carousel and you've injected a new image and that's coming in, that won't be a new entry because your initial carousel component is already loaded, right? So this is quite useful just to knowing when that has loaded, not if there's any paint updates in the same space. So here we go, image loads, no paint update. Again, because I'm going to get kicked off the stage. Really quick example, bringing it back to the terminal. We had LCP, which we know, in this particular case, isn't too suitable. We've got container timing on the top. Because our row had painted, I don't know if you can see it very well, basically the heading is painted. So that's one thing. That's candidate 1. A little bit later, we've got all the data coming in. That's candidate 2. So the purple there is a new paint. The green on the top, we already had it before, so we don't need to care about that now. We've got one column missing, and that's because that column comes from a different space. So finally, we get the third candidate, and that is our paint time for the table. That's what we care about, and that's what we can now time and then send off. Anyone? I know there's a lot of newcomers, because I saw that yesterday, but anyone who's here last year? Yeah, and Harry already mentioned it, we had time to first tweet. And the thing is, so yeah, Mark Zeman from SpeedCurve was talking about this and saying, hypothetically, somebody from X or Twitter or, if you're watching this back in 6 months, Blue Sky, anyone who wanted to time a tweet, they want to be able to time a tweet and say that's how long it took, not this is how long LCP was or this is how long, as Harry said yesterday, we don't want to be talking about TTFB to someone, to your boss. We just want to say, this is how long a tweet took. So I tried it out. I took container timing out of a terminal, and yeah, I put it onto a tweet, see what it would look like, give it a go. Yeah, I didn't want to use Mark Zeman's Twitter account. I thought that wouldn't be very fair, so I used my boss, Rob Palmer. I have slowed this down a bit. This is CPU slowed down a bit, so bear with it. But here we go. Right, just can try and run this. Let's see how we go. And there we go. We've got Rob Palmer's Twitter account, and there we go. We've got the whole tweet that has been timed, and we get some performance entries on the side. And we can actually go into them and see the information in detail. And yeah, we can get the size and everything we need, and we can get the time of that tweet. So I'm not going to say the time on here because I've slowed the CPU down, but we can now get the information you need. Thank you. If you're interested, there is a living explainer on GitHub. It's open. Anyone can have a look. Anyone can give feedback. There is a polyfill. There is an implementation that you can try out. And we're also trying to work on a Chromium extension so you can just actually pull that in and actually see exactly where, how well it works on containers. So please, please, please let me know. And yeah, just in conclusion, yeah, it's been great embedding the web. Some of the stuff that Paul has shown you, I think we've definitely had a good win with that, and I think the web benefits as well, just as much as we have. It's been good being part of the web community. Nothing's more rewarding than saying to people, we have this issue. I know the terminal's a bit different to your conventional web page, but here's the issue that we have. And then people in the web and this community here saying, yeah, we have that problem as well. Maybe we can work on that. And same in the Web Perf working group. So that's been fantastic. And actually, I implore everyone here, if you're not already involved, please get involved. The W3C operate in the open, and so do TC39 as well. It's been fantastic to be here and to talk to you all. And yeah, thanks for listening. Also thanks for Paul as well. Thank you.
Thank you, Paul and Jason. Come have a seat. Wow, that was amazing. Here, let me sit right there.
You sit in here.
Yeah. I need to be able to see PBK so he can tell me if I'm going over. Well, I don't know about you, but I am super excited about container timing. We actually were just at the Web Perf days talking about how we could have better RUM for spas and for soft navigations, and I see using container timing to figure out when I open my overlay and it's a spa interaction and I want to see how long it takes for my overlay to render. That could be super, super useful. So thank you so much for bringing that to the web.
Yeah, thank you for having us.
Yeah. So one question that was asked, which I think you sort of touched on already, which is that, you have all of this really cool performance profiling tooling. What do you think it would take to actually get that into the browser?
That's a very good question. It's not that complicated. So I actually think, collaboration is the way to do it. But I kind of feel some of that instrumentation, it may well be that actually DevTools has some of that already, we just don't know about it. So we'd love to talk to you folks about what can be always on. But sure, we'd be very happy to sort of share our experiences of what we've done and see whether that could be used at lower level. It may well be that the Chromium code base already has super fast instrumentation. It must do, right? So maybe we don't even need what we have, but it's just surfacing that data is the way forward.
Nice. So it's really wonderful that Bloomberg as a company has really embraced the standards process and embraced giving back to the community. What advice would you give to someone who wants to go back to their job and say, hey, I really think that we should start participating in this process. I think we should start funding features. What would you say to them would make a good case for their boss when they get back to work?
I would say convincing your boss that, you're not the only expert. There's a wealth of expertise outside that have, as Jason has said, has probably run into very similar issues or challenges, and actually being able to solve those problems together is far better and is going to be good for the business. Mm-hmm.
Yeah, I completely agree. I'm very lucky to have a culture that embrace the web and open standards here. I've been in other places where it's been a bit harder, and I guess in those places I'd say we try to take some baby steps and just see what sort of things sometimes it's even just saying, it can be as simple as saying, hey, maybe we should spend a Friday going through some open issues, and then having a discussion about them just with our team. And that doesn't, there's no cost to that. And that's something I've seen places that have just started from that, and then you can grow and grow, and then you can start feeding back, and then that starts to bubble up, and then you can build a culture like that.
Wonderful, yeah. The RUM community working group is also free. Free to join. All right, well, thank you so much, Paul and Jason. Yeah. Thank you for coming.
Thank you for having us.
Thank you. Yes, that was so fascinating. All right. Next up, we have Daniel Rowe. Daniel, I spent a lot of time talking to Daniel on the speakers cruise because he has led the most fascinating life. When you see him at the break, ask him about the Chinese television program that he was an actor on when he was a kid. And then he went to school and he was a vicar, so like a minister in Britain for a while. And then somehow that propelled him into open source. And he opened a consultancy, and now he leads the Nuxt core team. And he's here today to talk to us about bundling strategies. So it's going to be super interesting. Thank you.
Thanks. I wasn't paying attention. Was that any of that true? I'm not sure it was. It's a pleasure to be here. It's a real honor. And I'm going to talk about unpacking bundling. And I hope I am. We'll see how we go. My name is Daniel Rowe. I am an American living in the UK, in Scotland. and I'm a full-time open source maintainer. I basically get to do my hobby full-time, which is amazing. I'm supported by sponsors. And the slides might need to come up on screen. OK. You also missed out. I'm going to go back. I'm sorry if that offends anyone. But this was my opening slide. And I feel the cat deserves some love. It's not actually my cat. I'll show you my cat in a moment. But I'm a full-time open sourcerer. I don't know. I think we're all magicians in the web space. That's why I love it. You can make anything happen, if you can imagine it. So I'm an open sourcerer as well. I lead the team building Nuxt, which is a framework for building web apps. I'm on the team of Nitro, which is a framework for building servers, which we actually built as part of Nuxt, and is now it is a separate project now, which powers things like Solid Start, Handstack Start, Analog, which is an Angular meta framework, and hopefully others. I have a few other projects you might want to check out, like pagespeed.dev, which I was told by someone. I was told by someone it was the fastest client for Core Web Vitals they had ever seen. We're on the Google team, and I won't name names. And that is basically me nerd sniping you to go find out why it is slow and tell me later. And a few other things. This is my cat, Barley. And this is where I normally stand and work. I have got my coffee or tea, depending on the time of day. And Barley basically stops me from doing any work as much as possible. I mean, can I get a show of hands for how many people here have actually had to choose what you are working on based on the presence of a pet? I'm sorry, I can't code right now. The keyboard is off limits. I can read PRs. I can think. I cannot type. It's very real, a very real thing. Now, basically, I think it's an important thing before giving a talk that any speaker needs to be appropriately humiliated. Well, maybe not any speaker, but it's probably useful for me. So if you could just tell me whether or not you've used Nuxt, that would be a lovely thing. I would love to know that. I'm surprised. 17. Maybe that's because it really needed to be optimized. Actually, I also want to just highlight how intelligent I am. I've put the choices here as yes and not yet. I thought that might go unnoticed unless I pointed it out. That was a self-deprecating joke, just to be clear. I'm not actually saying. OK, thank you for letting me know. This, by the way, is so much fun, isn't it, to build stuff with the web? This is a few lines of code in my slides, which it connects each of these components to a WebSocket server. And when you go to the QR code, which is a library written by Anthony Fu, it redirects to my website, which sends a HTTP request to the WebSocket server, which updates my slides. Isn't that amazing? Anyway, I can't quite get over the fact that almost anything can happen, right? Nuxt. I'm not talking about Nuxt, but just to give you an idea about where I'm coming from. So Nuxt, this is our aspiration. We aim to be a progressive framework. The idea that you can start easily and it takes you as far into the depths of complexity as you want to go. So you can get best practice built in, and you can customize it and add your own implementation if you need to. Now, a lot of what makes Nuxt unique is the fact that it is community-driven. So it was started one day after Next.js was released in October 2016. It was totally rewritten. We totally rewrote it for version 3 in July 2020 we started work on. And now we're just on the verge of releasing version 4. And most of what makes Nuxt is that it comes from the community. We don't have, as I said, a VC-funded company backing us. We are directed by members of the community. I happen to lead the team, but that's not a sort of imposition of will. That is a case of recognizing what people are doing and hopefully aiding and helping with that. We have downloads on NPM, if I'm allowed to mention that. And we have some numbers of stars, but honestly what I'm more excited about is the fact that we have quite a lot of contributors and people who are helping build Nuxt, which is something I believe in. The building of Nuxt, as well as the fact that it's a group project. It's the joy of open source, right? That you can do things together with other people that are more powerful and impactful than if you were one person doing it on your own. Now, it will not have escaped your notice that I represent someone from the JavaScript world. And in particular, not just from the JavaScript world, from the UI rendering library world, not just from the UI rendering library world, but from the meta framework world. And so I am looking around for Alex Russell, and I cannot see him, which is probably a good thing. Because I want to say, well, actually, I don't want to say this exactly. I want to say that JavaScript is useful. And I hope that that would be something we could agree on. Because I guess, like many of us, I believe in a tree, that you have things that can be static, should be static, things that should be server rendered, that can be server rendered, should be server rendered, things that can't be, can be left to the client. And the same with HTML, CSS, and JavaScript. Things that can be done in HTML should be done in HTML. Things that can be done in CSS should be done in CSS. And things that need to be done in JavaScript should be done in JavaScript. And that kind of waterfall, I think, applies in a lot of different areas in web development. And just substitute your order of priority in terms of what you pick. I'm going to talk. Actually, I almost forgot about that. I should actually talk about what I want to talk about, which is I'm going to talk about 8 different ways that we are working in the bundler space to improve performance, and which I think might be relevant for all of us. Not in the sense of we've got it nailed and we should all do this, but here's what we're exploring. Because, if I could say something about frameworks, frameworks exist because there's a need. Because there's some kind of problem space, people are struggling to do something, or they're doing the same thing lots of times, and there is an opportunity to bring best practice in a scalable way to a lot of people, or there's an opportunity to improve people's experience, both at the developer and the user experience level, in a very profound way. Now, when those needs go away, the framework has to change and adapt, because the enemy of performance is not framework or UI library. The enemy is human behavior, and in particular the human behavior not to adapt and change. So the desire to remain doing the same thing we've always done is the enemy. And frameworks that do not adopt a change mentality and an opportunity to grow will inevitably fall into the category of holding back the advance of the web. But that's not the kind of framework I want to be, and I hope it's not the kind of programmer, developer, consultant that any of us want to be. We want to be people who learn from our mistakes, who are constantly iterating, experimenting, testing hypotheses, and getting better. And so here are some ways we are testing hypotheses. I hope people will come to me later or drop me a DM and tell me why I'm wrong on some of these, because I hope I don't want to be sensitive about that. I hope none of us would want to be, right? When our hypothesis is proven wrong, that's useful data. But I also want to suggest that there are opportunities that we are simply not exploring from the bundler and framework side to actually bring about web performance improvements on a scale that none of us can individually achieve. And actually, that's one of the things I'm most enjoying about this conference, taking notes and hopefully going away and bringing some of what I've heard from the stage and from people I've talked to back to the framework I maintain. So here is the bundle of your app. Except I want to challenge that. You might think that I'm going to be talking about splitting chunks of your bundle, which I totally could, because it's a really useful skill to look at your bundle analysis and figure out that there's a lot that's not used here, and let's see if we can move that there. But I actually want to expand the scope of what a bundler can do and think about to not that one line of JavaScript, but the entire document that's being rendered. And this is probably because I'm coming from a framework point of view. And actually, before that, I had a small software as a service startup. I'm coming from a pragmatic background, and I think that the opportunity we have is to integrate with bundlers in a way that transforms the entire application. So here are some of the things we're doing. Here's the first one: style inlining. Now, there are lots of reasons you might have to inline styles. Probably you don't have any reason in the case where you have a single style sheet. There's a pro and con, right? So a style sheet can be cached. On the other hand, it delays slightly the browser's ability to process what's inside that style sheet. When you have lots of style sheets, not 3, but 10, which can happen when you have lots of components used on a page, each of which, for example, might bring their own style sheet. It starts becoming a waste of network resources for each one of these things to be initiating its own additional network request at this point in the page and actually initiating a fresh request. And you can improve that by moving it into the headers, but still it's a delay, and it can create a waterfall. This is a Vue component. And this Vue component is an extremely simple one. By the way, I love Vue partly because it does prioritize the languages of the web. So you have something which looks like HTML and should be valid HTML, and something which looks like CSS and is CSS, and something you can also add a script element, which is JavaScript. And so this gets rendered by the Vue compiler. I'm talking about Vue, but this also applies, and I've implemented as a proof of concept in React as well. So if you're interested in style inlining and you want to explore this in the React world, please let me know. I'd happily share my code or create a library if that would be useful to you. But when Vue renders that component, it embeds some metadata about the file it comes from and the chunk that it will be part of in the build. So this source file becomes the __ file part of this single file component. And when the chunks of the build, by the way, if it doesn't, if like the internals of me talking about chunks becomes too boring for a while, just think of a cat. But this we can match up when we are processing the chunks of the build. We can say, okay, in this chunk we have these source files. And when this chunk is rendered, we can match that up with some information from the chunk. And so as part of the build output, we get this manifest, which matches the resources to the chunks in the source files. And we also inject with our bundler now in this case this is done by the Vue compiler, but it can also be done by a bundler as well. We inject a registration point. So when this component is rendered, it injects the same ID into a set, which is attached to the rendering context on the server. I should have said that. And that means that after we finish rendering the HTML for the page, we have a list of every component that has been rendered into that HTML. which means we can actually track back and find all of the CSS that matches that component. Now, the benefit of the way it's been done here is we can actually extract as strings the CSS from every component into a map, which maps the source file to an import that will resolve to CSS at runtime. And then our renderer it can just map that across and actually render it out. So we get something that takes this list of CSS files and replaces the CSS files, which are effectively would be dynamically associated with components on that page, with inline CSS that is directly relevant to those components. And this, we think, this kind of thing is not straightforward. You can put too much CSS in the HTML. It's not cacheable. It's part of the document, so you run the danger of inflating the document size. But we think it's a good trade-off for the components that would be not global CSS, but the components that can be dynamically imported and are part of a render. And we do that in Nuxt already. It's not a capability in Vue itself, but I have also implemented it in React if you're interested. And I think it would be trivial to implement in most other server-rendered UI libraries. That's our first thing. Oh. How did he get here? He's constantly showing up. So the second problem was INP, which we all were made sadder by the introduction of INP as a core web vital, or far from it actually. INP revealed the sadness that already existed, as we heard just 2 talks ago. The fact that people were experiencing slowness. And we had a very interesting, and this Rick actually tweeted a few months before coming in, sort of calling out the framework. See, with this image, he said, come on, get going. We need to improve the INP. And we actually had a user, some users raise the point, a very paradoxical point with Nuxt, that they were seeing a real INP slowdown in the most performant build of our app, of a Nuxt website. Now, let me tell you something about one of the things we do. We offer a full static build. This is similar in some ways to, I think, what Next.js does, in that we can extract data that's dynamic at build time. So for example, imagine you are creating a UI that displays a list of GitHub repos and maybe some metadata for each one, and maybe even the contents of the README file for every Git repo. Now that is going to be a lot of network requests. And so if you want to do that at runtime, you're going to be building a backend, you're going to be optimizing it, you're going to be dealing with caching. You can also do this at build time and basically take all of that data. And if you need it to be interactive, you can create this payload of data. And so we actually serialize it in JSON into something which is a payload.json. It's serialized. It looks like this. It uses a library called dvalue from Rich Harris. And basically this kind of thing, the numbers refer to other keys, and the strings refer to a way of deserializing the data. So we can deserialize very rich data. So we can recreate dates, we can actually create components, deserialized components and lots of things. And basically that kind of data turns into this kind of dynamic object. That's just by the by. The problem is, this is the weird thing. Can anyone tell me why in our static build, where we are not performing data fetching, we had a higher INP than our runtime server site, where people were clicking a button and waiting for who knows how long for the data to come back from an API. That was much slower. People would click the button, they would wait for a second, 2 seconds to get to the next page. Surely that would be worse. Whereas with this, they were clicking and they were getting there within 50 milliseconds, but the INP was worse. Why? It was synchronous. Exactly, because we actually prefetched the payloads. We had them ready to go. We were going as we wanted to have as performant a website as we possibly could. And so what we were able to do is actually inject into our build a hack. Not a hack. We actually built in the opportunity for the browser to respond to user action. So the actual click the button can, or the link can now get the focus, or whatever the browser needs to do, whatever paint has to happen, can happen. And we're able to do that by integrating with the bundler to detect the kind of, so we only do this, for example, if a page has been pre-rendered. That was something that wasn't intuitive to me. That's probably why I should come to more of these conferences. And there are more opportunities to do the same. But that was one that we didn't expect. Here's another. Mandy gave a great talk earlier, so this probably won't come as any surprise. But if you have, and I chose to pick her font, if you have a web font that loads, it can obviously create cumulative layout shift like this. And we've actually built something that enables almost not all, a lot of what Mandy talked about to be done at build time, in fact, as part of the bundling process. So we can get the benefit of this. So these are metrics just generated by Nuxt as part of the build process, to mean that when you're using a custom web font, you don't experience the CLS penalty that you might otherwise experience. So there's some problems that we would, I would say, exist in the custom web font space, and I won't go into them because Mandy's covered them so well. This is what we do at a bundler level. We take that component, and it can be a component, or it can just be ambient CSS or anything. It can even be in a CSS variable. If someone references a font family, we will generate a font face for it. And we created a library called Unifont, which is abstracted, works in any framework, which allows unified access to web font APIs from Adobe to Google Icons to Bunny to FontSource to FontShare, and allows you to create your own custom ones, which you can use. But I would really like it if you would submit a PR and add the font CDN to the library. But it basically allows, we query these providers to find one which matches the font, if one exists. And if it does, we can actually directly render the data from that font CDN in the CSS file. So we don't need to add a link to an external file. We can actually transform it so it's actually part of the user's CSS. What's more, in the background, in development mode, we create a proxy so that when this hash is queried, _fonts hash, it actually pulls down from the font CDN. And when you build your app, it includes it as part of your app. So you don't have third-party connections. You don't have the need to face any potential privacy issues. We thought that was quite a useful thing to be able to do. And we also control, therefore, how many different weights are included, or if variable fonts are required, that can also be configured. So all of this most of this is zero config. So all of this just happens. The moment you use Oswald in the CSS, this occurs. But then we also notice what the fallback is. So if it's sans serif or a particular font, we then go a little bit further than just size adjust and create a custom one-to-one mapping between those two font metrics to generate something which should, as much as possible, map the size of the fallback font to the font that you're using, the custom web font. And so that actually means that you should get the experience I showed you a moment ago that was created with Nuxt fonts, again, with the user not having to do anything at all, the developer not having to do anything at all. Obviously, it works with custom providers. You can also do exactly the same thing just by dragging a font file into your public directory in the project, which means that there are lots of people who don't need to listen to Mandy's talk. Actually, they should still listen to Mandy's talk, because there's much more there. But it's a way of rolling out these performance insights and these capabilities into absolutely every developer who uses it, without them having to be an expert or know anything about how to calculate these font overrides. And also, when they change their usage or they delete the font, the CSS that's been generated is up to date. It's no legacy code left in their app. I was pretty happy about that. Here's something I built just a couple of weeks ago, which is why it's marked as experimental. As part of the build for Nuxt in particular, but this is true of any framework which has asynchronous processing, particularly asynchronous processing which doesn't always have to run. So we have the concept of async data. which this is the data which gets put into that payload I talked about earlier, and cached and prefetched. So it's available. So the link is on the page. We can either prefetch on visibility or we can prefetch on interaction, like hovering or clicking. And we can, and so the data is there the moment the mouse lets go, or the enter button is pressed, or whatever. So the, but this is run at generate time. So actually, none of the code required to perform that fetch, and it might not be a fetch, it might also be a complex data processing. It might be some kind of syntax highlighting. Heaven forbid, please don't put that in your client-side code. It's much better off in a server component or something like that, but people are doing it in their client-side code, and this is being included in their bundle for a zero likelihood situation. Not totally zero. They can manually refresh it. They might have a preview mode or something like that where they want a developer to be able to go in and see the most up-to-date data. So what we were able to do is perform this kind of transform. So this is what happens normally when Vue compiles the app, but this is more human readable. It sticks it in a component. There's a setup function which gets called, and inside the setup function we perform this step. And use async data in a static site doesn't call the function. It just returns the data. So why not extract the whole function into a separate file, which can be dynamically imported? This means at build time, it becomes a different chunk. And it means if you never call it, that chunk never gets loaded by the browser, never gets prefetched. It's just, as far as the user is concerned, as far as the user's browser is concerned, it's not part of the build. And so we're able to do exactly that. And this, it's experimental, but it will be going into next versions of Nuxt when users are creating static sites, because I think there's very little downside to it. Testing on one particularly bad website, we saw a decrease of 39% of total JavaScript and a decrease of 66% of the unused JavaScript on the website. I am going to take the anti-JavaScript JavaScript club sticker for that, if nothing else. You are very kind. That's not all. We heard earlier today about how, well, not just today. I mean, even the unconference before, we were talking about the pain of third-party scripts and how they decrease responsiveness. It's one of the biggest problems in evaluating web performance. For example, I want to look at HTTP archive data and see how Nuxt websites are improving based on, or not improving, hopefully they're improving, based on new releases and performance improvements that we're shipping into the framework. But a lot of the data is muddied by the fact that I think the worst offenders in terms of site responsiveness seem to be third-party scripts. So we have some solutions for that. We recently released a Nuxt scripts integration, which does a number of things. It has built-in facade components, which are faster in synthetic testing. I don't have real-world data yet. It's too recent, but and it has functionality that we hope will enable users to replace things like Tag Manager with just the built-in capabilities of the framework, to load scripts on cookie consent, or manually trigger them only when required. It takes care of everything that users need, like adding pre-connect headers and integrity and so on. And we advise users not, actually, there might be, we advise users not to use Tag Manager, but. So there's some things that it can do, but particularly, I'm not here to talk about those. Bundling. We actually enable users to bundle scripts that they're using and actually take and optimize scripts from the third-party providers. This obviously doesn't work with all of them. Some require a particular origin, but we can actually bundle quite a lot of them. And so simply by setting bundle to true, the script will be downloaded at build time, made part of the build, and there will be no third-party request made at all in order to get the script working on the user's site. It will be included, again, a hash in the _scripts directory, and we even have plans to make remote code part of the actual build itself, so we can tree shake it and do other things like that. For example, when third-party scripts include polyfills that are not required by the user's target build of their website. Here's another one. This wasn't working one day before I set off for the conference, and it is now working. So I'm going to tell you about it. And otherwise, it would have been 7 things I was telling you about. So, by the way, this also, it's totally possible it's just me. And I'm just, so if you're using a bundler that produces a lot of chunks, such as roll-up, Vite-based builds are often this is the case, but not only. You can find that a lot of bundlers can produce a lot of chunks, particularly as your site increases in size. There are multiple dynamic imports, multiple routes, which are normally code split, and then components and things that are shared across those routes can often end up as chunks on their own. And you can end up with something awful like this, where the moment you load this page, it starts downloading lots and lots and lots and lots of different files, because they're all going to be used in the first entry chunk. And so why not get started downloading them soon? And this kind of thing is terrible for performance. It can, at the worst case scenario, it can max out the request limit. And even at the best case, it's going to slow everything down. And it's a pain. So we can actually fix that. So we can, at a combination of bundle and a runtime, but running at build time, so in a pre-render phase, take all of those chunks out and use rollup at runtime, not really at runtime, to rebundle them based on the particular route that's being pre-rendered, knowing the components that will be required for that render, because remember, we keep track. We have a list of every component that's being used. We know every chunk that's going to be required on the client side, and we can actually smush them, that is a technical term in the bundler world, into one file which re-exports namespaces from each of the chunks. And then we can create an import map to remap each of those chunks to that single chunk. I feel like I've said chunk a lot. Are you with me? I think this is pretty cool, because it basically takes exactly the same code that's going to run in the user's browser, but just cuts all of the network requests down into a single one. And it doesn't have any downside in terms of additional navigation. So there's no duplication in terms of reloading the same chunk again. That has a cost, which is that you lose the caching of that initial chunk if you were to come back and hard reload another page. But I think the benefit is worth it. But I mean, these are all experiments, right? If I get off the stage and you come over and say, tap me on the shoulder, take me to one side and say, Daniel, you're not welcome here next year, because that was a terrible idea, that's fine. But I think it has potential for being quite a useful thing in the bundler world, and particularly where we are generating lots of stuff to create something that is just optimized for that initial request. Because after all, in a hybrid SSR and SPA app, the subsequent navigations are not going to be incurring this initial cost of loading all of those chunks. Oh, the import maps. I just want to say, did you know you can use data URIs in import maps? I did not. I discovered that. So you can actually have, you can just embed the string of the module that you want and actually override any arbitrary actual module that would be imported from the web. That's pretty cool, right? So that is, I base 64 encoded it because it's a bit shorter, but you can just URI encode it as well, and it would read, basically import a hash from this underscore thing, the rebundled, and then export the hash.default, export default hash.default. So it's just single re-exporting that particular namespace. Here's another project. I don't know if you know, maybe you probably do. Have you ever come across any of the libraries that I have scrolling across the screen in a marquee tag? No need for JavaScript for that. I really appreciate you, whoever that was in the back who laughed really loudly. So there are loads and loads of libraries in the ecosystem that exist to support particular features that didn't at one point exist in the language, but which totally are unnecessary now for most of us in most of the environments we are running in or creating code to run in. These things are all native. None of this needs a package, or any more than a package which re-exports a native utility. And so this is a bundler integration, unplugin, purge polyfills. Unplugin, who here has heard of Unplugin? Unplugin is a library we developed as part of building Nuxt, which is generic. We've created a whole ecosystem, by the way, a GitHub org called Un.js, which is full of libraries that are meant to be used by everyone. So in the Nuxt team, we're not particularly interested in building an empire of Nuxt. The whole fun of open source is doing stuff with other people. So, and any developer who becomes too attached to their tool loses track of what it is to be an artisan. The joy of building things is not the one tool, right? It's the fact that it's the you that's building them is able to exercise creativity and power to create something that achieves a purpose, right? That's the joy. But anyway, Unplugin is a tool which enables you to write bundlers, plugins, like I've been talking about all the way through the talk, that run in Webpack, RSPack, ESBuild, Rollup, Vite, Farm, and future bundlers yet to come. So it's an agnostic wrapper around bundlers, which makes me excited. And basically, if it detects any of these in your tree, it actually replaces them with a native language utility. So it's powered by the work done by a group called E18E, which is about E18N, which is about ecosystem cleanup and innovation. They have their own website. Check them out. They have a Discord server. They're all about getting rid of cruft in NPM package trees, all about modernizing and improving dependencies, about speeding up libraries and CLIs in the JavaScript tooling world. Wonderful. Definitely check it out. And there's a library, module replacements, which we use in Unplugin polyfills to make it possible to get rid of cruft and legacy code at the build stage. So it might not be a dependency you have, but for example, it would be possible to add Moment.js support to this, so we actually just swap it out at build time with something that does an equivalent thing, but using language features. That's totally possible. If you want to do it, I'd love a PR. Because we don't just have to say that these problems exist out there, we can actually fix them, and in a lot of ways, very real and profound ways, at the bundler level, until the ecosystem catches up. There's more. I do think it's important to skip JavaScript when it's not needed. And so since the release of Nuxt 3, we've supported a single flag for generating a multi-page app site with no JavaScript. But you can also do it on a much more granular level and say, these routes, these parts of the website should not have any JavaScript. These ones do, because they are going to be, I don't know, there could be a dashboard or something like that. And you can do the same in terms of certain bits should be static and certain bits should be server rendered, and certain bits should be cached and certain bits should be run at runtime. And certain bits should be server components. You just need to take a page and add a .server.view, and it will be processed by the bundler differently, and it will create static HTML with no runtime component. And you can even embed little islands of interactivity in these server pages and components, because I think we do need to reduce JavaScript usage if we can. So where next? We're releasing two new, I'm sorry, this is not about bundlers, but just very briefly. We're releasing two new modules, Nuxt Hints and Nuxt Accessibility. And Nuxt Hints aims to, in the next few months, Nuxt Hints aims to surface the kind of performance improvements that we've been talking about today. Stuff like your image doesn't have an explicit width and height. You should probably use the Nuxt component that will produce those for you based on your source image. Or your largest contentful paint in this dev server load was here, and it was at this time, and here's what the component you need to edit, and stuff like that. You lack a lang attribute on your HTML. You should really have a title for this page. I don't know, all the boring stuff that we require. And we also have an accessibility module, which will integrate with our DevTools and actually surface. Obviously, most of accessibility can't be automated, but we'll surface the parts of accessibility that we can reliably detect in an automated way, actually at not just at build time, which we can fail the build, but we can also surface that when the user is actually developing the site, so that it doesn't become this circle of build, 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 build. Oh, wait, let's check the performance testing tools. Why is it so bad? And then people try and make it as optimize as much as they can, try and fix the accessibility bugs. Actually, they probably don't get to the accessibility bugs. They're just the performance ones, and then ship it because they've run out of time. We don't want that to be the story of people using Nuxt. But the main thing is experimentation, because all of these things are only a hypothesis and a possible solution. We need data. And actually, really, we need continued conversation at the performance level, so that frameworks aren't innovating in a vacuum to try and solve problems in the wrong ways, but that we're hearing from performance experts who can tell us what the problems are and collaboratively seek to solve them in a way which will benefit not just a small proportion of users, but users who don't even know they're benefiting from the solutions we're deploying. If you're interested in Nuxt in particular, I would be delighted to hear from you. You can visit nuxt.com or find us on Blue Sky. There's a Discord server too. I should say I have an open diary. If anyone ever wants to chat to me, visit my website, ro.dev chat, and you can book it's only a 10-minute call, but feel free to book it totally freely. If you want to get involved in open source, maybe you're a consultant and you've been, you're an expert in lots of ways, but you would like to contribute back either to Nuxt or some other project, let me know. I would love to help. I can tell you about the open source perspective and whatever. Or maybe you just want to book a call to tell me that I should definitely do something differently, and I would love that as well. So do get in touch. And we probably have a time for a question or two, but it's been such a pleasure. Thank you so much for having me. It has been an honor.
Thank you so much, Daniel. That was wonderful. I hope you feel welcome here, because you're very welcome here.
I feel very welcome here. Thank you.
So we have a lot of questions, actually. People are very interested in this topic.
Is that why you told me I was welcome up front?
Yes. No, no, just kidding. Well, there is one vaguely spicy question that we can just get out of the way immediately, which is, why did you choose the name Nuxt, considering Next has kind of a negative association with it?
So there's so much to go in there. The first is that I didn't pick it. So I started open source in 2019, 3 years after Nuxt was created, and which I've loved. It's been an amazing journey, and basically just contributing back as much as I can until I was asked to be on the core team, and then I was asked to lead it. So it's been a fun journey. But I didn't create it. But I can tell you the name came from Vue versus React. So the U in Vue became the U in Nuxt, if the E in React became the E in Next. And in 2016, when Nuxt was created, none of the things that the web performance community might have been saying about meta frameworks were being said, I think. So I'm not sure there was much. I will say, at least one website has been built in Nuxt because the person who commissioned it had an Australian accent and asked for a Next website. And the agency heard Nuxt. So I'm going to say it was a very strategic move. And it's already paid off at least once.
I love it. So another question that was asked was about some of the other kind of frameworks and meta frameworks that are out there. It seems as though Nuxt is sort of heading in the same direction as frameworks like Astro, which are very much no JavaScript first with islands architecture. Whoop, whoop, islands. And yeah, folks are curious, like, what are your thoughts on that? It seems like you're kind of learning from each other in this space right now.
Yeah, I think with any ecosystem with established tooling and then rival or competitor tooling coming in, you see that either things, so sometimes new frameworks come in, bring an innovation that gets adopted, and sometimes adoption doesn't happen, and the existing dinosaurs perish. So there's different ways of happening. So I'm absolutely listening very carefully. I think I'm particularly inspired by some of the stuff from Quick. I'm really interested to see how that comes into Angular and starts being open source out of Wiz. So a lot of the ways Wiz, which is an internal, I'm sure everyone knows, an internal framework within Google, those innovations are coming into Angular. And I'm really looking forward to adopting some of those as well. And Astro takes the opposite approach to Nuxt, but we're approaching the same point. Right. So Astro takes the sort of static with islands of reactivity, and we take the idea of we always want a runtime by default, and we have islands of static inside there. So whether or not you think there should be a default runtime is the choice. But in terms of the level of that runtime, at the moment it's something like 90 kilobytes, including Nuxt and Vue and all of our dependencies. As in that's a minimal Nuxt website. But that's going to go down with the introduction of Vue Vapor, which is coming shortly, which will support Vue not having a runtime, and basically compiling to imperative DOM changes.
Sorry. No, I think that makes a lot of sense, and it kind of feels like there's this pendulum swing that's happened where everything was on the server, everything was on the client, and it's swinging back to somewhere in the middle where a lot of people are realizing that, totally on the server doesn't work for everything, totally on the client doesn't work for everything, and we need to have this kind of balanced approach. So I'm excited to see the ways that Nuxt is approaching that.
I would actually tweak that analogy, because I think often people think of it as a pendulum, but I think of it in terms of a yo-yo in the hands of a person walking up a flight of stairs. Because things appear to be going from pole to pole, but actually things are getting better consistently along the way. So we're not going back to a world where there is no JavaScript and everything is just server rendered. Like, we have the capacity to deliver sites that are more performant because they have that could deliver a better user experience because they have JavaScript, or they're using Vue transitions where they can, so they don't need to adopt. But we're better off than we were, is what I'm saying.
I agree. I like that tweak to it. Jason Grigsby had a question about the inline CSS for Nuxt. Does it take into consideration the positioning of the component on the page? Like, e.g., is it just an above the fold CSS, or does it look at the entire page?
It doesn't take into account the position of that element on the page. The trade-off is we don't know. We're operating with a limited amount of information, and in order to get better information, we would have to potentially do something which is non-performant on the server side, which is somehow render it. I would be up for doing something like marking an element with an HTML attribute that says, like, this is what we care about, so render this. And in fact, that's already possible right now manually. So the inline CSS feature can be enabled not just with a Boolean, but it can be enabled with a function which returns true or false as to whether a file should have the CSS extracted. So you can say, like, for my hero components, I want those, but I don't want other ones. So it's possible, but I mean, ideally, we'd like it to be less friction than that.
Yeah, makes sense. The next question, I think actually this is a really good one, because this is something that I've been thinking about a lot lately. Is so, right now there's really no standardized way to measure the performance of SPAs and to compare hard navigations versus soft navigations. And is that something that you, as a maintainer, do you have your own internal performance tooling that you rely on, or ways that you're managing, measuring, SPA navigation performance or advice that you can give to the community on what you think we might do?
from the point of view of core of some kind of Core Web Vitals or
Yeah,
Lighthouse
or
score,
or even, I mean, did Core Web Vitals even realistically map to a soft navigation?
It's so difficult, isn't it? But I mean, INP is not enough, because INP is just, there's now a response to the click. It doesn't mean that there's then like that the actual full navigation. And you know, some sites will. So there are of course ways of measuring these things, right? So you can have mutation observers, you can have performance measurements, and you can collect that data. It's very hard, obviously, in development. The conditions are very different from production. So most of the time when you're developing a site, the data you're seeing does not map to what is going to be the case in production. You know, Vite, for example, which is the bundler most Next users will be using, will be compiling on demand the page when the link is clicked. So, you know, it's very different.
Yeah.
But yeah, we're doing the best we can.
Yeah. It's like what Harry said yesterday.
I'm
The difference between development and production is a huge gap right now, and it's a huge problem.
I'm really keen to see better tooling in terms of being able to talk about the difference, because sometimes it's a lot of these things impact people's feel and how you like even things like the View Transitions API, native view transitions, make a huge difference in how people feel about a navigation, even when the navigation is actually technically slower.
It's the perception.
So it feels to them like it's smooth. And so it's a very difficult thing to measure, but.
Awesome. Well, thank you so much, Daniel. There were a couple of more questions that we don't have time for. So if your question didn't get answered, then please definitely come and find Daniel in the break, and you can ask him. So we're going to start our final coffee break. Yeah, what a great day we've had. Oh, and we still have 2 gold hoop earrings that were lost and don't match each other, so we can't really do anything with them after the fact. Okay, at 6 o'clock we'll start a bidding war for the earrings. No. Anyway, so yeah, go on, enjoy the coffee and the tea, and we will see you back here at 17:10, which is 5:10. I can't math anymore. All right, welcome back, everybody. Come on, don't forget the Tetris rule. Make your way down front, squeeze in, fill in spaces. Don't leave gaps. This is our last talk of the day, so we want everyone to have a place to sit and relax before the party starts. So our final speaker for Performance Now 2024 is the fabulous Annie Sullivan. Annie is responsible for the team that brought us Core Web Vitals. Woohoo, yeah. Thank you, Annie. Thank you, Annie's team. Annie has been working at Google for 20 years. She has seen some incredible changes in the web in that time. Like, could you imagine 20 years in one job? I could never. But anyways, I'm really excited to hear Annie's talk. I hope all of you are too. So give it up for Annie Sullivan.
Well, thanks so much. It's so great to be here with you all today. I've spent the better part of the last 25 years working on performance in one way or another, and being here, it just feels like home. So I'm so happy to be here. And when I got the invitation to talk, I really wanted to take a step back from the day-to-day and talk more about what I've learned over that time about how everybody can be a great performance engineer. But first, I just wanted to take a look back. This is the last talk of the day. I know there's some sad things we saw with excessive JavaScript and third parties, but overall, there's a lot to celebrate. So we had a blog post that launched kind of with Perf Now last year, and we calculated last year for the previous year, so 2023, how much time had Chrome users been saved along the Core Web Vitals, and that counts both changes that we made to Chrome to improve it, and also changes that all of you and many, many more people have made to websites and the platforms that websites are built on. And so that was almost 12,000 years in 2023. And that was super exciting and motivating. And so when I came back, I thought it would be great to update the number. I didn't think we'd be able to beat it, but actually we almost 3x'd it. We have saved 30,000 years of end user time in the last year. That's just absolutely momentous improvement in the day-to-day lives of millions of people. And thank you all so much. This is really, really cool. And I also made this slide. It's been around a lot, but I think what's really cool here too is that we have more time right now to spend on that performance equality gap, because dozens of countries are going green or greener as far as LCP and IMP. So this talk is called Aiming for the Stars. And my idea was to kind of talk about all the amazing performance work that I've seen in my 20 years at Google and my previous teams in video games, and really talk about what I think makes a great performance engineer. But I think one thing that I kind of want to balance when I was talking about this is that not everybody has the chances that we have at Google to just spend full time on performance, to go deep and spend years on an ecosystem effort. I know some of you are struggling even to get your companies to buy in at all. So I thought I would frame the talk around this idea of the North Star. We have a direction that we want to go, and we all try to aim in the same direction and figure out where we want to go. And even if we don't get all the way there, that's okay, because I think all the best work I've seen, including all of this amazing work on Core Web Vitals, has been iterative. And you can't iterate unless you have a direction. So I wanted to talk about some of those directions. I'm doing this in terms of North Star. North Star number 1, have a North Star. So the first thing you should do, if you haven't already, is choose a North Star. A North Star is an overarching goal, something that you might not be able to fully achieve, but that it's a really great vision for your product, for the user experience. So not we want to save X bytes of JavaScript, but more if we could wave a magic wand and make one thing about our product true from the user experience perspective, what will we do? So on our team, our North Star is that every site on the web has good Core Web Vitals. We think that North Star is part of a broader world where we have a thriving open web ecosystem. And that has really, really been a big deal for the Chrome team at Google. It has really helped us rally around a few straightforward metrics: largest contentful paint, cumulative layout shift, and interaction in next paint. Every time we launch a change, if we want to make a performance improvement, we launch it as an experiment, and we look at the impact on real users, and we understand, did it help their core web vitals? When people launch new features or changes that are not related to performance, we see, did it regress their core web vitals? And as we have the same North Star year after year, we get better and better, as you've seen, at making the web fast. And so I think I do want to say that, we are, on the one hand, we're making great progress. This is from Core Web Vitals Tech Report that Jason mentioned in his talk. You can just look at all websites, too. And you can see the pass rate on mobile of, the percentage of sites on mobile that are good, Core Web Vitals over time. And on the one hand, both on mobile and desktop, we've doubled it. But on the other hand, we're only halfway there. And that's OK. Your North Star doesn't have to be quite this lofty to have years and years and years of work towards it, but it should be something that you really aspire to. We have done our best to make Core Web Vitals a great North Star. It's supposed to be a good default. But I think you should really think carefully about your North Star. There's a few things you want to consider as you go through thinking about it. One is that, obviously, it represents the user experience. 2, for real users. 3, it should be rooted in business values. And 4, you should be pretty careful about the statistic you report on it. So first, representing the user experience. That's really, really important. Obviously, the user experience is what we all care about. And a really, really great lens for thinking about user experience is what's called a critical user journey. A critical user journey is just like the set of tasks a user goes through to complete a key task in your product. So for example, they go to the home page, they click product listing, and then they click a product and hopefully buy it. I think this is a really important concept to be thinking about as you're writing a North Star metric. What are the critical user journeys for your product? But if you think through this a little bit and you try to make a metric that represents this journey, a lot of things get mushed together, right? Page loads and interactions, and if you try to make it all just a big gob together metric, weird things like drop off in the journey could increase the metric. A lot of people, for a lot of reasons, not just performance, have come up with a way to break this down into the idea of a critical user interaction. And critical user interactions are just the steps in a critical user journey. Core Web Vitals measure critical user interactions. But if you think of them as part of your critical user journey, it could help you prioritize. Maybe instead of having the 75th percentile for all page loads, you would split up the home page, the product listing pages, and the add to cart page. Or maybe you would measure the add to cart and the buy now button at higher priority than the rest of the things that contribute to IMP. So sometimes your application is complex enough, and I think we've heard a lot about this over the last 2 days, that maybe the Core Web Vitals don't quite align with your own critical user interactions. We are measuring very specific critical user interaction, a page load, the first response to a user input, and the stability of the content. So what if you need to measure more? I think there's several things that you can consider. A lot of the different APIs from the Web Prep Working Group work really well here. When we were making LCP, we did anticipate that this was going to be an issue, and we implemented the element timing API at the same time. That'll give you the timing of anything that's contentful according to the largest contentful paint API. So anytime you're thinking about when did this show up on the screen and it's not quite a page load, that's a great go-to. I also would refer you to Jason's talk about the way that Bloomberg is extending this API with the container timing. We're really excited about that. Similarly, for event timing, you don't have to measure the IMP. You could measure any interaction. And you might think about which ones are more important to you. I also wanted to call out the long animation frames API here specifically. I know we've seen so much cool stuff from run providers about the long animation frames API and how it gives us attribution. It can tell us which scripts are slow, and it's even convinced third parties to fix stuff. That's all super cool. But taking a step back, what the long animation frames API does is it kind of models the event loop. And so if you're thinking about you want an application that's very smooth, you have like a lot of frames that you're producing, especially on the main thread. The long animation frame will give you every frame that takes more than 50 milliseconds. So you can see when things are choppy and not smooth. So that's one you should definitely look at. And there's tons and tons more APIs that you can put together. And one other thing you can do is stitch them together through the user timing marks and measures. That can get reported to RUM. It can get shown in tooling. Jack showed a super cool demo of how it looks in DevTools. So those are some things to be thinking about. But I did specifically especially call out element timing, container timing, event timing, because they measure when something is shown on the screen. And we do think that's really important to keep the focus on the user. All right, so now we probably have an idea of like what are critical user interactions and journeys. It's also super duper important to measure for real users. So the easiest way to do this, if you have the resources, is real user monitoring tools. They're amazing. There's tons of real user monitoring vendors here. They give you a dashboard that updates really fast, and you can slice and dice the data. It's fantastic. If you don't have that set up yet, a quick start is a Chrome User Experience Report. It's really fantastic at getting you an idea of what are your actual core vitals seen by end users. OK, but what if you're actually just making the site right now, or you don't have any traffic, you can't get RUM or Chrome User Experience Report? So I think the best thing to do is to think carefully about what your user base might be like, what would their devices and network connections be. Really try to get a low-end device, like a low-end Android or a netbook, and test your site out on that. But if not, you can fall back to the DevTools throttling. So here is an example of opening the DevTools and using the throttling. And you can see, like, I tried to make this page really slow by setting the throttling pretty high. And you can get an actual feel for, like, what is a 7-second page load actually feeling like. And no matter how much RUM data you have, how great your data collection is, I really encourage like each and every one of you to just try it, to see like what are your high percentile users and devices, to click on your site, and see how it actually feels. It's really important to have that empathy with end users. OK, another thing you should be thinking about, performance engineers don't define user experience in a vacuum. We're part of a business. And ideally, our metrics are rooted in business value. So Tammy mentioned this at her talk. She has an awesome blog post that I linked about how you can correlate your metrics to your your performance metrics to your business metrics. Getting aligned with the whole organization on what are the critical user journeys and the business metrics, I think, is really critical to getting buy-in across the organization and getting everyone swimming in the same direction, which has been a really key component of every successful performance project I've worked on. Finally, you want to choose a percentile. So what about the 75th percentile? Annie, didn't you just tell everyone in the world that they should use that? Yeah, so Core Web Vitals does use a 75th percentile. It's a good starting point. I want to take a step back and say, why does Core Web Vitals use a 75th percentile? So let's take another step back. What is a percentile? So it's at that percent of your users have that score or better. So at the 75th percentile, if it's 3 seconds, then 75% of your users have a score of 3 seconds or better. Obviously, like the higher the percentile, the more of your user base you're capturing. So one thing is that, like, how many percentiles should we show? For all of our tooling in Chrome, we choose to show 1 percentile, because people think it's really confusing to throw tons and tons of numbers at you. We don't want our dashboard to look like those really awesome Bloomberg ones that maybe not all of our customers are traders, right? So we toned it down. We just go 1 percentile. And one thing that was really critically important to us is to be inclusive of the smallest sites we possibly could. And if you're on the smaller end of our data set, like 1 user zooming into a subway tunnel as they load your site is going to kill your higher percentiles. So this is a trade-off. We have a number that represents most of your user base, but it also ignores outliers. But I think you should consider going higher with your percentile. We, on Chrome, so yeah, one stat that I was going to say is that like if you just Google like how many page loads does the top 10 websites have, you can understand really quickly that the 99th percentile for one of the top 10 websites is translating into like that experience is experienced by tens of millions of people every single day. So at Google, obviously we track the 99th percentile and we track it in Chrome. And I think you should really strongly consider it. We also did a study. We have had an argument, right? The 99th percentile users, they're zooming into a subway tunnel. They're slow, they're on bad devices, on bad networks. And so we actually did a study, and we found that it's not just one user group that experiences this terrible performance. It's a lot of people experiencing a little blip once in a while. And that's something that you should really care about, because in many, many products, a very slow experience can be a retention problem. Users will leave a product that's too slow if they can. OK, so how do you actually like go about deciding a percentile, and if your 99th is too noisy and whatnot? I highly recommend looking at histograms. One thing that's really, really cool, and where this data came from, is a Chrome user experience report actually has like full histograms in BigQuery of all of the site it reports on. And if you don't feel like being like me and doing a BigQuery collab, shout out to Treo. They have awesome histograms. But here's my BigQuery-based one, and it's 2 histograms, right? The blue is a desktop, and you can see like it's faster, right? It's got a peak at around 600, 700 milliseconds, and then it drops off pretty quickly. And then the yellow is the mobile. And you can see it has a pretty heavy tail. It drops off really slowly. And so the bars are 75th percentile overall and 95th percentile overall. So you can see for this data, like the 95th percentile really captures it a lot better than the 75th. But this isn't like a super popular site. The 99th is over there at like 12,500. It might not actually be worth it for this site to go all the way to 99th. Like 95th might be good. So looking at histograms can really give you a clue of like what you're measuring. And I'll just say, like, try looking at histograms and slicing and dicing them. This is an interesting one I found when I was just querying the data. You see there's like a little bit of a hump on the left and then a big hump on the right. This was called a bimodal distribution. And that's a hint that there's actually like 2 distributions here in your distribution of data, right? If you look at the navigation types in Crux, you'll see that the little hump is BF cache navigations. Tim gave a really awesome talk last year, Tim Vreek, about optimizing different parts of your site, and he recommended to like kind of split that out when you're optimizing. And I think this is something that I see a lot of people get confused about. Oh, let's split out BF cache, let's split out mobile and desktop, let's split out different countries. That is great for debugging and optimizing, and I think Harry used the word enabling metrics. But when you're talking about a North Star, you want as few as you can. And you just want to like really report like as best you can like what's the user experience. So recap. A North Star represents the user experience for real users. It's rooted in business value at a carefully chosen percentile. North Star number 2, understand the bottlenecks. OK, so I think this is one thing that I see over and over for great performance engineers is they dig in and they really understand like what is slow about their app and what can we do about it. And there's some really fantastic writing by Philip Walton and by Jeremy Wagner on IMP and LCP. Since that's pretty relevant to this group, I thought I'd kind of cover it to show you what we mean by bottlenecks, and especially like how a bottleneck works out in a browser. So here's the LCP breakdown. We call it the Walton breakdown after Philip. So the first part of the breakdown is the time to the first byte. You have to get a response from the server before you can do anything. And if that takes too long, the whole thing takes too long, right? And then this is called the resource load delay. So we have in purple some CSS files loading. And I think when I first started working on LCP, and I think what a lot of people think is like you have an HTML document, it has an image in it, and then the image displays. Not usually this simple. So most of the time, the image might be in a CSS file, or it's injected in a JavaScript. And one time, we actually found a page that was like a JavaScript file, loaded a JavaScript file, loaded a CSS, et cetera, like 6 hops before this image can start loading. And so if you think about resource load delay, that's trying to give you an idea of the bottleneck. So right now, we're waiting for these CSS files to load because they're on the critical rendering path. And only then do we start loading the image, which was in the CSS. Then, obviously, we have to wait for the image to load. But wait, there's more. All of this JavaScript that is running, when the image is loaded, the main thread is still busy in an event loop. And we have to wait for it to be not busy for it to display the largest contentful paint. So if there's a bunch of JavaScript running while it loads, we have to wait for that. And so we can see through this graph that there's a whole lot of potential bottlenecks that we'll want to understand and look for. And it's the same with IMP. Jeremy has written like really awesome articles about this, but I just added some new trace events to Chrome, so I'm going to ignore Jeremy's way better diagrams and go with mine. All right, so this is a click event handler. And before Core Vitals, I think a lot of people were thinking about the performance of their interactions in terms of the click event handler, which, you know, honestly makes a lot of sense, right? But the full interaction time is this. From the time the mouse is clicked, through the event handler, through a bunch of other stuff, until it finally gets presented to the screen. So what's the other stuff? We have a script that's already running, and it needs to finish before our click event handler can start. But then on the other side, we're part of an event loop. And the event loop always needs to run a request animation frame, style and layout, render, and resize observers before that animation frame can run. And so this is actually what the long animation frame API is meant to like kind of conceptualize, is these animation frames in the event loop that have to run. So it runs all the scripts, including the event handlers. Then it does the rendering style and layout. And then it also has to go to the compositor process, which is kind of not pictured. So you have to be able to think about all the different bottlenecks and not just your specific event handler. OK, so that's all well and good. Do you want me to go read the blog post and like dig into documentation, learn about the critical rendering path and the event loop? Like, that would be great. But you know what I think a lot of really, really fantastic performance engineers do is they learn to use the tools so that they can dig into this and understand it themselves. And I think it's the best way to learn about like how the browser works. Sorry, real quick. And when I talk about tools here, I want to kind of split it out. So a tool like Lighthouse that audits and tells you kind of like, what do you need to do? What's broken on your page and what should you fix? Those are amazing tools. They're fantastic. Paul gave a really convincing talk just yesterday about how almost any site could benefit from those. But like, what if you wanted to be like Paul and come up with these like things that are wrong that may not be in the tools? That's when you need to dig deeper and understand those bottlenecks. So one of the things that I see that are really, really common in tools, like if you go back, we have all of these boxes, right, that I'm showing, and they're called spans. And then we actually have these things called tracks. So we have a ton of tools that have spans and tracks, and Chrome DevTools is one of those. Jack gave like this amazing talk about how they're working really hard to simplify this down and focus things in here. But I want to take a step back and say, like, what if we don't know what to focus on yet? What if we have to dig into our own critical user interaction? Like, how do we even start? Because this is like very complex, right? And the reason it's complex is because it shows a lot of information. If they took some of this out, then you would be able to do less. So what do we do? How do we figure out how to get around in this thing which has so much information? First off, we break it down into tracks. The whole thing is just a series of tracks. So up at the top here, this is very, very common in a tool to have like a top-level track that helps you get your bearings. At the very top, it has a timeline for the whole trace, right? So it takes about, sorry, I can't see, almost 6 seconds, 5,500 seconds. So you can see, like, what is the whole thing? Then Jack talked about this more. We have these cool sliders that let you zoom in and out in different parts of it. And then, so we are zoomed in right now. if you look at, you can compare like the timestamps on the thumbnails to the timestamps on the left and right. It shows how, the bottom timeline shows how zoomed in we are. And then we have the main thread activity shown here. And this is pretty cool. It lets you like think about like what might you want to see, like probably those giant blocks of orange, or yellow. Those are JavaScripts. Those are interesting. I'm kind of curious, like what is that tiny mountain of green? But that kind of helps you find, like if you don't know what to look at. And then also there's a row of screenshots that you can hover over. So if you're looking for like a specific interaction or thing that's happening, you can use those. So all of this is about finding your bearings. Then there's the network panel. Again, it's got a ton of new features. It can show you like all sorts of cool stuff if you click and hover. This is a more detailed frames panel that can give you all sorts of information about the smoothness of animations, when did frames drop, and what was rendered when. This is a second animation panel that thinks of it in terms of like the animations as opposed to in terms of the frames. This is a really handy panel that will give you like so your user timings and your web vitals. The user timings panel, is that what it's called? Timings panel, yeah. And then the main thread track, I think, is where we want to focus a lot of our attention. So we've been talking about JavaScript. Is it good? Is it bad? Is it useful? This is where JavaScript runs in all of the yellow. But there's also other things that have to run on the main thread. Remember, I talked about that event loop and like CSS and Java and rendering, like the purple and green there too. So this is one of the tracks that we're going to spend a lot of time on. But first, I think it's really important to learn to navigate the panel. I think whenever I try a new tool like this, I just go in and like take a big trace and mess around, right? Like, what does the mouse wheel do in this tool? Like sometimes it zooms, sometimes it scrolls. What happens when you click on stuff? Most of the time you'll see a little box underneath it. What do the scroll bars do? The arrow keys. A lot of these tools, like, do you guys remember video games with WASD? A lot of these tools have WASD support. Check that out. And obviously use those sliders and all the amazing stuff that Jack talked about, of course, to find your place from the Insights panel. OK, then the next thing you want to do is just close everything you might not need, because there's so much information. And the reason that we have tracks is because we have too much information. Almost nobody uses all the tracks at once. So we just want to get rid of the stuff we're not interested in and focus on the rest. If you right-click on a track, you can actually close and reorder them. I think it's new, right, Jack? Yeah, it's pretty cool. They've been doing amazing work here. All right, leave yourself some signposts. This is the second part of getting around. So first, when you're first learning the tool, there's a couple things that I always do to make sure that I can understand like what the heck is going on. Harry was telling me he wasn't sure if the Chrome memory tool works, so he made an array that allocated like a ridiculous amount of memory, and then he could see it, and then he knew it was going to work. And same here, right? If you add, like here I just added a script with the 5-second busy loop, and I could definitely see like, OK, I've got a 5-second busy loop. I know where it is. I can find it in the tool. It does what I think. Another thing you can try is just a really short session. Like open the DevTools, click record, do something, click close, and like, can you find the thing that you did? Jack pointed out annotations. Those are super helpful as you're going from like just experimenting to like trying to actually navigate your way around a real trace. OK, but in the real world, we're not going to constantly add busy loops to our code. We actually want to debug it. And the best signpost that we can use to do that is user timing. So I think we all know how to add marks and measures. And Jack gave like a really, really great example of how to do that. But I can't emphasize this enough. If you do have like a place in your app where you're trying to debug this certain here to here, how helpful this can be, right? To just add a custom span and show it, right? It doesn't have to be like, Daniel added those really cool spans to view. It doesn't have to be like this production thing that everybody can use. It's a really great like one-up to the printf. So definitely try it. And also, if you press Control F in DevTools, you can find the spans that you added. And that's a really common pattern I see performance engineers do, like find the thing and scan through until you find the one that you want to look at. OK. So now we know how to use the tools, but how do we actually see the bottlenecks? So again, you want to mark off somehow, whether you already have an LCP or whether it's a custom user timing, the start and end of your critical user interactions. And then you want to find things, right, that are going wrong. And a couple of things that go wrong is very long bars, right, like things that take a really long time. Things that clearly happen in serial instead of in parallel. And also, sometimes when things are going wrong, it's a gap. So here's an example that's not like a really bad problem, but it just helps illustrate what Phil was saying about LCP. So we have this main thread, it's running, and then before we get our LCP, it just stops. It's completely blank. Nothing's happening. What's going on? That CSS file that we started loading is render blocking. So we can't actually keep going with the page until the CSS finishes. The reason there is, I don't know if you all heard of Flash of unstyled content, but if we styled the page and then the CSS loaded and then we restyled it, that's bad. So that's why CSS in the head is render blocking. And if you look at the timings, like, that's like, what, 10 milliseconds? It's not a problem, right? But it's just a good example of like when you can see like a gap and whether you expect it. Now I have an example of a long bar. So here, I didn't mention earlier, we also have an interactions track that can help you get your bearings on IMP. So this like dashed red line that's really long is a long keyboard interaction, 800 milliseconds. And then underneath that, you see this like super long bar. OK, but commit. Like, what's commit? OK, it's green. And then if you look at the bottom, green is painting. OK. Now we're like not sure what to do, right? Because it's just green, painting, commit. OK. The next thing you want to do is add your tracks back in, focus on this thing, and scroll up and down and see what else might be happening in the other tracks. And when you look, you get to the thread pool track. It's got some green bars, and then you expand it, and you see this. Image decode. And this is really cool. Number one, we know like this an image is a problem, but also it actually links the image here. So you can click on it, and if you do click on it, you get an image that's like, if this is my laptop, it's as big as this stage. And it was actually meant to be an icon. And I have seen that like recipe sites do this a lot too. So that's kind of a thing to know about, right? Like you learn as you go. But it's an example of finding a bottleneck that's a long bar. OK, so we found our bottlenecks. We're getting used to the tools. I think it's really cool. What's the next North Star? Oh, I forgot. Sometimes you have these gaps, and the whole DevTools just doesn't show you the gaps at all. Chrome also has its own tracing tool called Perfetto, which is like the IMP events that I was showing you. We also just launched this really cool thing where it can automatically collect traces on slow events while you're browsing. And then those can be loaded either in Perfetto or in DevTools. But in Perfetto, you have like tons of information. So if you need to dig deeper, Perfetto is where you go next. And it has the same tracks and overview and spans and everything. It's definitely like that model is worth getting used to. All right, now we're good at bottlenecks. North Star number 3, get awesome at experimenting. OK, so like I feel like I made it down pretty straightforward so far, right? You get a goal, you find the bottlenecks, you fix it, right? But I think if you're more experienced people in the audience are like, well, it's not that simple. A lot of times, so again, we want to improve things for real users, and real users they're crafty, right? They have different networks and devices. We've talked about that. But even though we just said what our user journey is, sometimes they do something else, all sorts of different things. And you're not ever really sure if you actually found the right bottleneck or if you actually found the right way to streamline it. So what do we do? The best performance engineers I know? Experiment. Oops, I forgot part. So what can we do? Oh, no, I was going to, sorry. All right, so the first experiment that I would encourage everyone to do early and often is just try ripping stuff out. Jason gave a really good talk about, and I think a couple other people mentioned, just ripping out the third parties. You can do that with web page test experiments. You can do that with DevTools. Oh, Jack mentioned it. You can do it in DevTools, block anything you want. You can also go and look at a bundle analyzer like Vue or any other bundle, look at things that might be weird, and try ripping them out. I think this, sometimes you get super lucky and you actually just didn't need the thing at all. Like Alex gave some examples. But maybe you do need it, right? And then ripping it out actually gives you a really solid timeline of like, is this actually a bottleneck, or is this just a thing that I don't want to load too many resources? Ripping things out helps you validate really quickly whether you found something that's important or whether you want to move on to something else. But once you have done this, you've identified the bottlenecks, you've experimented, pulled things out, messed with your app, you have a good idea of what you want to do, and you probably actually want to re-architect. You have some cool new component architecture that's going to make everything better. And the problem is that those things always kind of like take like 2 years, and then at the end of the 2 years, it found a lot of complexity that you didn't realize was there at first, but you had to add it all back in, and the performance is the same. So what do? Keep experimenting. Try to make as small and iterative a change as possible, and then just keep going around in a circle. Make a change. Focus on maybe just one part of your critical user interaction, of one example. Take out your cool idea, try it, measure it, and learn from it. Keep going around in a circle. OK, so I think one of the most critical parts of experimenting, and just one of the most difficult parts of performance work where you're really impacting real users, is actually knowing whether the experiment worked. It's just so hard, right? Users just do the darndest things. And you can't always be sure that the things worked out. What really brought this into focus for me was this really cool opportunity. I got to join one of the best front-end performance teams I've ever seen is about 15 years ago. I got to join Search front-end. And they measured their real user page load times at the 99th percentile. And they could identify at that 99th percentile pretty much all of the root causes of shifts up to 15 milliseconds for real users. And that was amazing. How did they do it? Everything that launches on Search launches as an experiment. If they had a performance optimization, they would run an experiment, get the data from real users, usually find out that it wasn't what they expected, tune it, and repeat. If they had a feature launch, they would run it as an experiment, and they would get the data. And if there's a regression, they would try to figure out what happened, or report that it's 15 milliseconds or whatever. And this was just super cool. And when I joined the Chrome team, I was one of a group of people that was really, really excited about the idea of bringing this to Chrome. And as part of a much larger group, I was able to help make this happen and help us get metrics like the core vitals that we run every experiment on. And this is just like, I just can't emphasize enough how big of a part of those improvements that I showed you at the beginning, being able to do these experiments well, is. And then I think this is the biggest disconnect that I see when I start to talk about this, is experimenting is really A/B testing. You have an experiment group and a control group, and you want to get the numbers for both. And A/B testing frameworks do that, right? But they do it by usually on the client, they inject some treatment, and then at layout shifts, it can be really slow. Isn't that bad, Annie? Yeah, that's why it took so long to get to get this working in Chrome, right? Is you actually want to have a server-side solution that does it all with really negligible performance impact. Right, we'll all go back to work on Monday and rate negligible performance impact experiment frameworks. OK, doesn't always work out, right? But I do have some ideas for you, and I think this is one thing where I would love to tag me in on Blue Sky. I would love to hear your ideas and your thoughts on what's worked for you. I know that a lot of A/B testing frameworks can work in edge functions. If you Google your platform and A/B testing, you'll probably find some interesting stuff. Tim Kadlec wrote this amazing article about, it was on Netlify, but about using a branch to split between traffic. And he actually went all the way through logging run data in speed curves, so you can get some screenshots of what that might look like, which is really, really helpful for just kind of working through what does this even look like. A really, really cool case study that I saw as well is Vodafone. They optimize their page, and they are using ads. They have landing pages. They just sent the optimization for one landing page and the non-optimized for the other, and they're able to show huge revenue impact in addition to the performance impact. So those are some of the ideas I have for solving that problem, but I would really love to work with you all on like how can we do it better. Which brings me to North Star number 4, contributing to the community. This is just such an amazing and awesome community, and I've seen so many people with so many great ideas, so much exciting stuff. I really love to see people contributing back. And so I had some ideas on how to do that. I think Daniel also mentioned the ecosystem performance effort. It's E18E because there's 18 letters between the E's. They're doing all sorts of really cool work to improve JS package performance. And I think like something that hopefully is clear is like if you optimize one of those packages that Daniel mentioned, right, that like tons and tons and tons of people use these packages, so like lots and lots and lots of websites will get faster. So that's a really cool thing to contribute to. I'd love to see people looking at these tooling gaps. Even if you don't feel like you can make your own open source tool, like blog about how you did it, make a video. I think I'd be really interested to see how people are solving that problem. Another thing that I think feels really intimidating, but it doesn't have to be that bad, is to actually like help out with the browser. There's people not only from Chrome here, but also from Firefox. And if you're interested in contributing, there's a couple ways that I think that, you know, if you don't have like C++ skills and you're feeling a little nervous about that stuff, if you just have front-end skills, there's a ton of stuff you can do. So Michael Mockney and I are working on soft navigations. I forgot to call that out too on the critical user interaction slide. That is the missing one in Core Web Vitals, and we are working on it. So if you're interested in that effort, come talk to me and Michael afterwards. But one thing that we can use help with is web platform tests. If you're not aware, the way that we know whether APIs work or not, especially in a cross-browser framework, is this thing called web platform tests. They're all HTML and JavaScript, and they just test whether the APIs do what they should. So that's a great way to contribute, and especially if you have ideas about something that may or may not be covered well by a soft navigation heuristic. Another thing, and I just actually want to go back, you know, like what, I think it's been 14 years ago, my very first changes to Chrome back in the WebKit days were to DevTools. I wanted right-click copy URL on the network panel. And what I learned from that is that it's just nowhere near as hard as you think it is. And it's Jack and team have made it 1,000,000 times easier today. DevTools is just JavaScript and HTML. You don't even have to build Chrome to contribute. It's really awesome. And go talk to Jack if you're interested. And finally, the thing that I absolutely wish everybody would do more is report issues. If you're able to file a bug with a reduced test case, that helps us out so much. And it can honestly, like, when people do file bugs and we tell them like what's going on, they seem like really relieved, like, oh, finally, I'm not crazy. This is happening. But also, I wanted to call back to Jason talking about how frustrating it is, right, to continue like tell the third parties get better. I wanted to give the other side of that, right? Like, yes, most of the time you tell a third party to get better and they don't. But like Erwin, I think you actually found one that got better, right? Malta did too. And we actually have had a ton of success recently. Gil put out a case study of a consent management provider that had improved cookie consent IMP. And I think now there's like about 12 of them that have improved IMP significantly. Taboola put out a case study after data came back from long animation frames that showed that Taboola was slow. Now that they have that metric, right, they used it to improve, and they're no longer like an issue. So that's really cool. We've seen some really cool impact in ads. So I think the upside of like, yes, most of the time you'll report the issue and you won't ever hear anything back, is that every once in a while you'll report the issue and then it'll get faster for like thousands or maybe even millions of websites like overnight. And that's really, really cool. And even though this can be really frustrating, I think that's a really important way to keep going. That's all I got.
Oh my goodness, you startled me. I wasn't ready.
Sorry.
Usually I have a good sense for that, but thank you so much, Annie. Okay. We really appreciate it. That was amazing. Everybody, let's give one last big hand for Annie. That was so good. Well, that's a wrap for performance.now 2024. I can't believe it's over. I don't know about the rest of you, but I have an extremely long list of things that I need to do on Monday when I get back to work. Hopefully first, though, I can get a little rest and get over this cold and get my voice back. If you see me later, I probably won't be able to talk to you, and it's not because I don't like you. So I want to say a big thank you also to our sponsors yet again. All the amazing things that we got today, Stroop waffles, heck yeah. So yeah, everybody give a hand to our sponsors, please. Thank you. We couldn't do it without them. All right, and with that, oh, he's still thinking. All right, you ready? All right, I'm going to hand this over to PPK.
Thank you. We have come a long way. I really feel like the start of the conference was like 2 or 3 weeks ago. I don't know about you. But I want to take this opportunity to thank a lot of people. First of all, the speakers and the MCs. So please come back on stage, all the speakers and the MCs. A conference is nothing without its speakers. We are very lucky that all the speakers who we asked to come say, yeah, that's kind of cool. So yeah, let's do performance now. Yeah, sure, why not? Then there's, let me see. Then there's Thijs, where's to go? Thijs, yeah. And Karlijn, where's Karlijn? Yeah, they could have already gone to beer, but he's not supposed to in any case. Oh wow, this is going really bad. Okay. Of course, I also want to say thank you to this marvelous venue that we've been holding our conferences in for 3 years now. We really like it. I mean, it's a classy venue. It's a church, a Protestant church, not a Catholic one. Very important distinction. And we like being here and like doing the religion of performance. And you like it as well because you come back year after year after year after year. So that's kind of cool. Thank you to the AV staff, mostly Jeroen, who's over there. Oh, damn it. Yeah. Okay. I don't know, it's gone well all the time and now it breaks. It doesn't understand. I don't know what's going on. Well, never mind. Can you switch back to my old slides, please? The thank you slides is not on there, but it doesn't really matter. I'm too bloody tired. There's one thing that can you open it? There's one thing I want to mention in particular, because it will be a last time. Karlijn, my co-organizer for many, many years, too many years, 13 years? 13 years? He is leaving the conference organization business, and that means that we are going to miss him dearly. He will probably be back next year, but purely as an attendee. He will walk around, you know, he will say, oh yeah, nice conference, yeah, nice conference. Oh yeah, no, I have nothing to do with it, no, but just a nice conference. That doesn't mean that performance now stops. We will continue with coming back here at 30th and 31st of October 2025. I have a slide for that. Could you? It's online. Great. You can subscribe to our mailing list if you want to be informed of the details. And now we're just going to have beer because I cannot talk anymore. Beers. Thank you. Bye.